Hello, this is Adam Bertram, and this is the course PowerShell and Active Directory Essentials. If you are new to PowerShell and trying to figure out a good way to create reports based on various Active Directory criteria, or you just want to learn some PowerShell, you come to the right place. Lucky for you, we're going to take you on a tour of PowerShell, all while applying your skills to Active Directory. As I mentioned, my name is Adam Bertram, and I love automation and PowerShell in particular. I do a lot of stuff, as you can see, and have more than enough street cred to take you on our A to Z journey on PowerShell and Active Directory, as you can see here. So the biggest question I receive when talking about PowerShell to different people is why? Why should I use PowerShell to do X? What if I already know Python, or Perl, or even Batch? What's the big deal about PowerShell anyway? Of course, every question is going to depend on the context, but in a nutshell, here are the few basic reasons I give everyone right off the bat. First, it's everywhere. If you've just heard of PowerShell and haven't used it much at all, you might know this. PowerShell is not VBScript or Batch. PowerShell is more like Python in a roundabout way. PowerShell can manipulate files, it can manipulate the registry of Windows machines, and a lot of other simple stuff like that. But it can also call REST APIs, work directly with Active Directory, hundreds of other non-Microsoft products, all while providing rich objects. Oh, did I mention it's now available on Linux and Mac OS as well? It's also intuitive. It was designed to be easy to learn in the familiar verb-noun syntax. What you see is what you get with PowerShell, and typically what you expect the command to do is what it does. No more guessing what this or that argument does. It can also automate just about anything you can think of. Other than being a console, it's a powerful automation language. Because of its ubiquitous presence and support for so many different platforms, you can implement a crazy IFTTT thing if you want, if you're familiar with that service. I've seen some scripts that pull data from an HR database, populate Active Directory, send users to SAP, build home folders, build Exchange mailboxes, and all kinds of other stuff. Since I've just convinced you to use PowerShell for all your daily needs, okay, well, maybe not yet, but I've still got some time. But you're probably coming to this course because you're a security guy or gal. Admittedly, I'm not that guy. I'm the automation guy, as in PowerShell. Automation is a general term and can be applied just about anywhere. PowerShell is a universal tool that can enumerate security policies in Active Directory, build Exchange mailboxes, control your sprinkler system, and even control your cloud environment. It doesn't really care where it gets applied. PowerShell is great at gathering all kinds of data and building reports. As you can see, the effort required to pull all users and computers from Active Directory is as easy as just doing it for one. If built right, your work is infinitely extensible. Do the work once and apply it across the board regardless of the number of objects. And finally, it's also popular in the InfoSec community for the reasons we're not here today. PowerShell is very popular in InfoSec because it's installed by default on all Windows operating systems and has hooks into all layers of the OS. This means a lot of fun hacking opportunities for you security guys and gals. But again, in this course, we're not going to focus on that. We're just going to focus on using PowerShell as an automation language. So, is this course right for you before you spend your valuable time going through it? Well, are you just getting started out with PowerShell? Have you used PowerShell for a little bit to create some super simple scripts but don't really understand how it all works? If so, you're in luck here. In this course, we're not only going to be working with Active Directory and PowerShell, but as I'm going along, I'm going to be breaking down PowerShell concepts and will ensure you understand everything before continuing on. So you've got a good handle on PowerShell already? Well, that's fine. You might want to skip over the next module, but stick around for the rest of the course. I'm not going to pull punches when getting in deep with Active Directory with PowerShell. If you finish this course, you're going to come away with some very useful skills. For one, you're going to understand PowerShell. Now, I'm not talking about just learning language constructs like operators, functions, modules, and what have you. That's useful, but you're going to learn how to apply this knowledge to a real-world scenario. This is the most valuable knowledge of all. You're going to come away with lots of other ways to apply the tactics you'll be learning here. You'll come away with a shiny new PowerShell tool that can be wielded a number of different ways in your daily lives. And finally, you're going to learn a lot about Active Directory concepts. You're going to get exposed to all kinds of different best practices in AD. We're not only going to just talk about them, but I'm then going to show you how to use PowerShell to implement them as well. This course is going to be laid out in modules. We're going to start off with just general PowerShell stuff and hone in on Active Directory. We'll start out with just getting used to some common PowerShell commands and then hop into applying your PowerShell skills to Active Directory. Once you've got a firm grip on PowerShell and how to handle it, I'm then going to show you how to use PowerShell to interact with AD. We'll then dive a little bit deeper into how to pull out various data from AD objects like users, computers, GPOs, and so on. Once you've learned how to interrogate various objects, we'll then take a step further and get into maintaining Active Directory health. This is using PowerShell to check for potential problems, reporting them, and even take a step further and fix them on the fly. And finally, we'll convert our rudimentary PowerShell console output and create some pretty reports. You'll get introduced to some of PowerShell's output commands and how it can be used to convert data into useful reports that even a non-technical manager can understand. And then finally, at the end, we'll kind of wrap it all up with a nice bow and provide you a nice summary of what we've covered. In this module, we're going to get right to it and get started coding with PowerShell. This module will be a great jumpstart for those of you who are brand new to PowerShell. We're going to focus on the basics here and attempt to give you a quick run through on everything you need to know to get your feet wet with PowerShell. PowerShell is both a shell and a scripting language. One of the first things you'll need to grasp is running commands. You'll do this with the PowerShell console, as you can see here. The PowerShell console is an interactive console that enables you to run various commands in real time. This means you don't have to execute a script separately. The PowerShell console is just like the old cmd.exe. All the commands that you're used to still work with the PowerShell console, like cd, dir, type, and all these other older DOS commands. Most of those aren't real commands in PowerShell, but aliases that Microsoft has put in to make the transition to using PowerShell as easy as possible. This also means that even those ancient batch files even still work. Although I'd be hard-pressed to recommend keeping those around, but really that should show you just how compatible the two are. So let's start running some commands now in the console to see what we can do. Alright, so it's time to really get into PowerShell now, and let's dive in and go for our first demo here. In this demo, let's just run some commands, get the feel for the console, and just kind of see what's going on with PowerShell. So whenever you're first started getting with the PowerShell, the first thing we need to do is open the PowerShell console. And to do that, I'm running Windows 8.1 here, but the process is exactly the same with Windows 10 or any of the other Windows Server versions. So I'll just go in here and I'll just type power, and you'll see that I have Windows PowerShell. So I'm just going to click on that, and then you'll see that PowerShell gets open. You'll notice that it looks exactly the same as the cmd.exe prompt that you're used to. There's things like CLS is still there. We still have commands like ping. So there's a server called DC on my network. We can ping. We can run commands like ipconfig. So exactly the same as cmd.exe. We can even do stuff like dir or any of the old style DOS commands. We can do any of that stuff still. In fact, in PowerShell, we can also run the command prompt from within PowerShell. So if we wanted to, I can go to the command prompt here, and now I am actually in the old school cmd.exe command prompt. So again, I'll run ipconfig, same exact scenario as before. But since I'm now in the command prompt, I can get out of that by typing exit. And you'll see that my prompt there turned back to PS instead of just the C colon. What can we do with PowerShell? Well, when you first get started, you really don't know what's possible with this new language. But PowerShell gives you some really good commands to do that. And the first one is called get command. And you can do that by typing get-command. And one thing that you'll soon realize with PowerShell is PowerShell has really good tab completion as well. So instead of typing out get command manually like that, I could just type out get dash and maybe CO. And then I can start hitting the tab key. And you can see that PowerShell knows all the commands available to me, and it automatically will start rotating through all of those. So you'll find that you'll use the command quite a bit. If you get lazy, you can even do git dash, and it'll start cycling through all of the commands that you have there. It's a really, really good time saver. So let's type git command here, and we'll see what that does. And you'll notice that this has a lot of different commands. It's flying through all of them now, but these are all the commands that are currently available to me in my current session. Now, there's a lot of those in here that are not going to be available to you off the top of the bat. So like in the AWS PowerShell stuff, the Google Cloud PowerShell stuff, these are modules, which we'll discuss later, that these commands are part of, which you will not have those available to you immediately. But one thing I wanted to show you is just the command structure. Notice that with git command here, you have git, which is a verb, and command, which is a noun. And if you look down through each of these commands, they all have the same general structure: update, dash, noun, unregister, test. So there's always going to be a verb, and then a dash, and then some kind of noun. And you can easily see what all the verbs and nouns are available to you with git command. So with git command is really, really flexible, and it allows you to see all the commands available to you and do some filtering and things like that with it. So let's say that I want to find all of the commands that start with the git verb. So with git command, I can do a dash, and then I'm adding a parameter onto git command. And because, again, I'm lazy, I don't want to actually figure out what this parameter is, I can just hit tab here, and I can tab through all of the different parameters that are available to me with git command. Since I want to find all of the commands that have the git verb, I can just do dash verb and then a space and type in git. Hit enter, and then all of those will be filtered only on the git verb. The same thing I can do with the noun. Git content is a good command, for example. So let's say I want to find all of the commands that have the noun of content. And you can see I can do add content, clear content, git, and set content. The git command is a very good discovery tool to use to really get in there and feel around and figure out what's available to you. So another thing I wanted to compare is if you are used to the command prompt and haven't used PowerShell very much at all, I wanted to kind of give you a general sense of what those two mean. Let's go to the command prompt by typing cmd here. So let's just change into a directory called example. We could just do cd c example. Let's say that I want to enumerate all the different files in there starting with foo. So I can do that with the command prompt, which is the old school batch way here. I can do that with the old school for loop. So if you're familiar with batch files, the for is just a way to loop through things and set iteration variables. If you're not familiar, you'll look at this like, what in the world does this thing do? You would have no idea what this thing does. It's not very intuitive. You're not going to really know what that thing does. Versus, let's do the same thing with PowerShell. Let's exit out of the command prompt here. Now we're back into PowerShell. Now PowerShell has a command called getChildItem. And getChildItem works similarly to the dir command on a lot of other different things. So getChildItem gets a listing of all the files and folders in a one or more directory. So if I just run getChildItem on the root of C here, you'll see that it just looks exactly like the dir command in DOS used to. So you have all of your different files and folders there. Now let's do the same thing we just did with the command prompt. I'll use getChildItem here again, and then I'll specify a path. So there's a path variable that I specify for the folder. And again, I will use cexample, and also notice that I can tab complete folders as well. That works with not only commands, but I can also tab complete folders and files as well. It knows that if you type c:/ that you are querying the file system. So let's go example here, and I'll type a tab here, and that'll be cexample. And then now getChildItem has a parameter called filter. And filter, what it does, well, what you would think it would filters the output that getChildItem is going to provide. I can provide this filter here and just do a foo star, so a foo and a wildcard. And I'll try this here and see what happens. Well, it looks like it did find all of the foo directories. That's great, but what if we had a file in the example folder here? So I can do that by, let's say that I'm going to create a file called foo.txt, and I'll do that. PowerShell also has a command called add content. So I'm going to add a file here called foo.txt, and I'll just put some kind of value in it, and that created the file. I'll run this again, and then let's say I only want directories that start with foo, not files as well. In the previous example, I wanted everything that started with a name. I technically did that just now with PowerShell, but let's say that I want just the directories. Well, you just do dash and then hit directory, and it filters that all out by directory. We can also do that with files as well. So let's say that I wanted to only do files. Well, I don't know what the parameter would be. Let's see what that looks like. So I'll hit dash, depth, force, name. None of these look file, all right? Just using the file parameter, I did not know that parameter offhand. I just tabbed through until I was able to find it. Then notice that it filtered on file. Now, compare this command with this command. Which one makes more sense to you? To me, the get child item specifying a path and the filter and the file is going to make a lot more sense than the old school command prompt way of doing things. You'll see that a lot in PowerShell. So the next thing I wanted to show you was that PowerShell has very, if not the same, very similar commands that the command prompt did. So for example, ping. In command prompt, you had ping, and then you specified the name of the host name. In PowerShell, obviously, we can still use ping, but you'll see that all the output that ping has is just one big string. What if, for example, we wanted to pull out something like this big IPv6 thing here? We would have to do a whole lot of string parsing and doing all kinds of crazy stuff to make that happen. PowerShell has a test connection command. And the test connection command can do the same thing. I can use test connection and then DC. And you'll see that it's formatted out with different headers here. So instead of just one big piece of string, you'll see that it has these different headers: source, destination, IPv4 address, and so on. These are actually properties in object. We're going to learn more about objects later, but just suffice it to say, if you have everything broken out in this way, pulling out this IPv6 address from this output is going to be significantly easier than doing it with the DOS way. Another really useful command is add content. And add content, as you saw earlier, creates a file or adds existing content to a file. So let's go ahead and I'm going to name one example.txt. So I'll just create a text file. With the value parameter, I'll put in there a few of my computer names. So I'll put in localhost to represent the machine that I'm on now, DC, which is my domain controller here, my lab network, and lab SQL. So I'll go ahead and add this. And then with the command prompt, you could have seen the contents of this with the type command. So I will do type and then C example.txt. And you'll see that looks like I already had it in here. So I added duplicates. So again, with command prompt, I could have used del, and I can use the same thing in PowerShell. So I will go ahead and delete this. And then using the up arrow a few times, I can search through the history. And then I'll do it again. And then you'll see that I can use type to get the contents of that file. But PowerShell has a much more powerful command called get content, which I went over earlier. Get content is exactly the same as type, but it's much more powerful. You see that on the surface, it looks like it's exactly the same. You don't think it's really doing anything different. But what you'll find is that each of these, the localhost, the DC, and the lab SQL, each of those are individual little objects with properties. Now again, if you're not familiar with objects and properties and all that, it's not going to make a whole lot of sense to you right now, but I'm just going to kind of give you the primer here to make you realize that these, with everything being objects, it's so much easier. To give you an example of that, so let's say that I'm going to do type. Well, okay, I want to only see the first line, for example. So let's say I only want to pull out localhost. Well, how would I do that in command prompt? Well, honestly, I don't know how to do that in command prompt because it's not intuitive. I'd probably have to do something like find string, or I don't really know how to do that because I would have to parse out that first line. However, just one tiny example of what PowerShell can do is with get content, that's an array. Each of those elements there is an array. Because of that, I can assign this a variable. So I'm going to assign this and say this is my computers. And then now my computers variable contains each of those. Now you may think, well, big deal, you just assign the output of get content. Well, let's just say I want to pull the first line. All I have to do is put it's indexed, 0 index, 1 index, 2 index. Okay, let's try the same thing with type here. Let's see if that works. Say this is CMD computers. CMD computers, and again, notice I can tab complete. It also tab completes variables as well. All right, so let's do 0 here, 1, 2. Now you may think, well, that actually works. Well, I'll show you why that works. So type is an example of an alias in PowerShell. I can look at aliases. PowerShell has aliases for a lot of the common things that you would run in CMD, because in PowerShell, you're not actually in the command prompt. Although Microsoft and the PowerShell team really wanted you to adopt PowerShell, really wanted to make it easier to do it. That's how they came up with this concept of aliases. So you'll see that there's quite a bit of aliases. And what aliases are a command that you can type in here, but you're actually executing another command. For example, here is group. If you just type group, you're actually running group-object. If you type II, you're actually running the invoke item command. If we scroll down here and go down to type, you'll see that when I actually execute type, I'm actually executing get content. Whenever I run get content, see example exe, and whenever I run type see example, it is the exact same thing. That's because of aliases. So aliases are a really good way for you to explore and get things done without having to learn all the commands right off that. Eventually, it's a really good idea to learn all those different commands, but right now you don't have to do any of that stuff. That concludes our running commands demo. I encourage you to get in there, type around, try the get command again, and just explore some of the commands that are available to you. See if you can't learn a little bit about the different commands and what they do. As you're just starting to get your feet wet, you're going to need some help. Lucky for you, PowerShell has an awesome and intuitive help system built right in. No more Googling around to try to figure out what that obscure command or that obscure argument means. Every PowerShell commandlet has help built right in. If you're familiar with the Linux man account, this is like man on steroids. By typing get-help followed by the command you'd like to learn about, along with a few different parameters, you're able to see a description of the command, each parameter, and their descriptions, as well as some really helpful examples. What really sets PowerShell apart is its concept of updatable help. By using the update help command, PowerShell can reach out to the internet and download the latest help content for you. This feature is even possible using your own custom commands as well. So let's jump into a demo to see what's possible with help. So when you first start out with PowerShell, you really don't know what commands to use, how to use them, and so forth. So where's the first place you look at? Well, the first place that I always look at is I used to do a $? Or a /? Or something like that to figure out like what the command is supposed to do. And when I didn't know what command even to use in the first place, maybe I used to do dir to try to find the different commands or that sort of thing. Really, the discovery was not that easy. With PowerShell, the discovery is very easy, as you saw with the running commands demo, but also PowerShell has a really great help system involved here. So let's go over a good example of how to use this. So first of all, let's say that I want to find all of these services on this machine. I can do that with get service. So you can see that get service brings back all of the Windows services and their states on this machine. Well, now maybe that I don't want to see all of them. So let's say maybe I just want to see the status of this one here, maybe the WMI performance adapter. Its name is WMI APSRV. I don't really know what parameter to use here, so I will try get service again, and then I'll type a dash, and what I could do is start tabbing through here and trying to figure out which one it is. And in this case, it's name, which is pretty obvious what the right parameter is here. But a lot of these commands, you'll see the parameters, you may not know exactly what the parameters do. So What we can do is we can look at the help properties of each command and all the parameters and what they do. So here's how we can do that. First thing we do, we can use the get help command here. And get help has a parameter called name, and I want to get help for get service. And you can see that immediately it brings back a lot of great information. So it has the syntax category here to where it provides you 3 different ways that the parameters can be used. So on the first one there, you see you can use name, computer name, dependent services, etc. The second one, if you just want to specify a computer name, you can do that. Each of those little sections there in the syntax, they are called parameter sets, different ways that you can use each of the parameters. And then you have the description, which is a really good example of just kind of a summary of what the script does. And then you also even have related links, so you see what commands are related to these, and you have remarks here. Now, the remarks, let's go into a little bit more detail here. This is definitely not everything you can do with the help syntax. So let's say that I want to use the help syntax again, and I will use get service here, and I can do another parameter. And let's first just do parameters here. So let's say that I want to get more information on what that name parameter does. I can just type in name here, and then you can see that it gives a really good summary of what just that parameter does. It also tells you if it's required or not, so if it's a mandatory requirement. Its position, we're not going to go over positional parameters very much, but that's basically just, you don't have to actually type in -name, you can just type in the name and it would work. Default value, pipeline input, and wildcard, we're not going to talk about all that. It allows you to really dive in and get some more information about each different parameters. However, what if you kind of wanted to see everything? You can do -detailed, and you can see when you do -detailed, it brings back just about everything you want to know about that. So it brings back the same syntax and description. It brings back descriptions of all the different parameters and even examples. Examples is what's really cool about the PowerShell help, because I learn best by examples. Examples allow you to really comprehend and understand how different parameters work. Depending on the commands, there's anywhere from 1 to 10 different examples of how to actually use the command. A quick way to get to the examples, this is the one I use all the time still. It just used -examples. -examples, you saw that output in the detailed section, but -examples is just a really quick way to grab the examples. And then finally, you can also do full, which is pretty much everything possible about that individual command. You see there's a lot of different things in the detailed, but the full actually breaks down each of the parameters of required, positional, default value, and so forth. So that's kind of the gist of the help system, and you can use every command built with PowerShell will have help. So you can do get help, get content, get help, set AD account control. That one was with the Active Directory module. You can see that all really good commands do have the integrated help. One thing that really sets PowerShell apart in its help system is this concept of updatable help. Things may change, people want to update help, but if you rely on traditional help systems, they're all static. There's really no way to get the content updated. PowerShell has a concept updatable help. So I can run update help here. And what update help does is it goes out to wherever the URLs that are set on each of the commands, normally all the commands built for Microsoft are pointing at a Microsoft URL. It'll actually go out to the internet and download all of the new help that Microsoft provides. Update help is a really great way to keep up to date on if things change. So for example, you'll see this a lot on some of the Active Directory module, the Microsoft Azure module, and a lot of the other modules that they're constantly adding new features and the way things work. And if you use update help, this will automatically go out and grab all the latest and greatest descriptions for all of that information that you want and get it all on your system to where it's in your local help system here. So that's one thing that really sets PowerShell apart from a lot of the other scripting language or console help out there. That's about the gist of the PowerShell help system. This help system is not just static. You can also write your own help for your various functions and things and integrate it into the help system pretty well. But I'll leave that up to you. We'll leave that for another day. Objects are what sets PowerShell apart from other scripting languages like Batch, VBScript, Bash, and the like. Objects allow you to group like properties and events into a single entity and manage it as one. In PowerShell, everything is an object. Even data types like string, integers, arrays are all just objects. Objects are everywhere in PowerShell. Now these objects have properties and methods. Think of an object like your car. Your car has attributes that make it a car, right? It has colors, it has doors, a trunk, tires, etc. These attributes would be called properties if your car was the object. Your car can also do things. It can go forward, it can go backward, it can turn left, it can turn right. These will be methods on your car object. In PowerShell, these properties and methods will be passed along a pipeline with the object. Unlike Bash, where piping is available, but it's just simple strings, PowerShell allows you to pass these entire objects along this pipeline and do things on them. It's sort of like the assembly line you're seeing there. In the next couple demos, we're going to explore objects and the pipeline. One of the features of PowerShell that really differentiates it from other languages and other shells is the concept that everything is an object in PowerShell. Now, as you saw from the slides, an object is basically just a thing that you can consider that has various attributes, which are just properties of that object, and then various methods, which are the things that you can do to that object. So let's go through a few examples of what that looks like in PowerShell. First thing I want to do is I'm going to create a variable here, and I'm just going to create a simple string variable here, and I'm going to do that by just taking the output of write output here, and we're going to say hello world. Well, before we do that, I'll just show you what this output looks like here. So you can see that it just outputs an hello world string. So let's go ahead and assign that to a variable and call it $string. Now when we get that, then the output is stored there. Now when I just type it out like that, you'll see that it just brings back hello world. On the surface, it doesn't look like there's anything else to it. You would definitely be wrong if you thought that that was the only thing. We can dive in a little bit deeper, and I'll show you that this string is actually a rich object full of all kinds of different things. To do that, you can pipe that to a command called getMember. GetMember enumerates all of the various properties and methods of that particular object and then displays them all in the console here. You can see here that it is a string, and you notice that as a type. In traditional programming languages, a string is just a string. It's just a set of characters, and that's it. There's nothing else to it. In PowerShell, a string is actually a string object, which, as you can see here, there is a lot of different methods to the string one, and there's only a couple of properties in this case for this string type. GetMember is very good at allowing you to get in and really do some investigation of what type it is and what are the various methods and properties that you can do here. Notice that in order to reference any of these methods and properties, you have to use something called dot notation, and you may be familiar with this already. So for example, this string object here has a length property. So I could just use dot, and then again with the tab completion, I could just type a few other characters and then hit tab and it would complete. I can hit string.length, and string.length can tell me how many characters are in Hello World. So if you would count all the different characters there in Hello World, it would be 13 different characters. That's how you reference properties on an object. So let's say that you want to do something to this object. You want to use one of the methods using the same dot notation of the methods, but with the methods, they always end with parentheses. But right now, we just have hello world. All right, so let's say that I want to convert all these to uppercase. I could just use the toUpper method and just use a left parenthesis, right parenthesis, which means that method has no arguments to it. Hit enter, and you can see that all of the characters are uppercase now. We can do the same thing with lower as well. If we wanted, we can do toLower, and they would bring all of them to lowercase. Those methods perform some kind of action on this. Same thing with replace. So let's say we want to replace hello with goodbye. That did not work because it looks like that it's case sensitive. That's one thing you need to remember. A lot of things in PowerShell are not case sensitive, but some things are. You have to always remember that. So the replace method is case sensitive. Now, one other thing I wanted to point out was, notice that on this method here, notice we just have the method name, toLower, left parenthesis, right parenthesis. That's it. there is no what you call arguments inside of there. So we can run this and there's no arguments. So think of arguments as kind of like parameters in various functions. However, with the replace, we need to provide the replace method with some kind of input. So in this case, the replace method has what you want to be replaced, and then what do you want that to be replaced as. That's called passing various arguments to a method. When we created the string variable here, we just created an object that was already built in. We created an object of type system.string. Now the system.string type is a built-in type in PowerShell, but we can build our own as well. Let's say that I want to build an object from a car object. So a car has various properties to it. So let's try to run this and see what happens here. To do that, you can build a PowerShell hash table. And a PowerShell hash table is nothing but a lot of different key value pairs. So in this instance, we have a color. The car color is going to be red. The transmission is going to be automatic. And it's not going to be convertible. As you can see that I have a Boolean false value here. So I'm going to create this hash table and call it hash table. Now when I pipe our hash table to get member, you see that the type name is system.collections.hashtable, and it has different methods and properties. That's because it's a different type. What I can do is I can build an object of this. Now hash table technically is an object, but we can actually build what's called a PS custom object to do this. This is very common whenever you get more into PowerShell and really using the pipeline and things like that, which we'll talk about later. Let's now convert this into a custom object. We can do that by using PS custom object. This is called a type accelerator here. And you can see that it changes the output without even changing it. So whenever I output the hash table, you can see name, value, key name, key values. However, when I convert that to an object, it brings back convertible, color, and transmission. Those are the properties of that object versus the properties of the hash table object are name and value. And we can also, using the PS custom object type accelerator there, that's kind of a shortcut that you're generally recommended to use. So now let's assign this to the variable car, pipe that to get member. And you can see now that is a system.management.automation.ps custom object. Now notice that up above I used $car, piped it to get member. And well, not necessarily, I piped it to GM. Well, what is GM anyway? Well, GM is a set of aliases. So that is an introduction to exploring objects in PowerShell. So remember, the command that you really need to run the most is getMember. GetMember allows you to really dive in and explore more about objects and figure out the properties and methods. And then also remember, use the dot notation to reference the various properties. And then methods are always left parenthesis and right parenthesis. One of the other unique features of PowerShell is the pipeline. The piping itself has been around for a long time. So in Bash or even in DOS, you could do things like dir. Let's go to actually the command prompt here. So let's go to dir, pipe that to type, or pipe that to find string. You can pipe commands to other ones, but never before in a language in Windows, you can actually use the pipeline to pipe those rich objects that we talked about earlier. To demonstrate the pipeline, I'm going to show you a couple different ways how you can use it, how we can get stuff done without it and with it, and see what the differences are. Let's say that I want to restart a service. So first of all, I'm going to see if this service is on here or not. I'm going to use the audio SRV service. Nope, looks like it doesn't work because I'm actually in the command prompt because the PS wasn't there. So let's exit the command prompt there and you see we get PS back. So let's run get service name audio SRV. So it's running now. The Windows audio service is running. I can restart that by just doing restart dash service name audio SRV. And that would have restarted the service. Now that doesn't use the pipeline in any way. That's kind of like the old-fashioned or traditional way that you would do it, providing a parameter directly to a command. So now let's do it the object way. So here's the next step up to do this. Let's first grab this and put this into a variable. The variable now contains the service object. Restart service has a name, which you saw before, a name parameter. It also has a parameter called input object. Now, input object is a common parameter name that you see on a lot of different commands that accept pipeline input. However, we're not going to use the pipeline in this. We're just going to show you that we can actually pass that whole object, and it does the same thing. Instead of accepting just the name, it accepts that entire service object. This is how you would do that the pipeline way. We can do that a few different ways. We have the service object in here, and if we look at this with getMember here, you can see that it is a system.serviceProcess.serviceController object this time. Instead of piping it to getMember, I can actually directly pipe that to restart service, and it would do the exact same thing. So I just took that entire object, passed it to restart service, and since restart service allowed pipeline input to that command, it worked. We don't even have to assign that to a variable if you want. This is the beauty of the PowerShell pipeline, because we don't even have to do that on separate lines. So we can just take the output of get service directly to restart service, and it will do the same thing. You can add as many different pipes as you want here. So let's say that I'm going to do something else to that service. Restart service has a common parameter called pass-through. So you notice that whenever we just ran this, nothing happened. Instead, we can use pass-through, which as soon as restart service is restarted, it will actually pass that same object that it got from get service out to the console. Now this allows us to pipe something else to it. Let's say that I pipe something else here. Set service. Let's change the startup type to manual now. Actually, let's first see if it's set to manual or not. So we'll look at this again. Looks like the default output doesn't show the startup type or anything else for that matter. So let's dive in a little bit, and we can pipe that to select object property. So let's look at all the properties of it. And we have status, service type, service handle, display name. So it looks like in this instance for services, we can't actually see the startup type. Let's do this another way here. So let's grab get service. Just for a stupid example that you will probably never use, but hopefully you get the concept here. We can restart service, do a pass-through, which would then pass that same service through, and then now let's stop service. So it's going to get the service, it's going to restart the service, and immediately after restart, it's going to stop. So then we hit there, and you notice that it didn't do anything at all. Stop service, so you can even do pass-through and stop service, and then now you can see that the status is stopped. So it got the start service object, restarted it, and then stopped it all in one line because I was piping all those down one at a time. Let's go through a more real-world example here. In this example, I'm going to go through a list of computers in a text file and then just ping each one. So to do that, I'm going to first see if my text file is here. I use get content path. I believe it's example.txt. Yep, we still have those in there. I can use test connection here. I want to make sure this command works. Computer name DC. Looks like my DC is up and working. All right, so I want to do that. I want to ping each of those. Now, you might think that this may work. Using the pipeline, you may think, well, that's going to grab localhost DC and lab SQL, send all that out to the console. Well, maybe I can just pipe directly to test connection. That's a very common assumption. But you can see that we get a lot of errors, and it's because test connection does not provide that pipeline input like that. So the command has to be built for pipeline input. And if it's not, you'll see that it will say the input object cannot be bound to any parameters, blah, blah, blah. They do not take pipeline input. To get around this, we can use a for each object and then provide an object that test connection does accept as pipeline input. So let me show you how this is going to break down here. So we can use get help to get more information on test connection to see the pipeline input. To see any kind of pipeline information, we always need to use detailed here. So if I use detailed, and I'll scroll up, nope, all right, we need to use full, which provides us information for all of the different parameters and their type of input. When we scroll up here, you can see that here's the parameters. We have first, I had the as job parameter. The accept pipeline input, false. Buffer size, accept pipeline input, false. Okay, now finally you see here the computer name parameter, accept pipeline input, true. So that parameter alone can accept pipeline input. However, you see that it says by property name. There's two types of pipeline input in PowerShell. There's by property name, and then there's by object. Because we were piping an entire object to test connection, that didn't work because test connection doesn't understand accepting an entire object into the command. It will, however, understand just that single computer name parameter here. It will understand the computer name parameter because it's set to accept pipeline input by property name. So what does that mean? Well, let's do one by property name. To do that, we need to build an object that has a computer name property. So when we go check out the output of get content here, you can see it's a string. There is no computer name property on here. We need to make one of these names over here. We need to make these computer names so it will understand it better. To do that, we can use a for each object. So we can use for each object, and then let's just do PS item, and it's exactly the same output. We're just grabbing all the contents of get content, piping it to for each object, and then iterating over each of those individual ones. If we pipe this to test connection again, it will do the exact same thing because essentially we're doing the exact same option before. We need to actually build another object from this PS item or the pipeline variable. To do that, we can use the PS custom object like we went over in the earlier demo. So let's do PS custom object, and then we want to build our own here. So then we'll do this, build the hash table again. We can always cast a hash table to an object. And then I'm going to make a computer name property. And now for each object, we'll output an object with only one property, computer name. Now I'm going to pipe that to test connection. Now you can see that it works because test connection finally understands the input that it's receiving. Well, let's go ahead and look and see what this looks like. Now you see that instead of just showing localhost DC and lab SQL, it has a computer name with the dashes and then all of them under that. So that's saying that the computer name is a property. And if we pipe all this to get member, you can see now that it's not a string anymore. It's a system management automation PS custom object with, most importantly, a computer name property. So now that we have an object with a computer name property, test connection can understand that. Then we can pipe directly to test connection. Once you've gotten the hang of individual commands, it's now time to start building some scripts. Scripts are simply groups of commands running together as one. Scripts allow you to easily take the output of one command and use it as the input of another. The majority of our work will be creating scripts and eventually modules, which we'll discuss a little bit later. By building scripts, you can easily reuse code. By doing something called dot sourcing and simply executing other scripts directly from another script, you can call scripts from other scripts, which means no more rewriting code over and over again. Scripts will be used for anything other than minor ad hoc tasks. Unless you like working on the command line directly, the majority of your time will be spent on building scripts. Although a script is just a text file, and you could technically use something like Notepad, this will soon get old as there is a much better editor called the PowerShell ISE or Integrated Scripting Environment that comes with Windows and is a great choice for anyone beginning PowerShell. So let's now get into another demo where we'll be using the ISE and build our first script. Alright, so we graduated from running commands and it's getting too tedious to copy and paste commands all the time and run them in the console. So your next evolution in your PowerShell learning journey here is to use scripts. Let's get into building our first script. There's a lot of different ways to do that because after all, a script is just a text file, but Microsoft provides a really good script editor known as the PowerShell ISE. So that's the first thing we're going to go over here. To get to that, we just go to our start menu here, type in ISE, and there it is, Windows PowerShell ISE. So we run this, and you'll immediately see that there is no place to actually type code. It actually brings up a console screen. In actuality, the ISE has a built-in console here. So you can see that I have a built-in console, and it's exactly the same console as you have if you just manually type in PowerShell.exe. So it's a really great way to do debugging and just to do quick copy and paste and things like that to get things done. With the ISE, we need somewhere to build our script. So the first thing we need to do is go up here to View and then go to Show Script Pane. And the script pane is where we can actually type out our scripts and various commands that we need to run. There's a lot of other things to the PowerShell ISE, like debugging support, a lot of different viewing options. You can zoom in, zoom out. There's a lot of different options here, but I'm not really going to go over a lot of the options. You can pretty much figure out a lot of this stuff by just clicking around and do things. Today, we're going to focus on just writing a script and then executing the script. To do that, I'm going to kind of come up with a fictional scenario to where we have built a text file with computer names, and I want to loop through that text file and first ping the machines to make sure they're online. And if they are online, then I want to query something in WMI and get their operating system. So let's go ahead and do that now. So the first thing we need to do is make sure that we have our text file on our file system somewhere. I can do that by going down into the console. I believe it's in the root of C. Let's check it out here. So we can do dir C, and it is called example.txt. All right, well, let's just make sure. PowerShell is a really good command called test path. We can just dash path here, C example.txt. It's true, so it is. One other thing you should have noticed here as I was doing this, in the PowerShell ISE, it has a really nice IntelliSense feature here to where it will immediately show you all the different parameters and things that are available to you. So it's a really handy feature there. So now that we know that our text file is there, in here in the console, let's just make sure that the computer names are in there like we think they are. So we'll just run git content, and it looks like we have 3. So we have localhost, DC, and lab SQL. So that's good. So we have all those in here. The first thing we need to do is to enumerate all those computer names. We did that with git content. We need to do other things as well, like ping, make sure they're available, and then query them for the operating system. We can't really do that in the console very easily, so we need to build a script to that. So what I'm going to do is I will just copy and paste, basically just get this exact snippet here and paste it up here into my script pane window. And because I'm anal about my capitalization, I will just capitalize get content here, and then I will use the path parameter so it's more obvious instead of using the positional parameters like we were earlier. All right, so we have get content path. One really good thing about the PowerShell ISE is you don't actually have to write the whole script ahead of time and then execute it all at once. You can kind of do this piecemeal. To do that, you can click on any line in here. So I have line 1, I only have 1 line in my script. I can click on that and then click on this button here, run selection, or I can press the F8. When I do that, you'll see that it just runs it down here in the console. So it's a really good way to run these one at a time. So I can do dir. All I have to do is click in it somewhere and I run dir. If I want to run more, I just highlight, click selection, and you see that it runs them all. So it's a really good feature of the ISE that I use a lot. Since we need to enumerate through all of these, we need to find a way to kind of iterate through each of and do something to each of the elements. And to do that, we're going to use a for each loop. There's a few different ways to do a for each loop in PowerShell, but I'm going to use the for each object command. So to do that, I'm going to do a pipe here, and I'm going to type for each object. I'm going to add left curly brace, and then I'll add a right curly brace. What this does is, this means for each line that get content provides, so each line inside of the example.txt file, it will do something for each of those lines. So if I run this now, you'll see that I don't get any output at all. That's because I've actually redirected the output here to my pipe. So I'm not actually piping it out to the host console here. It's actually going straight into this for each object command. To get the same output I did before, I need some way to send that to the console. I can do that with the pipeline variable. I can use the $_. This is just a variable that represents the current item or current iteration in this file. So if I run it now, you'll see that I get the same output. That's because each time the $_ is ran, it will output to the console. Another automatic variable here that I can use is I can also use PS item if it's a little easier for you. So I can run PS item, and I'll run this again, and you can see that I get the exact same output. It's the exact same, it's called a pipeline variable, so you can use either one you want. I'm used to doing the $_, but you can use PS item if you want as well. Now that we have a system set up to where I can do something to each one of those items in that text file, I now want to ping them. I can ping them with test connection. So I will type in test connection here, and then I will specify -quiet and -count1. By default, test connection acts like the ping.exe command, where it will try 4 different times and give you a nice output of the IP address, the latency, and all that. Since I just want to test to make sure a machine is online or not, you can use quiet and it'll just output true or false. And then the count of 1, that just means just send 1 ICMP request to it and be done with it. So now let's run this and now see what happens. Now you can see that instead of the computer names, we have true, true, and true. That's because for every one of these computer names, we ran test connection against it and it returned a true, and a true. So you can see that with the for each object, we can do something to each of those. Notice that the line length is getting a little long. We have some other code to do, and we don't want to continue this all in the same line. One of the other great things about scripts, not as easy to do in the console, is to do multiple lines. So I can bring this down a line. You can actually do line breaks in these curly braces here, and then add another curly brace down here. PowerShell knows to kind of extend the line and knows at the same command, and it knows what you're doing. So we can actually highlight this all again, and it does the exact same thing. Be sure to always try to keep your line length manageable because you don't want to have to scroll left and right. It's just ugly to do. All right, so now that we're pinging each machine, now we need to build some kind of conditional logic. So we want to do something only if the machine is online. To do that, we can use an if-then statement. So I will enclose our command here in an if statement, and now I have an opportunity to do something only if test connection was true. First of all, let's actually take this back to a simpler level here, and I'm going to say if test connection equals $true, then let's just say the machine is online. All right, so let's run this. And notice we got 3 times the machine is online. That's because it was up 3 times. The if-then logic here, this piece right here, the test connection piece, that actually just returned true or false. It returned a Boolean true. And I'm using the -eq operator here to compare this result, this whole result here, against this Boolean value here, which is $true. This is the long form of testing conditions. What you'll most likely find out in the real world is you take all this away, and then you can run this again, and it's the exact same output. Because PowerShell if-then statement, it will always return either a Boolean true or value. Let's just write something out. So I could do write, output, whatever. And this will actually do the same thing. So it doesn't really matter what it is, as long as this statement here outputs something. So let's back this out. Now that we have set up a condition, so we can do something only if the machine is online. So instead of machine is online, we want to actually take some kind of action against that. So I want to grab the operating system name for each of these. Well, how do we do that? Well, we use wmy or we use sim. Using the wmy command, it's like get wmy object, is considered legacy. So what we want to do is try to use the newer commandlets called get sim. So we can go get sim instance. And if we look at get sim instance, we can go down here and we can do help get sim instance, which will run through the help in a future module, where you'll see that the get sim instance gets the sim instances of a class from a sim server. So in this case, the sim server is going to be Windows. Now that we know the command to use, now we need to specify a computer name to connect to. Well, what if you don't know the computer name? Well, you just type tab, and then in the ISC you have all the options. I have computer name here. Here on line 3, at this time when this script executes, the computer name will actually be represented as that pipeline variable. So it's going to be $_. Actually, now we need to specify a class. And to do that, we do dash again, and looks like we have class name, so I hit tab. And then I know from experience here that the class name is going to be Win32 operating system. So I will make that a string. And now let's see what happens. So this should go through and Only if the machine is online, it will query the Win32 operating system SIM class. And you see that it did that. It did bring back all of the various properties that were returned from that class. For some demonstration, let's actually stop one of these computers to make sure that our logic is working as it should. PowerShell has a really nice stop computer command here. Let's stop my SQL server. So we go computer name, lab SQL, and I want to wait until it's off. Nope, actually let's force it to make sure if there's any users logged in, they will go ahead and do that. So I will go ahead and shut it down, and I will just use the old school ping command here in the -T because old habits die hard, I suppose. Here, let's go ahead and clear this screen of all this stuff. We'll ping it, see if it's online, and it looks like it is offline. All right, great. Now, let's run this again. Then now you'll see it's taken a little bit, and we only got 2 instances. We only got localhost and DC. We did that because we had that if statement there, only if it was online. So we had that option to do that. We're reading the text file. We're making sure each of those machines are online, and we're reading the operating system. I now want to see what operating system it is. Notice that actually we're getting some information like the system directory, registered user, and serial number, but we're not actually getting the operating system name. So to do that with the get sim instance command, the get sim instance command has a property value here. So I can do -property, and I know that it's caption. Well, what if I didn't know it was captioned ahead of time? What I usually do here is I will take this piece out and then manually go in here and explore. To do that, get sim instance outputs an object with all those properties. I can pipe this to select -object and then a star. And then you'll immediately notice that we get back a lot of other properties than just the few that were shown. The few that were shown were just based on the format that getSimInstance was configured to show. It's not all of the properties by default that it shows. As we go down through here, I can explore which of these properties I want to find. And it looks like there I have a caption property, and it's Microsoft Windows 8.1 Enterprise in this instance. So I know that I want to get the caption property only. How do we do that? Well, I can do that by, again, copying, using the select object command again. And this time, instead of doing a star, I can just select object and do caption. And then notice that it just has caption. It doesn't have any of those other things. With select object, you can really limit the amount of properties that you see. So now that I've done this in the console and I know what syntax to use, I will then go ahead and put this up in my script. So I'm going to do select object and then do caption. All right, now that I have it in my script, I will highlight everything, run this again, and then you'll see here that I have caption, and then I have 8.1 Enterprise and Server 2012 R2 Standard. Great. So I've gotten all of the operating systems of all the computers in my text file. Typically, I don't just want a big list of operating systems. I want to know what computer name each of those operating systems correlates to. Well, we can do that pretty easily. So because we have the computer name available to us here with the pipeline variable, we can incorporate that into our output to the console. The first thing we can do here is assign this to a variable. So I will assign this to a variable and call it operating system. So now we have that stored in operating system. And now I can output this out, and you'll see that it should be the exact same thing as what we had before, because we're not just immediately sending the output of getSimInstance to our console, but we are saving it to a variable for later use and then outputting the variable which goes to the console. So now that we have that stored in a variable, now I want to add the computer name. So first thing I can do, well, if I just want a really rough output, I can just put the computer name in here and run this again. And now that you can see that it will have localhost, caption, well, it has it in there, then you have to kind of think about, well, what does this relate to? What does this not relate to? It's really hard. We need to make it into a more understandable way. So to do that, we concatenate these two in a string with double quotes. So to do that, I will just put in operating system and the computer name in double quotes here. So I can do a double quote, And then I can do $_ and I'll just do a dash and then close my double quote here. And let's see what this does. All right, so notice that we have localhost dash, and then we have the operating system and DC dash. So we have the computer name dash and the operating system. But instead of computer name dash and then this actual operating system name, we have computer name dash ampersand curly brace caption equals operating system name. Well, why is that? Well, that's because the operating system itself is not just a single string. Whenever we save this in here, we're not actually saving it as a string. Whenever we do select object here, caption, that's actually still outputting an object, but it has a caption property to it. So you can see that by default, PowerShell will output an object with a property in a string here as the @ curly brace property name equals whatever the value is. I want this to say localhost dash Microsoft Windows 8.1 Enterprise and DC dash Microsoft Windows Server 2012 R2 standard. I don't want all that caption stuff in there. So let's do that. We can do that a few different ways. So let me show you the first way. So let's take this out. And then instead of just outputting operating system, I can do a dot here. And then notice that PowerShell, the ISC, is smart enough to know what properties are available to you. So I can just pick caption. Copy this out again. And then notice now that we don't have the caption underscore and then the operating system. So up here, see we had the caption and then all the lines. That's to indicate that that's a property. Under here, now we don't have that at all. So we've removed all that completely. Now we can enclose this in double quotes again and put our routine back in here. And then now let's see what happens. All right, well, it didn't work again. What's going on here? Well, the reason is because whenever you reference a property, which is caption here, to an object, which is the operating system, inside of double quotes, you actually have to enclose this with parens and a $. So I'll do $, left paren, then right paren. And now I'll try this again. Now notice that's exactly what we want. We want computer name dash operating system name. Actually, we got exactly what we wanted here. So let me just show you one more quick way. Now select object also has, instead of by doing just caption, we can do a parameter called expand property. And expand property actually just grabs the value of caption, doesn't actually care about caption at all. Now let's go ahead and try this again with the expand property parameter. Notice that it has nothing for the operating system name. That's because there is no such thing as caption anymore because we expanded it out. We just grabbed the value with select object over here. To do this, now we don't need the $parens anymore, nor do we need the caption property. We can just do what we expect, computer name dash operating system, and we get what we want. This is a really good way to go because then we don't have to worry about that caption property. We got our script created. We've tested it by highlighting it and running it with run selection. Now let's go ahead and save it so we can reuse it over and over again. So I'll go ahead and save this, and I will save it as Git Computers. Now that I have it saved, I can go down here in the console, and then now I can just execute this script as we normally would. We don't have to use the ISC at all for this. So let's just use the PowerShell console that we were using before. So let's first make sure that it's here. We have getcomputers.ps1 there. So now I'm going to execute it. I can do that by just typing git dash and the first 3 letters or so of the script name, hitting tab, and then notice that PowerShell will automatically put the / in there. You need that if you're going to execute something in the local directory. So let's go ahead and run that. And then now notice we got exactly that same output, and we didn't actually have to write it. All those commands are available to us now inside of this single script. This concludes our building a script piece of the course here. So let's now continue on with the course and see what else we can learn with PowerShell. For our last part of this demo, let's briefly talk about modules. Just like scripts group commands together, modules take this a step further and formalize things a little bit. Although modules are, again, just text files and thus scripts, they are kind of a special script, not with a PS1 file extension, but with a PSM1 file extension. Or, in some cases, a compiled DLL. Modules group commands together, not necessarily random code. Modules are typically built around a single concept. For example, we'll be using the Active Directory module quite a bit in this course. This module has commands to just manage Active Directory. There's also a DNS server module, IIS module, and so on. Modules can't be directly executed and ran. Modules don't contain executable code themselves. They contain commands that can be executed. This is why if you attempt to run a module, nothing will happen at all. You will import a module into your current session and then run the commands the module contains. And finally, modules are great to share code. You'll see with our AD module that Microsoft has shared this code with us in a single module. This allows Microsoft to easily share that code with us. Likewise, when designing your own modules, you can share the code with your coworkers and the community as well. Modules are more advanced than scripts, so don't worry too much if you don't know how to build them. To manage AD, you won't have to know how to build a module from day one. Now that we've got the basics of PowerShell down, let's take this up another notch here for our final demo and talk about modules. As you progress in your PowerShell knowledge, you'll eventually find yourself creating a lot of these modules. But in this course, we are going to be actively using a module that's already created called the Active Directory module. So I wanted to make sure that you understood the concept of a module, how it works. So we're going to be using a lot of the commands in the remainder of the course with the Active Directory module. First of all, a module is, in its simplest case, just a grouping of commands together. To find things in PowerShell, you just do git dash, whatever you want. So I'm going to use git dash module. And you can see here that I have a few modules already loaded into my session. So that's kind of the concept of modules. It's called importing and exporting. Modules, when you want to load them, they are imported. Whenever you just run git module, you see all of the modules that are currently imported into my session. And you can see there with the exported commands on the right, those are all the commands that exist inside of each of those modules. Now, this is definitely not all the modules that I have currently available to me. To see all the modules on my local system here, I can use the list available parameter. And when I run that, you'll see a whole lot of different modules because I have a whole lot of different things installed here. So I have a lot of Microsoft ones. You see here I have Microsoft PowerShell Archive, Diagnostics, Host, and some of the third-party ones. So I have the SQL PS one here. I have the Azure one, the AWS PowerShell, and Google Cloud. All of these modules are essentially just more plain text files, but instead of PS1s, they're PSM1 files. PowerShell has an environment variable that looks for specific places where each of these modules are located, and that is in the PS module path. My PS module path contains a lot of different folders. So what this means is every time you want to make a module available to your PowerShell session, you can put it in any of these folders that you want here, and it will automatically pick it up, recognize it, parse through it, and understand it so you can then import it, and then use some of the commands inside of that module. So let's say that we're going to be working with the Active Directory module here. So let's take a look at that. So I can run git module, name, and then I just want to use Active Directory. Notice that I could just tab complete on the module names too. Tab complete is a great feature of PowerShell. Right now I have the module loaded into my session because I didn't have to do list available. So let's check and see. So it is loaded. All right, so now let's remove this from my session completely. I can do that by remove dash module name and then the module name. Now, remove module doesn't actually remove it from the file system. It just removes it loaded from your current session. When I run this again, you'll see that Active Directory doesn't show up now. As of PowerShell version 3, PowerShell auto imports these modules. So whenever you type a command in, it will automatically bring the module in. However, there may be times where you want to manually import these in for whatever reason. You can do that with import dash module. So I can do import dash module name Active Directory and then git module again. And then now you can see that the Active Directory module has been loaded. Let's remove this again. And then one of the other things is you don't necessarily have to have a module inside of one of those module paths for PowerShell to understand. If you place a module inside of any of these folders here, PowerShell will automatically pick it up. It's the best practice to put modules in here, but I wanted to show you another way to do that. So let's say that for some reason you don't want to put a PSM1 file in each of these folders. With import module, you can point to the PSM1 file directly. So to do that, let's grab some information from the Active Directory module. And I want to see where that's actually located at on the file system. So I can use list available since it's not imported. And I can pipe that to select star to give me all the properties. And I can grab down here and see the information here. Looks like the path is here in the system path. Notice that instead of a PSM1, that's a PSD1. Modules can optionally have module manifest, and a module manifest is basically a listing of all the information about that. So it can sometimes be the name, description, all the commands that exist in it, and that sort of thing. So, but we're not going to really worry about manifest for now. But so suffice it to say, if a module has a manifest, you can point directly to that manifest or directly to the PSM1 file, either way. So let's say that for some reason this module is not in the PS module path. I can do import dash module and then say the specific path of it and then get module again. Then now you can see it's imported. So import module, you can just run import module with the name, or you can just run it with the specific path. Now, 9 times out of 10, you're always going to be running it with the name. And in actuality, as you're just getting started, you're probably only going to worry about import module because all this stuff auto loads for you. But I wanted to kind of give you some background. We have a list of the exported commands here. So you see we have add AD central access policy member and another one with some dots there, some ellipses. Since the exported commands property here can't display all this in the console, maybe I want to see all the commands that exist in our Active Directory module. We can do that with get command. So get command has a module parameter here, and I'm going to specify Active Directory. After I do that, you'll see I can get a really good listing of all of the different commands that exist inside of that Active Directory module. And again, using help is a good discovery mechanism. Whenever I first start with a new module, I'll explore it. So I'll see all the commands that exist. Maybe I want to unlock an AD account. I look through and see unlock AD account here. Then bring that over to get help, put unlock AD account, and then get some more information. You can dive down a little bit further, do the various parameters. So we can do detailed and then get various parameters. Get module and get command, they're really good discovery mechanisms to really explore modules a little bit better. That concludes the basics of modules. There's a lot more to modules out there. But like I said, in this course, we're not going to be building our own custom modules and everything. Basically, we're just going to be taking an existing module that Microsoft has built and use that. I wanted to give you a summary of kind of what modules are and how they work so you kind of understand the foundational things. To learn more about PowerShell, I've got a few good resources here. I also author courses for the online training company Pluralsight. You'll find a lot of great PowerShell courses in that library. Also, PowerShell.org is another great community resource with free ebooks, a forum, and a lot more. But most importantly, just open up PowerShell and break stuff. Granted, do not do this in production, but get yourself an isolated environment and just play around with the commands. Take a process that's been in the pain in the neck and just see if you can automate it with PowerShell. Start small. Applying a real-world problem to your PowerShell learning will solidify your understanding of the language. In this module, we're going to get started applying our newfound PowerShell skills to Active Directory. I'm also going to introduce you to the little project we'll be working on throughout this course. I'm really excited to get started here, and I hope you are too. When just starting out managing AD with PowerShell, the first hurdle you're going to have to jump over is the difference between the GUI and the command line. In this case, PowerShell. Both PowerShell and the GUI are working with the same AD database, but present the information and give you tooling that's very different. A few advantages here. First, the GUI is great at discoverability. They are naturally interactive since you must click through menus, on buttons, scroll around, and so forth. They are also intuitive because you have cues on the screen to click on, like a tab name, a label, a visible scroll bar, etc. However, PowerShell has some great advantages as well. For example, a PowerShell script performs the exact same action every single time you run it. It doesn't change at all. It doesn't fat finger anything. It's also the same effort to do one thing versus many. Code allows you to just loop over lots of things to do the exact same thing every single time. And also, PowerShell code is reusable. You can save it anywhere and run it again at any point. To do this in the GUI is extremely hard to do and is pretty ugly if you've seen those screen scraping tools before. And a few disadvantages of the GUI here. First of all, GUIs are not scalable. There's no way you're going to say create, 100 users in the GUI and be sane afterwards. Humans are messy too. We make mistakes, fat finger stuff all the time, get distracted, and so on. And PowerShell does none of that. Now, I'm not going to say that there are not any disadvantages to PowerShell. Obviously, you have to learn the language and such. But once you get over that initial learning hurdle, you'll find that working with PowerShell is very rewarding. Before we get too far into building our own scripts with PowerShell, I first wanted to kind of give you a mindset transition from using the GUI to using PowerShell. To demonstrate this, I'm going to do one task one time with the GUI and then one time with PowerShell to kind of show you the differences and kind of the different ways to interact with whatever task you're involved with. To do that, I'm going to create a lot of users in Active Directory from a users.csv file. So there's going to be a lot of different employees in a CSV file, and we're going to create users from this a few different ways. Here is the CSV file that I'll be working with here. And you can see I just have 4 different employees here with first name, middle initial, last name, department, and title as each of the columns in here. I'm not going to actually create each of these by hand with the GUI, but I wanted it because that'll take way too long. Just like in the real world, you would get tired of doing this over and over again. Let's first bring up Active Directory users and computers here, right? So if I was doing this without PowerShell, what I would have to do is I would have to open up the folder that I have the CSV in. I would have to navigate to the folder here, so I'm going to do this in real time. So I'll grab the folder, and then maybe this would be Excel or something like this. I'll just open it up with Notepad++. I have 4 of my employees. All right, so I'm going to go ahead and try to create the first one. Alt-Tab over here. And then before I get too far into this though, there's a few different rules we have here. Our company has some kind of standard. So we have a standard to where 1 OU for each department. And we also need to add the user to the all users group. So every user goes into that group. They all have a common password. We all need to make sure every user that I create has to have the password as changed at logon attribute set. And then finally, the username. If there's no other username with first initial, last name, we'll go ahead and use that. If not, if that's taken, then we're going to use first initial, middle initial, and last name. And if that's still taken, for now, we're just going to say can't do it. Maybe we'll go back to HR or, somewhere like that. Let's go ahead and create the first user. So the first user is me, Adam D. Bertram. I'm in the accounting department, and I'm a manager. So I will open up here, and then because I'm in the accounting department, I first have to figure out, well, which OU do I need to be in? I'm going to be in accounting. All right, so I can right-click that, go to new, go to user, then type in my first name and last name. Okay, and then go back to the CSV file, make sure that it's right. Oh, I forgot my initial. Username, first initial, last name is default I want to start with. So I'll hit next. Oh, it looks like somebody else already has that first initial, last name. Then I will try to go with first initial, middle initial, last name, which is A.D. Bertram. Try that. Okay, great. That worked. So I'll type in my standard password twice. 1, 2, 3. Make sure my user must change password at next logon. Hit next. Hit finish. And then I've created my account. Now I need to go look back and see, make sure I did everything right. Oh, I still need to add it to the all users group. To do that, I will double click here. Here it is, member of, add all users. Done. And I make sure I did everything right. Yes, all right. So I've created one user. Notice how long this took to take place. Now times that by 4, and you'll get a good sense of showing how long it takes actually to do all these one by one. And plus, You have to add into the additional time to account for things like fat fingering and forgetting something and going back and changing it. It's just a really messy way to get things done like this. I'm going to go ahead and delete this one I just created. And now let's do it with PowerShell. So I will go ahead and close this, and I will open up my PowerShell script that I have created ahead of time. What we're doing here is more advanced than what we went over before, but the purpose of this is not really to explain to you what this is doing, but give you a good idea of just a general sense of the way that you would go about this in PowerShell. We'll cover a lot of this up in the coming course, but a lot of this is a little more advanced. I don't expect you to know what all this does at this point, so keep that in mind. This script works by, first, I'm reading all the employees in that CSV, so I'll assign them to an employees variable, that way we can loop through them. Then I need to find the common user password. So remember that I used the password, I've had to put it in there twice for that one user. If I was having to do this with the GUI, I would have to do that twice for every single user, or 8 times. Here, I'm just going to input it once. Technically, I could just assign this a variable right here and say whatever the password is here, but it's generally not a good idea to put password in plain text here. Using the get credential command, I can grab out that password and leave it encrypted. And then here's where the for each loop, we're really going to focus a lot on this for each loops the rest of the course. But for now, just suffice to say, we're going to do something to each employee in that CSV file. So the first thing we do, there's different rules that are set up in here. What you have to think about is, notice as I was going through in the GUI, I was having to go through each rule set. For me to pick a user, I first tried to create one. It failed. Then I tried to create another one. So I did one iteration, then I did another iteration right after that. By doing this in PowerShell, I can script and automate that stuff in code. It automatically checks the next one ahead of time, and then it will make all those checks in a blinding less than a second to make all this stuff happen. So you don't have to actually do all that stuff by hand. So this part right here is just trying to figure out the username. So it's going to check and see if the preferred username is available, and if not, it's just going to go ahead and use the second one. And then here, if that's not available, it's just going to error out and say the username is already taken, unable to create the user. So then after it knows the username, then it goes down through here and will create the user. The majority of this code here is just using the new AD user command. And I'm using a concept called splatting in PowerShell. I'm doing that because you can see there's a lot of different parameters to this command that I'm using. So there's quite a bit, and if I keep all this in one line, it could potentially go all the way out here. It's really not good practice to make your scripts go way over. Generally recommended to keep it between 0 and 150 characters. That's the total length of your script length. Splatting is a really good way to pass all of these different parameters that I have here, all in one shot to this new AD user command. So this is where it will go ahead and create that AD user based on the rules. One of the rules was create the AD user in the appropriate OU. Here, using the path parameter, we can do that easily. We could just say path, then make it a variable employee.department. So we got department from that CSV file. So that's where we are defining the path there. And then here's the account password. We are using that common password. We are defining all of these common things up here. So the OU path is going to be in the CSV, and then the common password is going to be in the common user password variable. So we define all that once, and then regardless of 1, 10, 20, 50, or 1,000 accounts, it's always going to be the same. We can just refer to that just like we always would. And then once we get the account created, then we're just going to add it to that all users group here. And that's what the add AD group member does. So we're going to add it to the all users AD group member. So you can see here that we have each of these different rules kind of separated out. The group addition, the user creation, and then we also have the rule set to figure out the username. And since these are built-in regions, I can just go ahead and collapse these, and you can see that I can easily read what's going on here. Again, don't worry about what this script is actually doing at the moment. We're going to address this in more detail later on. But for now, just realize that regardless if we can run this 1, 10, 20 different times, it's always going to be the same. Writing great scripts is about translating what you use in the GUI to code. So let's go ahead and run this now and see what happens. So I will go ahead and down here in the console here, since we're in the PowerShell ISE, we have this integrated console. So let's go ahead and bring the demo path in. I know this is a really long demo path. I have this script in. So let's go ahead and run it here. We run this by doing a ampersand demo path /create acme user.ps1. Normally when you're executing a script, you don't have to use the and symbol there. The only reason I'm using that is because I'm using a variable here, demo path, to specify the exact path I'm using, and I'm doing that by enclosing it in double quotes. So that's the only reason I have to use the ampersand here. So I'm going to go ahead and run this and let's see what happens. First thing, it's going to prompt me for the initial password for each account. By default, a get credential, PS credential in PowerShell wants a username and password. It's going to prompt for a username and password, but in this sense, we're just using this input to get a password. So I'm just going to type in the password here, and then just type in anything for the username because we are not going to be using the username in this. And I'll go ahead and hit enter. And then you can see here that it already output a few different warnings. A Bertram is taken and D Trump is taken. It did that because we had some warnings here. Right warning, username, whatever the username is, taken. It did that for each of the other ones. So it's really smart. You can write PowerShell to give you really great output and different verbose warnings and things. So notice that the verbose statement here, this didn't show up. Well, the reason was because we didn't have our verbose preferences on to see that. Let me actually show you how to run this through with verbose. I'm going to go ahead and delete all this stuff out that we just created here. So there was one in accounting, there was one in janitorial services here, and there was one in HR. Yep, okay. All right, and then I have to delete J. Murphy here. So let's run this again, and this time I will run it with verbose preferences on so you can see more information about what's going on. To do that, I will just assign verbose preferences to continue. Then I'm going to go ahead and run this again. All right, now you see the verbose output. We got more information about what's going on. It gives you a really good way to verify what's going on. So just going from the first example there, it's checking the username, A Bertram, is that available? Then it says warning, nope, it's not available. Then it automatically goes back to the first initial, middle initial last name, checking that one, great, and then now it's creating and then it's done. Adding a user to the all users group, done, and then just does that for every single one of them. You just define the actions that you want to take on each of those users, and it does the exact same thing for each user. As with any good course, we need a project to work on throughout. In this course, we'll be building a tool called AD Health Check. The purpose of this tool is threefold. By building a tool in PowerShell, this will greatly help solidify these concepts in your head. It's a great learning tool to use a project like this. You'll also come away with a tool that you can use today. This will be a tool that can keep Active Directory healthy in a number of different ways and give you much better visibility into the inner workings of AD. This tool is going to be built like a real PowerShell project. We'll go through 3 rough phases of first figuring out what we need to do, incrementally adding on any new features we need, until coming away with a finished tool that can be used when we're done. This AD Health Check tool is going to cover 5 different sections. It will first be able to query user accounts and discover interesting information about them like expiring passwords, locked out accounts, and so on. We'll also get into computer accounts as well to discover machines that haven't been used in a while or figure out the computer location and a few other things. We'll next get into managing groups. Our tool will be able to query all groups, members of the groups, group permissions, and stuff like that. These sections we'll cover in the next module. Next, we'll take a look at overall AD health. This will entail monitoring AD replication, checking on the database to ensure it's healthy, building a simple front end to the DCDiag tool, and a few other things. This will be in the module afterwards. And finally, we'll build some capability into the tool to produce great looking and intuitive reports which put together different sources of data to create a better way to visualize what's going on in your AD environment. The prereqs for this course are going to be pretty simple. You're going to need at least one domain controller running Windows Server 2012 R2 or greater. You also need a single domain joined Windows 8.1 machine or Windows 10, and ensure you have PowerShell v4 on it or later. And finally, since we're not going to be changing anything in this course, you'll just need read writes to a lot of different objects. I'll be running as domain administrator in my demo lab just to ensure I don't have any security problems as we progress, but you need to know this ahead of time, so make sure you have an account that can read all the various objects in Active Directory. There are a few ways you can interact with AD with PowerShell. The easiest is to use the Active Directory PowerShell module, which is part of RSAT, or the Remote Server Administration Tools package by Microsoft. RSAT is a package that consists of different client software like Active Directory users and computers, the Hyper-V console, cluster management, and a lot of other tools are in there as well. For us, the only thing that matters is the Active Directory PowerShell module, which is included in there. We'll need to get RSAT downloaded and installed before we can do much of anything. To allow PowerShell to work with Active Directory, we're going to use the Active Directory module. That module is part of a software package known as the Remote Server Administration Toolkit, or RSAT, from Microsoft. This is just an MSU package you can download from Microsoft, and technically we could just go to the web browser, download it, install it, but what fun is that? This is a PowerShell course. So let's go ahead and do this all from PowerShell. The first thing we need to do is download RSAT from Microsoft, and to do that we can use the invoke web request command here. Now the invoke web request command goes out and queries any kind of web API that you want, and in this instance we are going to be using the out file parameter. This command is going to go out to the URI that we provided here directly to the MSU, and then it's going to save the MSU to our local machine as C Windows 8.1 and then the name of the MSU. So I'll go ahead and run this now and I'll show you what happens here. So you notice that it's going out and it has a progress bar, writing request stream. It's giving us an output of how much it's downloaded so far. So just think of it as like poor man's download progress bar. And this progress bar that you see here is a built-in feature of PowerShell. So you can use that progress bar for any number of different scripts or modules or whatever you use that take a long while. You can always bring up that progress bar with the command known as write progress. So now it should be downloaded. So let's make sure we'll run test path here. Test path does return true. Great. All right. So we got it downloaded. Now, just like our cmd.exe, we can just run exes directly from PowerShell here. So in this case, I'm going to use WUSA, the install switch, the name of the MSU, and then I'm going to do a no restart. So I'll go ahead and run this. Looks like with the ISC and with the PowerShell console, you can see that it still can bring up the error messages and the message boxes that you're used to. So I think that this is saying that I missed the quiet switch. So let's see here. As this is installing in the background, I'll go ahead and come back here in a minute and we can finish the rest of the demo. Welcome back. RSAT is now installed, so now let's just verify to make sure it's showing up. To do that, I'll just go into the Programs and Features control panel app in here with appwiz.cpl. So I'll go ahead and run that. It's in Turn Windows Features on or off here, so it's in the Windows Features category. And when I scroll down, you'll see, yep, I have Remote Server Administration Tools. If I drill down in here, see that it contains a lot more than just the Active Directory stuff. It has DNS, DHCP, WSUS stuff. It has all kinds of different client features, how you can manage various Microsoft services. That's about it for installing RSAT. So in the next slide and demo, we're going to get into the Active Directory module itself and get it set up and show you how to use it. As I mentioned in the earlier slide, the AD module is part of RSAT. It's the tool that's installed on a client to allow PowerShell to interact with AD. It can be installed on the client, which we'll be doing here, but whenever a server becomes a domain controller, it also can be installed there as well. But it's generally not recommended to perform actions directly on the DC itself anyway. The Active Directory PowerShell module is the link between our PowerShell scripts and AD. It's pretty involved and has a lot more commands than what we'll be using. You'll see in this course that it contains over 150 commands that really make what used to be complicated tasks much easier. So we've now got the RSAT software package installed. Now it's time to really get into the Active Directory module itself. So in this demo, we'll go ahead and make sure it's installed properly, make sure all the commands are available. Then we're going to go over some general ways that the Active Directory module operates. So once the RSAT is installed, you go in here into Windows and Features, and then I will go here to Windows Features, and instead of just checking to see if RSAT is installed, I'll dive down here and go into Role Administration Tools, ADDS, and ADLDS tools, and then you see right there the Active Directory module for Windows PowerShell. Before, this was not enabled, and you had to go in here and manually enable it. It looks like now that they went ahead and just enabling this by default. So that's where you would check to make sure the module is installed. Once you confirm that it's showing up in programs and features, then more importantly, we need to figure out if it shows up in our PowerShell session or not. To do that, I will just go ahead and use get module again with list available to make sure it shows up and is available to us. Looks like it's there. It is in C Windows, System32, Windows PowerShell, v1.0, and modules, so that's good. Let's check out the commands that are in it. Make sure all the commands are showing up properly. Looks like all of the commands here, there's quite a bit of commands as you can see, so all the commands did show up. And now when I did that get command, it should have imported it for me automatically. So let's just make sure here. In order to enumerate all those commands, it actually had to do the import. So if you recall from the previous modules, if I just use get module with the module name, then it just checks all the modules that are currently loaded in our session. Looks like we are good to go here. When the module is loaded, what I usually try to do first is just make sure I have the right permissions to do what I'm going to do. And in this course, we're going to generally focus on 3 different commands. We're going to go into some other ones, but these are kind of the 3 general ones. I just want to make sure that I can read a user account, read a computer account, and read a group in Active Directory. So I'm going to use the get AD user command that's inside of the Active Directory module. And that command has a parameter called filter. Using the filter, I can filter out SAM account name equals administrator. So what that means is I'm only going to be returning usernames that match administrator. So when I run that, you see that I did get something back. At this point, what it is doesn't matter as long as it didn't get an error. If I would have gotten an error saying like permission denied or access denied, I know there was going to be a bigger problem. So I'll do the same thing with AD computer. That has the same filter, and you'll notice the filter is a common theme here. A lot of the AD commandlets have the filter parameter, and they all operate the same. They all operate from the Active Directory filter. So I will go ahead and check and see if I can get a domain controller. Yep, I have permission there. And I will finally do the same, see if I can get information about the domain admins group, and I can do the same there. So that confirms that I can at least have permission to read users, computers, and AD groups. So I know that's good to go here. Another thing I wanted to mention before we got too far into using the module is kind of the nuances of how this Active Directory module works. Here is the typical properties that you'll see whenever you run get AD, user, computer group, a lot of the different get commands in the Active Directory module. You know, there's 9 or 10 different properties that you'll see by default. If you remember from one of the last modules, we can typically do select object star, which would get all of the objects that are currently there. I'll run this again. You see that we got a few other ones, but if you're getting an AD user has a lot of different attributes to it. There's a lot more than just what's shown here. You may think, well, what's going on? Well, a lot of the Active Directory modules commands have a property parameter directly on the command. So you see here with get AD user, I can specify a property parameter and then do a star, which will then get all of the properties of that object. So if I do that, you see there's a whole lot more here. That's one thing that really tripped me up whenever I first started working the Active Directory module. I would pipe it to select object star and think that's all the properties there, but the Active Directory module behaves a little bit differently than we're used to. It's grown some skepticism over time, but it's generally just about the best way you can interact with AD. Just remember, if you don't see the properties that you're looking for, use the property parameter and then do a star or whatever property you are looking for. And one other thing that you may notice is if you've been working with Active Directory for a while, you know that each object has specific attributes to it. So there are specific Active Directory attributes. And then there's PowerShell properties. The Active Directory modules commands tend to give you a different view of the Active Directory attributes. So let me show you an example of that. Here is, I'm using what I call the old school way of pulling information from AD with ADSI. ADSI was what we used to use with VBScript. It definitely still works with PowerShell here, but you can see that it's much less user-friendly than using the Active Directory module for. But on the flip side, it does give you all of the attributes for a particular object. I will go ahead and just grab all of the attributes for the SAM account name of administrator. And when I do that, you'll see that these are specifically Active Directory attributes. So notice that they all are lowercase. When you do this in PowerShell, it kind of messes with the case a little bit. And generally, this is output coming straight out of Active Directory. Now let's compare that to getting the same information with get AD user here. So we'll go ahead and get this same information with AD user, output that, and then you'll see that it has a lot more properties, but at the same time, there's a lot in here that weren't necessarily Active Directory attributes. What it does is it tries to make a friendlier output. Notice that these are specific date times. These are bad password time here. There's a lot of different parameters in here that aren't necessarily Active Directory attributes. Just remember that PowerShell adds on additional ones and sometimes modifies the format of the actual Active Directory attributes. A really good example is last logon. The real attributes has the last logon parameter here, and I believe I can get to it by doing real attribs.last logon. The last logon, that is actually a date that the time that Active Directory user account was last used. This isn't very friendly. You can't figure this out. There's some ways to do this in PowerShell to convert this to a date time, but one of the great things about the Active Directory module, it does it for you. So whenever you do this with the Active Directory module, it has last logon, which is that big integer, but it also has last logon date, and then it has the actual date. It does that conversion for you. The biggest thing you need to remember is the Active Directory module does have a lot of great features and makes reading the output a lot easier, but do not just assume that the attributes for whatever object in Active Directory is going to be exactly the same as what get AD user, computer, or group will provide to you. Hello, and welcome to the next module in our course, Interrogating Active Directory Objects. In this module, we're really going to get down into coding. We're going to dive right into PowerShell and how to use it to perform a number of different Active Directory tasks. There are two different ways to interact with Active Directory with PowerShell. The first is interactively. This is doing things like checking a particular user account, maybe enumerating all of your domain controllers quickly, or really any other ad hoc task you might choose to do. One way to do these ad hoc tasks is to use the Active Directory provider. The AD provider is a way to interact with AD much like you do with a file system. We'll go into this topic in the next demo. If scripting, however, you want to use the AD commands like get AD user, new AD computer, and so on. It's possible to use the AD provider to write scripts, but you'll probably find it's much easier working with individual commands instead. So let's jump into a demo now on PowerShell providers, how they work, and what the AD provider looks like. All right, so let's go ahead and focus on the first way to query Active Directory, and that's through the Active Directory provider. And as I briefly explained in these slides, the Active Directory provider is similar to a browsing Active Directory via the file system. So let's go over quickly what that's going to look like. A PowerShell has this concept of a provider, and a provider is retrieved by using get PS provider. So if I run this now on my system, you can see here that I have a few different providers here, and each of these providers is essentially just kind of a grouping of like things. Like, for example, the registry is a hierarchical representation of keys and values. Similar with file systems. You can think of a file system folder as just like a registry key, because a registry key has values inside of it. A folder has files inside of it. So it's similar to what a file system is. To be able to see those, you can use get PS provider here. And you can use get PS provider and specify the PS provider parameter here, and just to get one of them. So let's just say I want to see what file system is. You can see here that the PS provider has one or more different drives inside of it. The file system down here has drives C and D, so that's just your typical C and D drives. However, the registry up here has the HKeyLM and HKeyCU drives already attached to it. Just think of the PS provider and PS drives very similar to the file system. To dive a little bit deeper and see what drives are part of the PS provider, we can use get PS drive. And get PS drive enumerates each of those drives that are part of the PowerShell providers. This gives you a view of each of the drives and each of the providers associated with each of those drives. You can see that we have all of the drives here. Notice that we have the AD drive, provider Active Directory, then we have the root of root DSE. That's because we already have the module imported here. So let's just go ahead and remove this. I'm going to show you what this looks like when it's not here. I'm going to go ahead and remove the PowerShell module from the session. Run this again, and then you can see there that the PS drive is part of the module importing process. So you can see that the AD drive is gone now. Let's go down a little bit deeper and see each of the items inside of the drive. A file system listing with get child item is a very familiar process, I would assume, just grabbing the files from the file system drive. Now let's import the Active Directory module, and when I do this, you may see very quickly the progress bar that shows you that it's actually creating the Active Directory drive. So let's see if you can see that. Sometimes whenever it's slower, it'll show it real quick, but sometimes you don't even see it at all. So we didn't even see it at all. So you'll just have to take my word for it here. Whenever we did that, that actually loaded up the PowerShell provider, which in turn loaded up the PowerShell drive. So now we can run this, and it looks like, oh, I had the wrong name here. So let's just run it without it. So we use the parameter by position here to find this. All right, so that worked. Whenever we run get ps provider Active Directory, you'll see that it has the AD drives inside of it. Now that the PowerShell drive is loaded, we can just go through it just like a file system, just using get child item and the path of AD. So now you can see instead of files and folders, it brings back domains and application partitions in Active Directory. We can provide specific paths just like we can a file or a folder in the file system. We can also do that in AD now. I just provided the path of the domain name. You can see now that it brings down organizational units, containers, and things like that. So instead of files and folders, it's just Active Directory objects. One other thing we need to discuss was the filtering. Whenever you use PowerShell drives and PowerShell providers, each has a different filter to it. If you've used get child item before to enumerate files and folders, you may have seen a filter parameter here. If I run this, this will actually filter out any files or folders based on my pattern there of star Bertram. Now notice that nothing came back, but then again, it didn't also send an error. Now it didn't give me an error because the file system provider itself understood the syntax of star Bertram here. So it understood that's the appropriate syntax. However, whenever you use the filter with the same star Bertram here with the AD drive, you'll notice that it's going to give you a different output. So now notice it says the search filter cannot be recognized. That's because each filter that you use here is PowerShell provider specifics. So the Active Directory filter doesn't understand what star Bertram is. It needs to be a different format. I'm not going to go into each of the little nuances between them. For now, I just wanted to let you know that whenever I use the filter to filter files and folders, I just naturally assume, oh, I still have filter on the get child item command here. I could just use the same filter to do the same thing for Active Directory objects or even for the registry. No, that's not the case. Each of these has a different filtering language, a different filtering query syntax that you'll have to learn and kind of get used to. One of the most common tasks you'll perform in PowerShell is building functions. We'll do a lot of these in the course. Functions are sort of like building blocks. They're a way to group commands together and all the logic together to form a common task. Functions allow you to start small, and then as you begin to accumulate more and more functions, you'll find that coding time will decrease because you're able to reuse code a lot. Functions have three phases: an input, processing, and an output. PowerShell functions are very similar to a script. A script can have parameters, which can be provided at runtime, which is input. The script runs, which is the process, and it can optionally output something. A function does the same thing, although it's within a PowerShell session and it's not actually a file. Let's get into another demo where we'll build a function. So let's now get into how to build a PowerShell function. Before we do that, let's first cover scripts, and we're going to be talking about how to build scripts and eventually convert these scripts into functions. So let's get started with that. The first thing we do is we just start out with a script. You've probably built at least one or two scripts in your day, but let's just go over an overview of that. And as we go through here, we'll see that we're going to convert this script to a function. I built a script here just called script.ps1. And you can see that this script just says, hi, I am in the script. So it just sends some output to the console here. So not anything big at all. And essentially, a script is just a text file with a PS1 extension. So we can open this up in Notepad if you wanted to, and it will show the exact same thing. Now, because it has that PS1 extension, and it's because it is PowerShell code inside of it, the PowerShell engine understands it and can execute it. If you are not in PowerShell, PowerShell can invoke scripts from the command line, so from cmd.exe, for example. So you don't have to actually open up a PowerShell console to invoke a PowerShell script. So you can see that here where I will just invoke PowerShell.exe and pass it a file. And then it says, hi, I'm in the script. Now, since I'm in a PowerShell console here, this actually spun up another PowerShell process and then ran this script inside of there. So at the time it was running, I actually had two PowerShell processes running. Since I already have the PowerShell process running here, I don't necessarily need to bring up another one to do that. I can just invoke it straight from the console here, which is the same thing. Because we have a variable here called demo path inside of here, I have to enclose it in double quotes, and then I use the ampersand symbol there to make it executable. So if I would just put this alone, you'll see that it wouldn't understand what it is. It just interprets it as a string at that point, so it wouldn't actually make it executable. Let's convert this same functionality to a function. First of all, why would you even want to make a function? Functions are great at essentially replacing scripts for the most part. So think of a function as sort of like a little building block inside of a script. Functions can either replace scripts or you can put different functions inside of a script. Now there's a lot of different advantages to building a function versus building a script. For example, you may lose a bunch of scripts. You may have scripts all over the place and you don't know what they do in the first place. However, with a function, if you can group all that code that you have inside of scripts into one or more different functions, you can just put those in your profile and then be able to have those at your fingertips. I can do some of these built-in ones. So I can do get content and you know that's going to work, or I can do test connection or something. All of these are going to work. I don't have to worry about the test connection.ps1 file, where that at, so I can execute it. These functions are always loaded inside of your console. So let's just build a very basic function now to show you how to do that. To build a function, we start out with the function keyword, followed by the function name. So in this instance, I'm building a function called do-thing. One thing you need to realize whenever you're building functions that PowerShell has a unique way of naming things. Technically, you can name a function anything you want, but there's a specific set of approved verbs that you could use. PowerShell has the verb dash noun, so it has the do thing, so a verb and then a dash noun. However, I'm kind of breaking the rules here because this do is not actually an approved verb, at least I don't think it is. PowerShell has the get verb command. And you can see that whenever it returns, these are all the quote-unquote official approved verbs. Add, clear, hide, join, lock, all these all on the left here. But these are all the verbs that you're supposed to use for your function names. You won't notice anything if you're just building scripts and functions by themselves, but as soon as you start to build modules, you'll see it'll occasionally throw some warnings say you're not using an approved verb or whatever. It's really a good way to utilize best practices and so that everybody can understand if you ever share your code, what your code does in the first place. Whenever you create this, you have the function keyword here, and then you have the name of the function followed by curly braces. And inside of the curly braces, you have whatever code you want to do. So in this case, I just have write output, I did the thing. Every functions have to be loaded into memory, so they have to be loaded into your session. So to do that in the PowerShell ISE, I would just highlight everything and go up here and hit run selection. It won't do anything because it's not actually executing. That's just loading the capability of the function to be used. Once it's loaded, I can then call it as many times as I want. So I do thing, do thing, do thing, I did the thing. It's actually executing the code inside of here. Another thing about functions is you kind of think of functions as bundles of code that have inputs and outputs. On this function we just created, it has an output. It really didn't have any inputs. We ran it and it just output, I did the thing. It didn't have any inputs. However, that's not real common. Most of the time you're going to have parameters for things. So let's first grab the output of this do thing here into a variable. And then once it's in the variable, I can run some logic against it. So I can run, did it equal I did the thing, and that equals true. Whenever you capture a function's output like that, you can do all kinds of things in the function. You could just capture it into a variable and then do some comparison, do some manipulation of the variable, or whatever you want to do. So let's take this to a different level here, and let's add a parameter. Parameters are essentially just different ways to provide the ability to send input to functions. So in our do thing here, I'm building a single parameter called attribute. And whenever I create this param block here with the parameter attribute, then that attribute is available inside of the code itself. I can reference it here. You can see with this function here, I'm running write output. I did the thing with $attribute. That's going to be the name of the attribute whenever I pass it in. So let's bring this into memory. And whenever I bring this into memory, notice that it's the same thing here. It just essentially overwrites what I previously had. I can now run this, and instead of just specifying do thing, I can specify a parameter -attribute and then give it an argument. In this case, it's going to be whatever. So I'm going to run this, capture to variable, get the variable, and now see it says I did the thing with whatever. So it's going to replace whatever is in the attribute right here. So that's a way to provide a parameter to a function. Now here's a good example of functions working together inside of a single script. So I've already created a script here. So let's go ahead and take a look at this. So in this script, I have two functions, and then I have some code inside of the script itself that aren't inside of functions. This is very common whenever you're working with scripts. You'll have the functions declared at the top, and then once the functions are declared, then you can call and use the functions however you need to down here lower inside of the script. But you first have to get the functions available. So for this example, I just have a small function here called find text file. It just essentially looks for a set of text files inside of the C demos folder. I also have a set text file, which changes the value inside of a file based on the path. So really simple stuff, and in reality, you probably don't need a function to do this because you can do this directly with set content and get child item, but just for demonstration purposes, we'll just go ahead with this way. So the first thing I want to do is I will capture a text file into the output here. So I run find text file, name, whatever. This is going to call the function up here, and then it's going to search for whatever. So it's going to be just like that there. All right, so we'll remove that. Let's just load in both of these, like I'm going to be calling it all at once. So we'll load in both of those into memory, and then we'll run text file. Oh, cannot find the path C demos because it does not exist. Let's just create this folder real quick, C demos, and I was searching for whatever. All right, so let's just add a file here. Now we should have two files inside of there. So when we run this again, now that we have the two files loaded up inside of the text file variable, I can already know from experience that this is not going to work, the situation that we have in. That's because we have two files in here, and I don't have my set text file function prepared for two files. So right now we just have a single path, a single value, and set content can only do a single file at once. Actually, you know what? Let's go through and see if this actually works. This may be a good educational experience here. So we have two files inside of text file, and then text file now contains the properties for each of these. Now let's just see what the text file.fullname is. So notice now we have the full name is C demos whatever.txt for both of these. So we have two of them in here. And I'm going to run set text file, and it's going to pass in both of these paths here, and it's going to change the value to I changed this file. So let's just see if it works. I stand corrected because sometimes set content or whatever function or command that you're using, you can actually pass in one or more different paths. In this case, we passed in two paths inside of here. So let's see what each of those has in them now. So it looks like get content can actually do two of them as well. That's one thing you need to realize, that sometimes lots of different commands have parameters that can do one or more different elements at the same time. So for example, on this one, I could have done get content, C demos, whatever text, whatever to.txt, so just doing one thing, or separated with a comma, we could have done C demos, whatever text, comma, C demos, whatever to.txt. It understands that you're passing two files instead of just one, and you need to do that. To figure out if the command can accept one or more, you can use help for that. So I'll use get help, and I'll use get content for this example here. And then I'll use the detailed switch here to get all the details. Now scroll up and go to the top here. There's a lot of stuff in get content. So let's find the path parameter. Actually, let's just make this easier. We'll do get help, get content. We can specify the parameter itself. I believe it's path. Whenever you want to know if a commandlet or a function can accept one or more arguments for that particular parameter, you'll see that whenever you use help and provide the parameter here of path, the top there has dash path and has string followed by 2 braces. Now notice the 2 braces. That's what you're looking for there. If it doesn't have the left brace and right brace, that means that it just accepts 1. So let me give you an example. So let's check out a parameter of the raw. Notice that raw is a different type, raw switch, but see, the switch doesn't have the left brace and the right brace. That means you can only put 1 item inside of there. So if you're ever curious if you can provide 1 or more arguments inside of that parameter, that's how you would do that. So that was our primer into building PowerShell functions. As we go through the course, we're going to build lots of different functions. We'll go through some further advanced steps, so we'll learn more about how to add on to the functionality of a PowerShell function. Time to get into some AD objects. We're first going to cover computer accounts. As our first foray into computer accounts, we're going to learn how to read them from Active Directory using the get AD computer command. As promised, a PowerShell learning concept will be attached to these and future demos as well. For this demo, we're going to focus on building and executing a script, learning about dot sourcing, and see how you can quickly turn a script into a function. So let's now get started into applying our PowerShell skills to Active Directory. So I'm assuming that you already have the Active Directory module loaded. Because of that, you will have the get AD computer command that we will be using in this demo. So you can see that I've already created a script and I've called it get Varonis computer. Now I called it get Varonis computer because this is going to be part of our project, so our group of scripts we're going to be creating. Now right now, get Varonis computer.ps1, it's not a good script because you can see that I have some demo code here that I'm going to be explaining some concepts for. However, as we progress through the course, I'm going to add some different functionality to this script so that we can use it in combination with some other things so that you can actually use get Varonis computer in the real world and query various Active Directory computers in any way you want in your own environment. To get started with figuring out how to query Active Directory computers, we're going to use the get AD computer command. And the get AD computer command is a very common command that you would use inside of the Active Directory module. So let's just run it and see what happens. The first thing to notice is whenever you run it without any parameters, it's going to prompt you for a filter. It's prompting you because the filter parameter is mandatory. So you cannot run get AD computer without providing something for filter. We can either do a star in here and then hit enter and it'll go ahead and run through, but it's always a good idea to not put any kind of interaction inside of your script. You want some autonomy in the script. You don't want to have to provide input to a script all the time when you're trying to run this in maybe a scheduled task or some kind of unattended instance. To do this, we should provide the filter and then specify the star all in one shot here. And when we do that, it's not going to prompt us anymore. As you can see, it's just pulling down all of the different Active Directory computer accounts that I have in my current domain. One thing that really got me when I first started was, as I was looking through here, I would see, for example, on this bottom computer 1000, and you have all the properties from distinguished name all the way down to user principal name. If you look at another one here, you can see that each one has those individual properties here. Just to demonstrate that, let's just grab the first one. To do that, I can use select object dash first one. Every computer that comes back with get AD computer comes back with an object with a certain set of properties here. So let's say we use the first one and we're just going to skip one. So that's the next one. So member serve 1. And then we have DC. Notice they have common property names. When I first started, I know Active Directory. I know there's a lot more attributes to each computer than just these few different properties here. Where do they go? So my first inclination was to do something like this. I would do dash first one, and I was aware of the property parameter here, and I would use property star. And I would think, okay, well, that's going to give me all of the properties. But notice that it added some things in here that don't make any sense. Property names, added properties, remove properties, property count. Those aren't Active Directory attributes. Does get AD computer not even provide these properties? Well, this is a nuance of the Active Directory module. The Active Directory module has a parameter called properties that allow you to specify these. There's a lot of talk in the community where the Active Directory team at Microsoft didn't really design the module quite right, not adhering to the typical community standards, but we're not going to go into that at the moment. Anyway, to get all the properties with Get AD Computer, you actually have to use a star here on a different properties parameter just specifically related to Get AD Computer. So when I run this, now you'll see a lot of different properties in here. So just so we don't have to scroll through each of these, I'm just going to grab one of them. So I'll specify properties star. Now notice that most of your Active Directory attributes come back, and you'll see that you can get a lot of the information from a lot of these. If you're just kind of looking at this, you're eyeballing this, you may think, well, this is all of the Active Directory attributes for a particular computer. Well, that's still really not the case. There's a lot of things like the custom attributes, the exchange things, and there's a lot of other less used attributes that don't show up in here. But for now, this is the huge majority of the AD attributes that you'll need for an individual user account. This is pretty much all there is to Get AD Computer. Now, you can go through the help, and there's a lot of options inside of the help. We're going to go over filtering a little bit later, but just to get you familiar with Get AD Computer and what it does, really that's just about it. If you're running this on a domain join machine and you have the ability to query Active Directory computer accounts, you'll see that it's really easy. If you're trying to enumerate Active Directory computer accounts in VBScript, it's a whole lot harder. That's why I chose to use the Active Directory module. Even though it has some nuances like the properties parameter there, it's so much easier, it saves so much time to be able to query things out of Active Directory. Next up is AD User Accounts. AD User Accounts are retrieved using the Get AD User command. You'll see that this command is similar to the Get AD Computer command, so we're not going to spend a ton of time on the command itself. Instead, we'll focus on the PowerShell learning concept. In the upcoming demo, we're going to learn how to query AD for user accounts from a first name and a last name. Instead of just typing them into the console, we're going to use a CSV file to read these names from, and then pass those to Active Directory. To do that, we're going to learn about loops in PowerShell and how they work as well. Now that we've went over AD computers, let's just go ahead and see if we can query AD users. You'll see that querying AD users is pretty much the exact same process of querying AD computers, because after all, a user and a computer are just objects with attributes inside of Active Directory. So the same process applies. We just replace Get AD Computer with Get AD User. And the commands have the same exact behavior. Filter is necessary here, so we just specify filter, and you'll see that we have all of the Active Directory users that come down. Same thing with AD Computer, where it doesn't specify all of the properties at once. We can use the properties parameter with the star, or if we want to, we can bring down individual properties by specifying individual ones. So let's just say we want to do password expired. And you see that we have password expired there is false. However, if we take it out, no properties at all, you see no password expired here. And if we want to do all of them, we can just do star. And this is exactly the same process with Get AD Computer, so I'm not going to go over that anymore. Because this course is going to be not just how to work with Active Directory in PowerShell. I'm trying to teach you PowerShell at the same time, and this is a really good area to do this in when you're working with a set of objects or a set of data. In this case, we are working with a set of AD users. A common reason to use Get AD User is that you have a set of users that already exist somewhere in a CSV file. In this instance, I have a CSV file full of users. So let's just go ahead and see what's in this CSV file. To read a CSV file with PowerShell, you use the import CSV command and then specify the path of the CSV file itself. So I will go ahead and run this, assign that to a variable, and now I have CSV users. And I can see in this CSV file, I have first name and last name. and they each contain different employee names, whatever have you. So I have this in a CSV file. Now, this could be a CSV file, this could be a SQL database, this could be an Oracle database, this could be just about an Excel file, this could be any kind of data source that you want. PowerShell has ways to grab whatever data that you need from a specific data source and compare it with another one. That's what I really like about PowerShell. To do this, I'm going to use the CSV file to filter out the Active Directory users that I want to see. Before, I just specified the filter parameter and then set a star, so I wanted to see everything. Well, in this instance, let's just say I just want to see the users inside of this CSV. Well, notice that it's just first name, last name. There's no unique account name, so we need to do some matching to make that happen. To do that, I'm going to first grab all of the AD users with get AD user and then specify the star parameter here. So I have everything saved in all AD users. This brings us to loops in PowerShell. The first kind of loop I'll show you here is called a for each loop. Now I'm using what's called a for each statement here. And a for each statement is declared by specifying the for each keyword here. And then in parentheses, you have a variable in and then your data set. So in this case, the U variable is going to represent the iteration variable. So it's going to reference, in this case, each user that's represented with all AD users. If I just put this to the console, you see that it does everything really quick. So it just dumps out everything all together. This natively iterates through each of them in here, but it doesn't allow you to actually do anything to the users as they're iterating through. So if I run this for each loop, I'll see that it does the same thing. You're going to get each of the users displayed out here in the console. I'm essentially just reading every user inside of this all AD users variable and then just outputting it to the console. Well, that's great, but that's not very useful because we can do the same thing by just outputting all the AD users, which will do the exact same thing. The benefit of using the for each loop here is that you can do things to each of these users as you're iterating through. Now, I'm going to do the same thing here and just do it for CSV users. So remember that for our CSV users, we had each of the users with first name and last name. So we have multiple different objects. So each of these first name, last name is a different object. And we're going to iterate through each of those objects and then do something to each of those. In this case, we're not really going to do anything. We're just going to use those as input for our search query for our Active Directory users. So in this case, you see that I'm going to iterate through each of the CSV users. Each iteration variable is going to be called CSV user. So let's just take this back a notch here. And then let's just do what CSV user dot first name. Whenever we display this, you see that with the dot notation, we can reference that object property and just specify the first name here. We get the first name. The same thing with the last name. If we do last name, run all of this again, you see that it gets the last name. It's just iterating through each of those different objects inside of there. What I'm doing here, I am using the CSV user first name and last name as input to where object to pass to my where object filter to filter out users inside of there. To demonstrate this, let's first grab the count of all the users. To do that, I can just do this and just do count so that I have 22 users inside of my all AD users command. Now, whenever I run this, that's all the users, but I don't want all of the users. I just want just the users inside of my CSV file. To do that, I am iterating through each of the users inside of the CSV file and using each of those iteration variables. So I'm using the iteration variable as CSV user, then just doing first name and specifying last name here. This will represent the first name and last name of each of those usernames. I'm doing this, putting this in the where filter, because all AD users, each of the objects inside of there have individual objects as well. So let's just do one of these here. Select object, first one. So notice that I'm going to be using given name and surname. Surname here, in this instance, is nothing. And given name, in this instance, is nothing as well. So I'm going to be referencing each of these in my where object filters. Essentially, as the for each loop goes through every single one of these CSV users, it's going to fill in this where object filter script here And they're going to compare, does the first name and last name equal some given name and surname inside of Active Directory users? Let's run this and see what happens. So it did find some users. So let's see how many it finds. I'm just curious here. Here's a quick tip for you. I'm just going to make a little counter variable here called I. I know that if this statement right here, if this returns anything at all, right now it's going to the console. But I just want to see if it actually returned anything. To do that, I can just enclose this with an if statement inside of my for each block here. So this just says if you returned anything at all. That means in this case, if given name is equal to csvuser.firstname and surname is equal to csvuser.lastname. If you returned anything at all, then do ++, which is a shortcut to increment the value of I in this instance. Now, that's going to increment that when it finds a match for each of these. So just a real quick way to give me a count. So I will copy all this here, and then now see what I is. See that I is 14. Well, that means that for 14 of those 22 users, there was a match inside of all AD users. You'll see these for loops are very common in scripts. They're a really good way to iterate through a common set of data sources. And you can do all kinds of different things. And we're going to be going into more depth and using these a lot further on in the course. Next up is groups. Groups, just like users and computers, are objects in AD. As such, the Active Directory module has the same general naming scheme for the command to retrieve groups called getAdGroup. Since groups are a little different than computers and users since they have subcomponents called members inside, we also have a getAdGroup member command that will help us retrieve those as well. As for the learning concepts in the upcoming demo, we're going to dive into objects and properties. We're going to go over a great example to build your own custom objects to get the output you're looking for. I've also intentionally broken this one down in incremental sections. As I was building the demo, it progressed into multiple stages and kind of grew from there. You'll see that this is a common occurrence when building PowerShell code. The upcoming demo is a great overall representation of iteratively building onto code. Next up is AD groups. Just like with AD computers and AD users, we will use getAdGroup. Very similar, have to use the filter, hit star, and it'll bring down all the groups. Exactly the same as the other commands. This time we're going to be getting into one other command here called getAdGroupMember. Groups are a little different than users and computer objects because a group has sub-objects inside of it called group members. That's why we have getAdGroupMember here. So let's just go over a quick demonstration of what getAdGroupMember looks like. Let's say we want to grab all of the members of the domain admins group. So we'll say domain admins equals getAdGroupMember. Identity is domain admins. Here's all the group members inside of there. So we have 3, it looks like. Let's just limit that down to name. We have administrator, the SCCM, and then an IT admins group inside of domain admins. So that's essentially what getAdGroupMember is. I'm going to be using this demo for groups to show you a real-world way that I write scripts in code and things like that. It's an iterative process. So you look at one thing, you see the output like, well, no, that's not really exactly what I wanted. I'll tweak it this way. And then, no, that's not really what I wanted. I'll tweak it that way. So this is what I'm going to be doing here. So in this instance, I want to build some kind of output that allows me to see all of my groups with all of my members. You can sort of do this with the members property of each group. Whenever you specify filters and then look at the members property of each of the groups, you can see that it has a members property and then it has each of the members inside of there. So let's limit this down a little bit and show you what this looks like. So let's look at the first group here. So that one doesn't have any members in it. Let's just skip 5 of them. Oh, backup operators. Looking for one with some members in it. All right, let's cheat a little bit. Just do where name equals domain admins. Technically, we have the name of the group and the members inside of it. But notice that in the members, we have groups inside of members, computers, and users. So let's just expand this out. If we do expand property, that's just going to bring out everything. You'll see that we have IT admins as a group, SCCM is a computer, and administrator is a user. Now, what if I just want to see all of the users inside that? I don't want to see anything about groups. I don't want to see any computer accounts. So how would we do that? So right now it's not possible. We need to redesign it a little bit. Let's just go a step further. Here's a good way of using the for each loop to do that. So let's first grab all our groups again. And then inside of the for each loop here, we're going to run get AD group member and query out only the user in here. So wherever the object class is user. So let's just run get AD group member again on domain admins. And then we do select name and then object class. Notice that it tells you if it's a user, a computer, or a group, whatever the class of the object is. Now I can limit that here by doing user. So let's just do one instance. This is another good example. Before you do the loop, you want to make sure you get your code right to just do one. So let's just say I want to grab all the users out of here. So let's say this is object class equals user. And then notice that it just pulled administrator out. So that's a way that I can pull out just users for the domain admins group. But I want to do all of them. To do all of them, I can assign them all into our groups variable here and then use a for each loop to iterate through every single one of those. In this instance, I'm running the for each loop. I'm going to run get AD group member for every one of the groups where the object class is user. So only grab the users out of each of the groups and only show me the members property. Now notice that this sorta works. The reason I say sorta is because this is going to last forever. Because the display doesn't look right. To display this out to the console, I'm using the group.name here. Whenever I just specify just group.name, it's going to output that name property to the console. Then it's going to output to the console the result of line 18 here. Now notice that it's not very intuitive. So for example, we have the administrator group, and then we have members below it. We have users, guests, print operators, backup operators. This doesn't work because it's actually showing groups as well as users. So I need to actually change this property here for members, and that needs to be name. Now let's see what that looks like. Now that looks a little bit better. Real world, on the fly troubleshooting here. Now this will work, but the display is terrible. I'm not going to really understand this. Now I'm not going to know that this is the group name, and then I have name and then the dashes, administrator. I can't see what the group name is and what the members of the group name is. We need to build custom object here to make this better looking so we can understand it better. So to do that, I'm going to create a custom object. I'm still going to use a for each loop, and I'm going to iterate through each of the groups again. However, this time you see here in line 23, I'm building a PowerShell hash table. So I'm calling it output. And as I iterate through each group, I'm going to add items to this hash table, and then at the end, I'm going to convert it to an object, and then I'm going to output that. Here in 23, I'm building a hash table for each of the groups. Then on 24, I'm defining a group name key, and I'm making that one the group.name, so that's just the name of the group. Then on 25 there, I'm getting that same output, and then just grabbing all of the group members inside of there. And then on 26, I'm creating a members key, and assigning that all of those group members that I just grabbed. And then on 27, that's where we have PS custom object. This is a really good way to create custom objects from hash tables. So you define PS custom object here, and then you put a hash table right after that, and then it just does a translation or a conversion in the background. So let's just see what this looks like now. So yeah, we have members, and they have group names. So like the WinRM remote WMI users group name doesn't have any members. The administrators group has the administrator member. Users not have anything. Guest just has one. Print operators. But notice that it still isn't that good to see. Yeah, it's nice. I can sort of see what's going on, but I want to take it a different level. I don't want to see the groups with no members in it. Just seeing all the space along the left there, it's not very intuitive. So to do that, I will put some if-then logic here on line 40. If there's anything that returning group members, then only create the members property and then output an object. Else, since I don't have an else in here, it's not going to do anything whatsoever. So I'm going to run this again. Now you'll see that there is no big space on the left-hand side for members. You'll see that we have group name administrators, members of administrator, guest, schema admins, administrators, you'll see that there's no space. It's a lot more intuitive that way. However, this really doesn't even still look the best. We can even take this step a little bit farther by formatting this output. Example there for the domain users group, you'll see administrator ... That is cutting that off because the console can't display that. There's some different ways to do that, but let's just use format table here. You'll see a lot of different commands called format list, format table. These are ways to make the display to the output a lot better. So the format table is another quick way to change the output to see what it looks like. I was saying format table, then doing the auto size, which adjusts to the size of your console. And when I ran that, you'll notice that it didn't still even look the best because it had a space here between your outputs of each of your objects. So it really didn't even look the best. The reason it did that was because it was piping this output here, this PS custom object to format table for every single group. Because I was in the for each loop, it was doing that for every single one. I want to do a format of everything at once. You may think, well, I'll just take this out, and then I'll put this down here right below my curly brace that ends my for each loop. Now you notice that an empty pipe element is not allowed. So you cannot pipe everything that comes out of this for each loop to format table auto size. To do that, we can use another type of for each loop here. This is the for each method. Now this was introduced in PowerShell version 4, so you cannot do this with any other version, but the for each method is on collections inside of PowerShell. So since I know there is more than one group inside of this groups variable, I can specify for each. So this is doing the exact same action as that for each loop previously. It's just going through each of those objects inside of groups, so each of those groups, and doing something to them. So in this case, I'm doing the exact same code, so everything here is exactly the same as what it was before. But now notice that I'm allowed to format table auto size at the very end of it. So now when I run this, it's going to wait until it accumulates all of the groups, and then finally when it's done, it's going to output that all at once and then send that all to format table. And then it's going to output it into a very nice format. So notice that we don't get any output now while I'm talking. Before, it was sending things out the pipeline to the console constantly. Now, since we're using format table, it's actually queuing all of these objects up, and then it's going to spit them out all at once and run with format table. Now notice that it's much better looking. We have the group name, we have the members for each. We have on the domain users group, see that expanded out. So we have administrator, the Kerberos, the Katie Holmes, S Help Desk. So it's expanded out a little bit more. To be able to fit these two columns on the console, we were able to see a very nice output there. That was a good example of iterating through and just eyeballing various objects and properties in the display format that you need. This is going to be a very common occurrence whenever you're building scripts in PowerShell. You're going to first figure out how to do one thing. Let's say figure out how to grab a group. Once you do that, how do you figure out how to grab all the group members? Once you do that, you see that it's just a building process. The PowerShells are very good at a building process, so using building blocks to build over and over and make things better and better. We have already done some collection filtering in the previous demos, but I really wanted to build a section here just for this purpose. That's how important this concept is, and not only when querying AD, but any kind of large data set. If you're aware of some best practices around collection filtering, your scripts will perform much better. In the upcoming demo, we're going to cover two ways to filter collections. One way is with the where object command, which we've used earlier. And also we're going to cover the where method, which was introduced in PowerShell v4. I'll go in depth on these two general methods of collection filtering and explain some nuances that you might run across. So in our previous demos, we essentially returned everything that commands like get AD computer, get AD user, get AD group, get AD group member, all of those commands, we just returned everything that we could possibly get in there. We didn't actually filter out anything. The majority of the time, you're not going to want to get everything in Active Directory, especially if you're in a big enterprise where you have tens of thousands or hundreds of thousands of objects in Active Directory. You're going to need a way to filter this out. Now, there's a few different ways to do that. So in this first demo on filtering, we're going to just talking about the basics of filtering. using the where object command and using the where method. So let's get started with that. So the first thing I need to do is I need to build an array. So in this instance, it's just going to be some kind of source of collection of objects. So I'm just going to make an array with 11 different elements in it. I'm doing that with the range operator here. We can use the dot dot, which is a quick way to get elements inside of an array. You see it's 0 through 10 here. So we have 11 different elements inside of this array. Let's just say that I want to only get certain elements inside of that array. I want to filter them out. One way to do that, I can use the where object command. The where object command is a very common command that you can use to limit the output of a number of different commands. It's not assigned to just this array. It's not assigned to get content, to get AD user, to get AD computer. Essentially, where object can be thought of as a generic filter. It will filter out on any kind of output that you can possibly imagine. So for this instance, I'm going to limit the output of anything that's greater than 2. So to do that, I can just use specify array, pipe it to where object, and then do my pipeline variable, my $_, which is greater than, which is the GT operator, greater than 2. Whenever I do this, I see that it just gets me 3 through 10. I'll admit that I was using a quick syntax, so I'm not using the full syntax here. I'm using a positional parameter. You probably won't do this a whole lot in the real world, but this is actually the filter script parameter to the where object command. So this filter script parameter here, this essentially just means if anything inside of here, based on every item coming out of this collection, is true or is some kind of output, as long as it doesn't output either a Boolean false value or null, it will go ahead and output anything. I could even do true. And this will output everything. I'm not checking it against one of the elements inside of that array. I'm just going to say just true for everything. Obviously, everything comes up. This is a condition that gets evaluated against every single one of the elements inside of there. Because I have an array of 0 through 10, I can use that because that is my pipeline variable that's going to represent every iteration inside of there. So when I just do this, because $_ is something, notice that now it's just 1 through 10. Previously, I had a 0 in here. It didn't output the 0 because 0 is another form of Boolean false. Under the covers, this does a conversion. So if this does not output anything other than a 0, a Boolean false value, or a null value, it will return. So if I just do false here, it will return nothing. If I do null, it will return nothing. And if I do 0, it will return nothing as well. But let's just say I do, 56, something random. It will return everything because it returned something other than those 3 different values. However, if you want to run conditions based on items inside of that array, you can do your $_ greater than 2 or equal to 6. Whatever code inside of here evaluates to some kind of output other than the 0, false, or null, then it will evaluate to true and it will send that individual element outside to the console. So another way to do that is to use the where method. As I mentioned previously, went over this a little bit in the last demo, that was using the for each method. In this instance, it's the where method. And as of PowerShell version 4, we have this where method here. And the where method is exactly the same as the where object command. The only difference here is that the where method does not use the pipeline. So notice here on line 6 here that I'm specifying array, then doing my pipe variable and piping all of that to where object. This actually goes through the pipeline. However, with the where method here, you notice that I have no pipe symbol. I'm just using .where, just defining a where method. Now this is generally faster than using where object. You won't see it too much on little data sets like 0 through 10, but you will notice on like tens of thousands of items in a data set where if you're not using the pipeline degrades performance and it really adds some time to the filter. This will be significantly faster. If I'm using PowerShell version 4 or later, I will always use the where method because it's pretty much exactly the same as where object, but it's faster. Now you can also use the in operator as well here. So if I run this, it gets me 3 through 10. And I can use the in operator here because this is essentially saying if any of these 0 through 10, which is the $_ there, is in this array, 3, 4, 5, 6, 7, 8, 9, 10, then evaluate to true. Now, I'm using in here for an example, but you can use that across any number of things. You don't even have to use a where method or the where object command to do this. You can actually do things like this as well. So if you're filtering, you'll notice there's a lot of different ways to filter. I can do this not even in a filter script. 3 is in there, that's true. 6 is in there, that's true. 66 is false. Filtering out elements in a data set, a lot of the times you'll use where object, but other times you may use something like this. You may have an instance where you're having some if-then logic. If 6 in whatever here, then do something. So it's all about bringing all these things together and figuring out the best way to filter things out. You see here that we can use in as well. Going back to the same principle that we showed you up here, as long as the code inside of the curly braces here outputs anything other than 0, Boolean false, or null, it will output everything. So when I run this, it didn't tell me hello, it just returned all the items inside of that array. Consequently, if we do this, maybe a for each doesn't actually filter out anything. It just gives you everything out of the array. But since this is a for each, this is going to actually send to the pipeline. Run for each, same thing. It iterates through every item in that array, but it just says hello. So where is good for filtering. For each is good for generally reading all of the elements inside of the array. So that is the first basic filtering demo. Coming up, we're going to go into more advanced scenarios on filtering. There's a concept in PowerShell known as filter left. This is a term that was coined to represent a best practice. The best practice to filter collections as far to the left in the command as possible. This means not using where object or the where method at all if possible. Why? Well, it's because those two methods take the output of the previous command and filter. Why not give those commands the absolute minimum number of objects to work with in the first place? Typically, filtering left uses a provider-specific filter. These are filters that are applied by providers themselves, like the file system, Active Directory, and so on. As such, they are much faster and are more efficient than simply throwing everything into the pipeline. You'll find that this concept yields the greatest benefits in large environments or when working with large data sets. It can mean the difference between waiting for a script for a few minutes or even an hour or more if the data set is big enough. In the next demo, we're going to focus on this filter represented as the filter parameter with the AD commandlets. I'll also go over a few other tips to really fine-tune your AD queries as well. So now it's time to cover some more advanced filtering techniques. I briefly touched on this in a previous demo where I explained the difference between the various provider-specific filters. So I'm just going to give you a brief refresher on this, and then we're going to be talking about the Active Directory filter specifically. And then after that, we're going to some of the different parameters you can use to really limit the scope of the things that you can find with the Active Directory filter. Every filter parameter for get child item, for example, is different based on the provider. When you're using get child item with the file system provider, as I am here, you'll notice that it doesn't return any files because there's no doc files in the Windows directory. However, if you use this, then it's going to say the search filter cannot be recognized because the filter syntax that the file system provider uses versus the filter syntax that the Active Directory filter uses is completely different. This is a topic that still to this day, I've been writing PowerShell and messing with the Active Directory module for a very long time now. You'll find that the Active Directory filter itself is not very intuitive. It's more of a thing you have to learn. If you're unfamiliar with how to use the syntax for the Active Directory filter, there's actually a help topic on it. To get to that, you can use get help and then the About Active Directory filter here. So when I run this, you'll find that it's a pretty complicated subject. You think, well, it's just a filter. It's easy to learn. It's just some syntax. But if there's an entire help topic on something, you know it's not very simple. So if you just use get help About Active Directory filter, you'll see that it has examples for everything you can possibly think of here. It tells you everything that's specific just to the Active Directory filter. So going down through the examples here, notice that the Active Directory filter essentially is a wrapper around an LDAP filter. So if you're not familiar with LDAP, LDAP is the essential directory that Active Directory is built on top of. It's just another way to query out various attributes. For example, on this first one here, you'll see that the filter is object class like star. And that's equivalent to the LDAP filter of object class equals star. And that seems logical. And to see that CM name like Bob. Okay, that seems logical too. However, you'll find that there's some instances where, I don't know if it's in the examples here, but you'll see some instances to where things aren't intuitive. I'm not going to go into a lot of details on this, but I just want you to know that whenever you're doing filtering with Active Directory, your first choice will be to use the Active Directory filter because you're filtering left of the pipeline. That means that if you use the native filter, your performance is going to be much better than if you're using something like where object or the where method, because that's actually filtering everything after the fact. This is going to be a learning experience for you. We're not going to go into this in detail. It could take up an entire another module or something to talk about how to manipulate these Active Directory filters. Suffice to say, there's a good starting point for you, the help topic. So if you ever have any problems, reach out to the help topic or reach out to the community. We'll be glad to help you. The next way I want to show is limiting the search for your AD commandlets based on the AD commandlets parameters. To do that, let's first see how many users we have in Active Directory. We have 22 of them. So there's a few different ways to do this. Let's say that you only want to get all of the users in a specific container or a specific OU. Now you could query that out by doing where the DN equals whatever. In this instance, I'm using the search space of just finding things in here. So let's say that I just want to find the users in the users container in the root of mylab.local here. I could do something like this. So let's say I want to do filter. Let's first see the DN of each of these. So select distinguished name. There's all the distinguished name. Now the OU or container that they're in is part of that distinguished name. Because of that, we can filter on that. So let's say that filter distinguished name like, do the star. See, that did not work because it may not be distinguished name inside of the filter. It may be DN. See, things like this, it's not very intuitive because even as a PowerShell scripter of many years, there's still many things like this that don't really make intuitive sense to me. You would think distinguished name, like, and then that would work. There's some reason inside of the syntax for the Active Directory filter that does not work. However, you'll find times when you'll do something like this. You'll say, well, forget it then. I'm not even going to use it. I don't care about shaving off a few seconds from the query. I'll just do something like this. I can do get everything where object dot distinguished name like. See there, that actually worked. The syntax for where object is a lot more intuitive than the syntax for the Active Directory filter. And I mean, that's not essentially the PowerShell team's fault. That's the fault of the filter is actually dynamically building all these complex LDAP filters in the background to do that. And granted, it will be a little bit slower than using the filter parameter, but the majority of the time, if you're not worried about shaving a few seconds, even 1,000 or more different users, it really doesn't matter. That's one way to get all the users in that specific OU. You could do this, but it's not the recommended way because the AD commands already have a parameter to do this without having to pipe everything to where object. To do this, you can use the search base parameter. The search base parameter just essentially says start searching for this particular Active Directory object in this OU or this base object. So now when I do this again, it should work. And then when I do select distinguished name again, then notice that they're all in that user's container again. Granted, we didn't use the filter, but using the search base or this search scope, which we're going to go over here in a minute, that's essentially the same thing because if you use either these and the filter or a combination of both, all those elements get combined into an LDAP query. At the end of the day, whenever the command runs against the Active Directory database, all that stuff, all these parameters in this filter will all get combined into an LDAP filter, which will then return the objects that you want to see. So that is the search base. We can also do another limit by search scope. Let's say that we want to find all the users inside of the users container. However, if we go over here, and let's say we want to find all the user inside of the automation list OU. There is a user here, just some random user inside of automation list, and there's a child OU in here. Let's just create another sample user inside of this child OU. So there's one in automation list and there's one in the child OU here. So now let's just say that I want to find all the users inside of automation list. To do that, I'm going to change this to automation lists. And this should find all of the users inside of that automations OU. Notice that it returned 2 because it returned the one inside of distribution lists, that sub OU, and it also returned the one inside of automation lists. Now let's say that I just want to see the users in the automation list OU, not on any of the child OUs. We can change the output of this by using the search scope. So let's first grab this and bring this down here, and then now let's play around with the search scope. Immediately it recognizes the available options I have. Let's do subtree here and see what this does. All right, it still returns something. Notice that it still returned everything we need because subtree will return all of the users inside of the current OU and all of the child OUs. However, let's say that you want to just get the users inside of automation lists. Notice that now it just returned the users inside of the automation list. We didn't actually go down inside a distribution list. So search scope is another good way. So you can use the search base and search scope and also the filter on any different combinations that you want. So between all of these, and if you possibly can't get the filter that you need, then you can also filter Active Directory object in a number of different ways. An Active Directory PowerShell course would not be complete without specifically talking about the Search-AdAccount command. This is a command that's essentially a shortcut to common queries. It's a command that saves a ton of time to quickly query various items around users and computers. Although it's really not feature-rich, you'll find that for small things like finding users with expiring passwords, maybe getting disabled accounts and the like, are much easier using this command rather than filtering out all these properties yourself. In the next demo, I'll go over some common uses of the Search-AdAccount command. No course on PowerShell and Active Directory would be complete without a demonstration of the Search-AdAccount command. Now I'm focusing an entire demo on the Search-AdAccount command because it is that important. The Search-AdAccount command is going to save a ton of time and really makes things so much easier to do ad hoc queries to pull different things, users and computers and things out of Active Directory. So let's just briefly go over that. So first off, let's just see what we can do with Search-AdAccount by using help here. And I'll use the detail to see all of the different parameters here. You'll see real-world typical queries that an Active Directory administrator may want to do. So for example, on the top there we have account disabled, finds all the accounts that are disabled. Account expired, finds all the accounts that are expired. Account expiring, all the ones that will expire within a certain amount of time. Inactivity, locked out, password expired. So notice that this gives you shortcuts on queries that you could use with the where object or the Active Directory filters. Let me just give you an example here. So let's say that you want to find all of the users in AD that are disabled. With our previous knowledge, before talking about Search-AdAccount, we could do that by using get AD user. Let's say at first try to do the Active Directory filter because it's usually better. It's faster to do it this way. So you kind of fool around with it. So let's say enabled equals false. So maybe that'll get it. We got all of the users that are not enabled, which thus they are disabled. So let's just make sure if we go do name and then the enabled. So we found all of them that are disabled. This is a legitimate way to do it. So that's one way. Let me show you another way here. Let's say we don't want to use the Active Directory filter, and then we'll just use a where object. We could also do something like this, where enabled equals false. Select the name and the enabled property, and we get the same thing. Two different ways of doing the exact same thing. Now, let's use the Search-AdAccount. The Search-AdAccount has a specific parameter just for this purpose. Account disabled. Because the Search-AdAccount by default gets both computers and users, we have to specify users only, And let's limit that to the name property and the enabled property. Same thing. Which method do you think is more intuitive? Probably the Search-AdAccount, because it's immediate. I want to find all disabled accounts and only users. You can infer that from the other ones, but it's really not as obvious. You can use this same approach for any of the parameters in here. So as you just tab through, you can say account expired. It looks like I don't have any. You can just play with this all you want here. Account inactive, locked out. Is there anybody locked out? So there's all kinds of different things that you can do here with this. Password never expires. It looks like we got a few there. So it's a really easy way to do it. Here's another one that requires more than just one parameter. Let's say we want to find all the accounts that are inactive. Tabbing through, we have account inactive, and we want to find just users. Brought back a whole lot of things, because the account inactive parameter requires either a date time parameter or a time span parameter to limit that to. I found that the easiest way to do this is use the time span. So let's take this a step further and see if we can find out the users that either have never logged on at all or their account hasn't been active in a certain period of time. So to do that, we have Search-AdAccount. We can use account inactive. Then we only want to get users here. So let's say we want to do users. And then we can do the time span of 90. You'll notice that time span can be a little complicated sometimes. That really doesn't make sense. Well, is that 90 days? But yes, this is 90 days. To get more information about time spans, you can actually build time spans with new time span. I'm doing this on the fly here, so let's see how this works. So right now, there's all the users and their last logon date. So notice a lot of them have never logged in, and there's only one that has logged in that just has a date to it. Let's just count how many of these are, and we'll do a comparison here. 23. So now let's try to build a time span to do the same thing. Instead of specifying the 90.0 and all of that with a string, let's just do a time span here. So we'll do a start of 90 days ago. So let's see if we can do something for 90 days ago. 90. So notice that's 90 days ahead of time. We can also do negative 90, which is 90 days ago. All right. So now this may be a little easier for you to understand. We can do new time span days, negative 90, 24. So that's the same thing as using the 90 string. To me, I try to find ways that are easier to understand. Since this method has days in it and negative 90, that makes more intuitive sense to me. And you can do the same thing for a lot of these other parameters as well. So we can do account expiring. That limits the amount of users by the expiring. You can do account inactive. There's a lot of different parameters in here that you can do. I'm not going to go over each one. Honestly, they're all pretty intuitive, but if you're curious and if you ever need to quickly run queries on Active Directory for various things, I highly encourage you just to run help, search account, detailed, and then run through all of the different parameters that they have. There's a lot of the parameters. Some of the parameters are common to the get80 user, get80 group. So you notice we have search base, search scope. You can still limit your searches to whatever you need to. But also now you have all these great switch parameters where you can just specify password never expires or password expires or locked out. You can specify all those things by just saying intuitive, I want to find all of these users that meet this criteria. It's a lot easier to understand than trying to figure out how to manipulate one of those Active Directory filters or even a where object filter script. All right, so the time has come for the final demo in this module. In this final demo, we're going to put everything you've learned together and build our AD health check script. We'll reuse the work we've done in many of the previous demos to build a nice tool that will allow us to gain better visibility into a few different metrics in AD. What's most important, though, is that we'll lay the groundwork for you to add additional functionality to this script. By doing this, you can take whatever you've learned here and customize it for your own environment. As promised earlier in the module and also in the course, we're going to take all of that learning that we went through in the previous slides and demos and put that all together to build a little tool here that will allow us to get a good summary of various counts of objects and components inside of Active Directory that you can just run one script and get an example summary of what your Active Directory environment looks like. To do that, I've built a script called invoke AD health check here. As promised before, we are using the same scripts that we built previously called get Varonis computer, Varonis user, and Varonis group. However, I've modified those a little bit so that now instead of being standalone scripts, we can actually easily consume those as part of this larger tool. For the most part, these are exactly the same functionality as they were in a script, but you can see that instead of a script, they're actually functions now. So I have one function with the same function name as the script name. So for get Varonis user here, I have a single function inside called get Varonis user. And to provide some kind of ability to change some properties, because that's going to be necessary in our AD health check tool, I've also built a single parameter called properties here. It's setting the star or asterisk as default. This function is a simple wrapper function around get AD user, which essentially when called, it just calls get AD user and passes whatever properties here directly to the properties parameter of get AD user. And the same thing for get AD computer, exactly the same. In the real world, you probably wouldn't write a simple function like this which calls get AD computer with the same parameters. The reason why we are going to be using these same scripts now is because there's maybe times where whenever you are getting a computer account or a user account from Active Directory, that you may want to do something to that output at a certain time. For get AD user, for example, so maybe you want to return home folder paths or maybe exchange mailbox information. You would do that by manipulating this script and not the main script. So you would be manipulating get Varonis user here, and then anything coming out of get Varonis user would be your home folder, exchange mailbox, or what have you. Get Varonis group, that's the one that's a little different since it was more complicated than the others. We're doing the same general concept though. We are just calling get Varonis group with the properties here, and we will define properties here. This needs to be members because we need to pass members to that. Then it creates that custom object for us. So this is a good example of why you would want a function as a wrapper to the various command lists, because we can do custom code like this and do custom output. Each of these scripts now contains a single function. Now, since I want to use those functions, I can't use those functions off the bat because they're in different scripts. So first we need to bring those into session or load those into memory. And to do that, we can use the dot sourcing, which we discussed a little bit earlier. In this instance, I'm just saving some time here, defining all of these scripts that we have, an array, and then using a for each loop to loop through all of them. And then notice the dot there, we have a dot, and then the scripts path slash whatever the script name is. And the script path is just the demo path that I'm working with here. So as we dot source all those scripts, each function inside of the scripts will become available. Next, on line 15 there, we are defining our output hash table. So similar to what we did with groups, we're defining an output hash table, which we will then output a custom object at the end there. And then on 17 to 19, we are actually calling each of those functions and grabbing everything that we need. In this instance, we are grabbing all of the objects that come from get Varonis user, Varonis computer, and Varonis group. Computers and groups, we're just using the default because we are not passing a parameter here. It will just simply use the default, which is star for each of these. But for users, since we need to manipulate the properties a little bit for some things we're going to be doing later on, we need to define our own properties to get. So in this instance, we're say getting all the properties, and then since the MSDS user password expiry time computed property isn't default, even when you specify the star, we're going to need that as well. So we can pass different properties here to this function. So once the script goes down through all these, then this is an option to where I wanted to get expiring passwords. This instance here goes through each of the Active Directory users and finds all of the user accounts that will be expiring in less than 30 days. This is an instance to where the result that we need is not inherently built into the Active Directory module. This is a good example of a time whenever you have to actually do a lot of coding and figuring out things ahead of time. This is an instance to where we actually have to dive in and really start Googling around and figuring out how to do this. In this instance, I'm just getting expiring passwords. And to do that, I'm using the where object in AD users where the password never expires and password is not expired. These are the easy ones. However, to actually get when the password will expire is a little bit harder because that attribute isn't natively in Active Directory. We have to kind of compute that on the fly. To do that, I'm using this datetime type here and using the from file time static method. So what that from file time method does is that's getting the date, which is the password expiry time computed, which means that is the date when the password will actually expire. So since we know that, we don't want when that date is, but we want to know how many days is that. So to do that, we subtract the current date from the date that it's going to actually expire. And if that's less than 30 here, it's going to return true. And I'm gathering all of these things up here, and this is all one command and getting the count of it. So we're getting all of the users that have expiring passwords less than 30 days and assigning them to the expiring passwords property here. And then going down the rest of this here, it's a little simpler. One thing I wanted to know here, I'm saying that I'm not using Search-AdAccount because we just went over the demo of Search-AdAccount, and a lot of this information here, the expired passwords, locked out accounts, for example, that's really simple to use with Search-AdAccount. However, I'm not doing that here because we are doing a lot more things other than just those one-off. Search-AdAccount is really good for finding those one-off things. However, if you're building a tool like this, because up here, we are already getting all of the users that we need, all the computers that we need, all the groups. Those are making a call to Active Directory. So it's going out and actively querying the domain controller. That's why we don't use Search-AdAccount, because Search-AdAccount, if you use that over and over again, that's just going out and making a call to the domain controller over and over, and it's not really efficient. If we've already made that call and we already have all the objects, we just need to do a little bit of filtering ahead of time. So that's why I'm not using Search-AdAccount here. Here is where I'm just defining all of the output properties that we need. So I want to see how many computer accounts are in AD, how many users, how many groups. Here's an example of how many users are in the domain admins group. So maybe we're concerned about group membership, expired passwords, locked out accounts, password not set. You're limited to only to your imagination here. It just depends on the properties that you need to see and how you need to see them. Once you have this framework created, adding another field here is as simple as just figuring out the property for the user or the computer or the group that you need and figuring out how to write code that will show you that count. It's pretty simple in that regard. And then on line 42, we are converting that hash table to a custom object and then outputting it to the console. Pretty simple. Wanted to mention that this is a common technique that you can use to build each object on the fly as you're going down and then just outputting it at the end. If you're accumulating a bunch of things all together at once like I'm doing here, it's a really good way. You just get the output, assign it to the property, and at the end, you output the object, and then it just outputs everything that you like to see there. With that being said, now let's just go ahead and run this. And this is going to take a little bit because it's going out and grabbing all of that stuff at one time. I'll be back with you here in a few seconds whenever this is finished. All right, looks like it's finished and we didn't get any errors, which is great. So now that you see, we just have a summary of the various pieces of Active Directory. The output is very simple, but you can see there was 42 lines here. It wasn't too bad. This is really what PowerShell and Active Directory are all about, especially when just querying and reporting on things. It's just about taking the time, going slow, building out each individual component that you want, and then eventually at the end, putting it all together into some kind of tool like this. This module really got us into Active Directory, got us diving into some of the various ways to query different objects in AD, and provided a simple output here. Hello and welcome to the next module in our course, Hands-Free Active Directory Health. In this module, we're going to get some AD-specific configuration settings and how to read them with PowerShell. Throughout this process, we'll also introduce a few PowerShell-specific concepts like parsing string data, and we'll also cover a brief introduction to PowerShell Remoting as well. This module will again mostly be all demos. We'll first dive into parsing exe output. Because not everything has a PowerShell commandlet available, it's sometimes necessary to use traditional exe tools and parse the output in a way to create a structured object from it. This is an important skill to learn, and we'll cover some examples using ipconfig and the DCDiag tool. We'll then build more functionality to our AD health check tool by introducing replication monitoring. We'll query each DC and gather various pieces of useful replication information from them. And next, since cached passwords on read-only domain controllers is a security risk, I'll show you how PowerShell makes this process easier through just a single command. This will also go into our AD health check tool. So finally, we'll query the database of each DC and enumerate things like the database size and if whitespace logging is enabled to demonstrate how PowerShell Remoting works. For our first demo, let's cover parsing exe output. When an exe returns something, it's to the standard out stream. Now there are different streams in the traditional command prompt, and PowerShell is capable of capturing all of these types of strings. It's much like the pipe command is required to capture standard output by using the greater than symbol here and piping it to a text file. The difference is that PowerShell does this natively without the need for the greater than symbol there. And although it's easier to always use a PowerShell command if possible, it's sometimes necessary to use these legacy tools as well. Parsing output allows you to create functions and code to be used as a stopgap or bridge between the two technologies. So for this demo, we're going to work on parsing command line output. But before we do that, let's first see what we're up against here. Whenever we're parsing command line output, that just simply means taking the output of an existing, perhaps legacy function or legacy executable, and then converting all of that rough output, that big string that it outputs, into a structured object. So to give you an example here, I can use ipconfig as a really good example. Now, when ipconfig sends its output here, you'll see that it sends out a bunch of text to the console. Now, this is fine if you're just casually looking down through here and trying to figure out what you want to know, but this doesn't really lend itself well to automation because you can't use this output very easily in another kind of input. So let's kind of break this up and parse it out into a more structured object. So the first thing I mentioned here is define what you'd like to parse out. Whenever you're designing these tools around this command line parsing, typically not going to want everything in here. Now maybe you will. That would just be part of your definition. But in this case, I just want to see the adapter name, the IPv4 address, and the subnet mask. And I just want to see the adapter name for Ethernet. So what I did here is I just kind of made this simple little hash table. It doesn't have to be a hash table. You just need to define what an example output would be. I want an output to show adapter, IPv4 address, and subnet mask just like this. Now looking down through here, at the top there, you see Ethernet adapter, Ethernet. So I want to capture that Ethernet string, that last one there. And then looking down through for IPv4 address, you see there is an IPv4 address, a bunch of dots, a colon, space, and then the text that we need. Same thing with subnet mask. I have subnet mask, the dots, the colon, space, and then exactly what we need. The trick is to figuring out how to remove everything else from that entire output and just get the pieces that we're looking for. One way to do that is to use select string. Select string is a really good tool that allows you to match patterns in strings and then output various matches things. It does all kinds of great stuff. It's kind of like grep on steroids, I guess you could say, if you used grep before. It's a really good tool to parse out strings. To demonstrate select string here, I have already created a string called just test string. Test string just contains a few different lines. So test colon, test colon, test colon, and then some output. I'm going to play around with select string and then figure out if I can get each of these in a structured object. The first thing I want to do is, because this ipconfig contains a lot of lines, so it's not just one line, we'll first need to split out the output, one for each line. So we need to create an array in PowerShell. To do that, on line 22 there, I am creating the array and I'm using the split operator and then specifying the backtick in. Now the backtick in represents a new line separator. What this is going to do is this is going to take each of these lines inside of the string and then create an array from it. To demonstrate that, I will go ahead and run it. And now I can just reference one line at a time. Test whatever failed, that's the first line. Test something failed, that's the second line. So it separates those all. So that's the first step in separating each of these and to be able to kind of parse these out a little bit later. So once they're all separated, I can then use select string and then use the pattern parameter to parse out what I want. I'm going to go ahead and run this here. And you see that it searched through that whole array, which 3 of those elements in there, and it just found the one with the pattern test::foo. And you see that it included the whole line there, so test foo succeeded. So that's a really simple way. At the simplest form, select string uses the pattern parameter to allow you to parse out various strings inside of there. However, that's not going to work in our situation. We need to use regular expressions or regex. Select string and regex, you'll use this a lot if you do a lot of command line parsing. This works out well because regular expressions has a concept called capturing groups. And the capturing groups is what's defined here. A capturing group essentially just says match this whole pattern right here, and then once that's matched, capture this piece of the match and store that off somewhere else. Once it's stored off somewhere else, I can then reference just this little piece here. And if you notice here, with the test foo succeeded the whole string, I'm actually just wanting to get the word succeeded in this case. So when I do this, this little piece here should just be the word succeeded. Now I'm also using the all matches parameter here because by default select string only finds the first match and then quits. Now in this case, since I only have one instance, I wouldn't have to use this, but if you would have multiple strings inside of there that match this pattern, you would need to use all matches to find all of them. I'll first go ahead and run this and then see what this output looks like. And you can see if you're just looking at the output, it's not going to show you much at all. It's just going to show you each of those lines. But I wanted us to show you there was something in there at least. One thing that select string does whenever it sends its output, it has a property called matches. This is only populated if you use the regular expression capturing groups, so the left parenthesis and the right parenthesis here. This matches is populated for each of these. Let's go ahead and run this and run through each of these here. So you'll see that all matches inside of there has a matches property, and the matches property has a few different properties in it called group, success, captures, and so on. This is good information. This tells you a lot of information about where it was captured and that sort of thing. I want to get the groups. So inside of the matches, there is a groups property. And if I run this, you can see that this gets more granular here and allows us to dive into the groups itself. So I have success, captures, index, length, and value. Capture the groups property always contains at least 2 different objects inside of groups itself. This one here is one object, and then this is a second object. Now, if you're just doing one match, the second object will always contain the actual value that was matched. So you see that where you have value succeeded. Now, if I just search for that, I get the object that I want. Because groups is an array, I can just specify the one index there. And then bringing it down another level, groups1.value, now I've gotten just the word succeeded. That's what I want. So I went down from that whole line and parsed it down one at a time and got the word succeeded. So that's what I want to do. So now let's apply this same concept to ipconfig. I'll first grab ipconfig's output here, and you can see that it's exactly the same as what it was before. I then want to parse out that Ethernet adapter name. The line that says Ethernet adapter Ethernet, I want to pull out that Ethernet string, and I can do that with select string. To do that, I can pass the output of ipconfig to select string as I'm doing on line 42 here. And then I specify the pattern, Ethernet adapter, and then I'm using those capturing groups again there just to capture that Ethernet string. And then I'm passing all that to for each, and then I'm doing the exact same concept I was to narrow down just that Ethernet string. So when I run this, you see that I just get Ethernet. The same concept goes for IPv4 address. Now, you can see that in the pattern, the regular expression is a little different. There's whole courses on regular expressions, so I'm not going to go into how to actually do the match, but you see that capturing group again. I'm following that same concept. When I run this, you see that I did get 192.168.0.122, so it parsed out that information. Same concept with subnet mask as well. I'm able to parse that out. It's all about building the right regular expression pattern. Now, once I'm able to pull out each of those strings one at a time, if this is part of a bigger automation script, it's good to make it efficient. Since each of these attributes looks very similar, because you see that I'm running select string, passing that to for each, doing the pipeline variable matches groups1 value. I'm doing that 3 times over and over and over again. Good code, it's all about keeping dry, so don't repeat yourself. That means use a loop. Here, I'm going to define a properties hash table, and I'll go ahead and bring that in. And I'm just defining a key of adapter, IPv4 address, and subnet mask, and then associating each of those values with the regular expression that it matches. Now, I want to create a custom object for this. So that all this is about going from a rough string like we did with ipconfig output and building an object from it. To do that, I am creating a hash table, and I'm going to put all these keys inside of this hash table. In order to loop through, so to read each of the keys and values inside of a hash table, I will use the getEnumerator method. So that allows me to loop through that just like an array. So at this point, what this string here is doing is this is saying loop through each of the keys inside of this properties hash table, and then define each of these keys as a key inside of this future object hash table. On 59 there, the $_.key, that's going to be adapter, IPv4 address, and subnet mask. This is essentially going to be the same keys as the properties hash table. However, you can see here that now I only have to specify this one single time. So I only have to specify how to grab the value of that key one single time instead of repeating that over and over and over again. In the end, this future object is going to be adapter, IPv4 address, and subnet mask. And instead of these regular expression strings here, it's actually going to be the values of each of these that I want. So now I will go ahead and run this and check out what it is. And now you can see that it's a nice structured output. I have the adapter, subnet mask, and IPv4 address all in a nice columnar format. That's a really nice object. However, you see that it just has name and value for the header. That's because it's still a hash table. Let's just convert it to an object, which using the PS Custom Object Type Accelerator here, piece of cake. I'll just run this. And now you can see that we have IPv4 address, subnet mask, and adapter as headers. At this point, we have parsed out exactly what we want from ipconfig and made it into a nice custom object. For this next demo, we're going to use the DCDiag tool. The DCDiag tool is probably the original AD health check troubleshooting tool. It's a tool that puts together a lot of different tests and performs them against your AD environment. The functionality is great, but unfortunately it hasn't been updated with a new PowerShell command. That's what we're here for. We'll break down DCDiag's output and convert the unstructured output that it returns into a nice object with each of the tests that are performed broken out so it's much more easily readable. And during this process, I'll introduce you to a simple concept I use to first define what I want my script to execute and then figure out how to get there. So let's now build a feature into our AD Health Check tool. So the first one we're going to be doing is we're going to be grabbing the results from a DCDiag scan on our domain. And since DCDiag doesn't natively produce PowerShell objects, we have to parcel out all those strings out for you. And hopefully with that introduction in the last demonstration that we did, we were able to quickly make this happen. So the first thing we're going to do, just like the ipconfig example we did in the last demo, I'm first going to just run the command and just grab everything and put into a variable. To run DCDiag, it's just as simple as running DCDiag/s for the server, and my DC is going to be domain controller. I will go ahead and run this, and since this takes a few minutes to run, I will go ahead and just let this run in the background, and I will be back in just a second whenever this is done. All right, we're back, and it looks like it's finally got done. So let's check out the output here, make sure it's not a bunch of red error text or anything. Yep, looks like it ran all of the tests, and it worked. Next thing we need to do is we need to define the output. So what do we want the output to look like whenever it's done? And I've done that again here. I want to see a row for each test, and for each test, I want to have properties called test name, test result, and entity. Now, entity may not be that obvious of what that is at this time, but you'll see what that is here in a minute. It'll make a little bit more sense to you. Again, just like with the ipconfig example, first thing we need to do is try out select string. Whenever you're parsing command line output, it's all about filtering down one level at a time. In this example, whenever I just eyeball the results of DCDiag output, I see here that I see DC pass test advertising, DC pass test FRS events, DC failed test. It looks like my entity, which will be my DC in this instance, and my domain controller, passed test and then the test name. Now, since I want to see the test name, the test result, and the entity, it looks like each of these is on the same line. I have DC, so whatever entity it is, passed or failed. I want to know that. The word test, and then the name of the actual test. So the first thing I need to do is I need to filter out all the other stuff that I don't want to see. So to do that, I will first try out select string using the pattern of test colon. And you can see here that I see starting test. Well, this gets me all of the test names. That's a really good start. It's not all about consuming and getting everything all done at one time. So this gets me all the test names. However, I want to also see test result and that entity property. To do that, I first need to grab out just the test names from these. I don't need to see starting test colon and then that space. I will run the for each, so I'll grab the value of all those matches again like we did it with ipconfig. And now you can see that I removed out all that unnecessary text that was in there. Then next, I will grab the test results. With the test results, you can see here that it did pull back the entity, so the DC passed test, and then whatever the test name is. So this regular expression here does that. You can see I'm using the capturing groups again because I want to capture what the test name. So this capturing group is going to be connectivity, advertising, FRS event, and so on. So again, once I have pared that down a little bit, I now need to grab the value here. So I will go ahead and run this. And again, this does exactly the same thing as I did before. I'm just removing out all of the unnecessary things that I don't want to see. And now I'm just getting the value of passed or failed for each of the tests. Great, next step done. Next, since I need to create an object after all this is said and done with the test name, the result, and whatever the entity is, I need to match these up somehow. So I can't just get the test names, just the test results. I need to match these up and to build these into an object. When I go back here, you can see that I am using these lines here. And luckily, in this instance, each individual line has all of the elements that I'm looking for my object. So my object has DC, passed or failed, the word test, which we're going to remove that here in a minute, and then the name of the test itself. So they're all in one line. You can see that I did already get that information out with this line up here, so line 24. So I was able to parse just those lines out. See, there's a lot of stuff in here that I need to parse out eventually, but this is a good start. Now I can have a piece of code here that essentially creates our hash table again and then converts that into an object. Now, since I'm using the capturing groups, that populates the matches property that select string outputs here. And then because of that, I can use the groups property. In this instance, before in our other demonstration with ipconfig, we just had one match. Now we have two matches. That's why I have to use the index of 1 and then the index of 2 for the groups. When I'm doing this, this is the value for each of these, and I'm defining the test name key and the test result key, and then associating them with the appropriate value. And then I am converting it to a PS custom object. You can see here that now I've got a really good start. I have an object for each test with the properties of test name and test result. That's great. So I have two of the properties that I'm looking for in the object. Next thing I want to see is the entity. Most of the time it's going to be DC, but as I was looking through there, I saw that there was sometimes it was going to be the application partition and things like that. I didn't necessarily want to call it DC. So I'm going to look down through here again, and this instance, I am parsing out the entity. Now you can see here I have DC, but I also have forest, DNS zone, schema, configuration, and my lab, the domain as well. So this is the entity, and I use the exact same approach as I did before with the capturing group, just grabbing that entity out of there. And then once I do that, it's just a simple matter of adding the entity property to the PS custom object as I am doing here. And notice that I have three values now, three groups in here to match. So I will go ahead and run this. And then now you see that we have one object for each property name with a test result, an entity, and a test name property. So once I have this information in here, now let's go ahead and take what we've demonstrated here and clean up this script and incorporate it into our AD health check tool. So I'll go ahead and open up the AD Health Check tool here, and this is the same one that we were working with previously. So let's go ahead and add this to here. It looks like in the AD Health Check tool, we have a few properties already. I want to add the results of DCDiag here as an additional property. So I will go ahead and just put in a placeholder here and call it output.DCDiag results, and it'll just be a blank string for now because we're going to put in a placeholder. Once I have that, now I need to figure out a way to execute something inside of here to get the output of what we were talking about here. First thing I want to do is, since we are modularizing out this with various scripts, I'm going to add in our scripts here. So I will add in our DCDiag.ps1 script. So I'm going to eventually be dot sourcing this in so we can go ahead and be able to run this. So once it's dot sourced in, I need to convert all this code I did into a usable function. A lot of this was just for demonstration purposes, so let's go ahead and remove out a lot of this stuff. We first need to get the DCDiag output. We definitely need that. And we'll remove all of this stuff that we did in the interim here and just get the final output. So that's going to essentially just do exactly what we did, just remove out all that explanation that I did earlier. So it's going to grab the output of DCDiag, take that output, pass it to select string, and then create that future object here. So let me just run this again to make sure this still works. So now we have just the code just to get the output that we want. Now, since this is going to be incorporated into our Invoke AD Health Check tool, we need to build this into a function. To do that, I'm just going to create a simple function here. I'll call it invoke DCDiag, and then I will place all of our code inside of this function. Create our param block here. Now, this allows me to compartmentalize this piece of code, and now we can just call it from wherever we want. And now I can just run invoke DCDiag. It will run DCDiag and parse out all the information that we need. So once we confirm that in the DCDiag script, it looks like we are dot sourcing it in. So the invoke AD Health Check script will dot source in DCDiag, so it will make it available. And I'm going to scroll down here to make sure I'm not missing anything. And nope. So now all of this information that you see down here in the console, I want to compartmentalize all of this into DCDiag result. To do that, I can just run invoke DCDiag right here and put it in parentheses. This is going to execute invoke DCDiag, and when it's done, it will assign it to the DCDiag property. Since I'm doing this on the fly, I didn't want to prepare for a lot of this ahead of time because this is a really good learning experience for you, as you'll see that I may make mistakes here and there as I'm doing this. Let's see, we have it in the same folder. So now I will go ahead and run this script, and looks like it did not work out right. We got some output there, but we got some errors as well. Invoke DCDiag is not recognized as the name of a commandlet. Okay, let's see why that was. So we have invoke DCDiag, the function here inside of the DCDiag.ps1. So make sure that both the scripts are on the same path, and I believe they are. Let me just make sure here. So they are in the same path, or in the 5 Active Directory Health and the demos folder. It is the scripts path. This variable here was wrong. So I'm going to need to update this path variable here. That's updated. Now I can go ahead and try to run this again. So it's prompting it for the mandatory parameter of filter for get AD computer. Let's just figure out why it was doing that. All right, let's check out the get Varonis computer. We didn't actually convert these into functions like was originally intended. See, we have get Varonis computer.ps1, but we still have a bunch of this executable code. We need to convert all of these into functions. Now we have a little what's called a wrapper function around get AD computer that we can then just call get Varonis computer. And I believe, let me make sure that the same is done for the other ones as well. So what we're doing is we're doing the exact same process as we did before. We are removing out all of the demonstration code that we were working with. And this is a common thing you'll do. You're going to be working with a lot with these scripts. And when you work with the scripts, you'll find that you'll need to refactor them in some way. you'll find that you'll have to convert these scripts into functions in order to help modularize your code and to plug in features like I am here in the AD Health Check tool. So again, here, let's just grab out the necessary code, and we're going to call this one get Varonis group. And then the same thing with get Varonis user. This was a pretty easy one here. So we have CSV users, and all AD users. So we need CSV users and the all AD users variable. Create the function again. Notice that we have a variable here called demo path. We're still going to need that. Okay, so we'll clear the screen there with CLS, and it looks like now we have get Varonis user with a function, get Varonis group with a function, and then get Varonis computer with a function. Now, let's try to run this again. Now notice it's taking a little while. It didn't immediately error out. Hopefully this is going to work, but you remember before, it looks like invoke DCDiag is probably working in the background because it's taken a while. I'll be back in a few minutes while this is done, and we'll see what the output is. All right, looks like it worked, so great. You see here that we have DCDiag result, we have that new property, and then we have all of that information that we saw previously that had the test name, the test result, and the entity. That is all a single property inside of our AD Health Check tool. Because I didn't output this to a variable, let me go ahead and do that now, and we'll just run this real quick again. So I can't actually run it here directly from the ISE because I need to output it to a variable here. I'm going to go ahead and run this manually here inside of the console. So let's change the directory to here, make sure we've got it here with ls. We're going to assign this to example output equals invoke adhealthcheck.ps1. That's going to execute invoke adhealthcheck.ps1 and then send all the output that you just saw to the example output variable, and then we can parse it and then play around for a little bit. Be back in just a second. All right, looks like we finally got done here, and now I should have that example output to be able to play with. So now I can just do example output DCDiag result, and now you can see that familiar output that it's all stored in here. This was the first task we did to add some functionality to a new tool. So this is a really common occurrence where we had existing functionality, so existing code spread out through various scripts, and we incorporated that all into one script per one function. Once we did that, now we have the foundation laid to where we can just start adding in functionality as we will. And you'll see that in the upcoming demos, we're going to be doing just that. The next feature we'll be adding to our health check tool is replication monitoring. DC to DC replication is one of the most important metrics to keep an eye on in your AD environment. By using the Active Directory modules command, PowerShell makes quick work of this. To do this, we're first going to figure out how to enumerate all of the DCs in the current domain. And then once we do that, we'll then target each of these DCs to gather a few key pieces of replication data. For the next feature of our AD Health Check tool, let's build a replication monitoring feature. To do that, just like we did with the other features, first need to define some kind of rough layout of how you'd like the output to look. In this case, whenever I run my AD Health Check tool, I want an output that's going to look something like this here. So I have a hash table, and inside of that hash table, I have a replication status key, which also is a hash table with each of my domain controllers listed there. And then inside of each of my domain controllers, those are also hash tables with the domain controller as the key name, and then the value, which is also a hash table with the keys of last replication attempt and replication status. And you can see that I've kind of laid a rough layout of sort of what that's going to look like. So I'll have the date and time for the last replication attempt, and then either success or failure if the replication status succeeded. It depends there. And then I will also have this one for every domain controller in my entire environment. So it's a really good idea to lay out a rough outline of what you'd like your output to start with before you start a new feature on a tool like this. The first thing we need to do to get the replication information for our domain controllers is first to enumerate all those in my domain. To do that, the Active Directory module has a really good command called getAdController. And it has a mandatory filter parameter here. In this case, I just want all of my domain controllers, so I'm just going to specify a filter of asterisk. And when I run this, I will just create a DCs variable, which contains all of my DCs in here. So there's lots of properties in here, so I'm just going to do a count to make sure I have 2 DCs in my environment. So once I have all of the domain controllers enumerated, I will then need to grab the information about replication on each of those. Fortunately, the Active Directory module contains a really good command here called getAdReplication Partner Metadata. And this is a command that gathers a lot of great information about your replication of your domain controllers, not just success or failure, but for now, we are just going to include just those 2 properties. So those are the only properties we are concerned with at this time. So when I run this, I can run it with a target and then specify those DCs that I found earlier. And now, for each of the domain controllers, it brought down a lot of good information. You see here we have last replication attempt, last replication result, the time it was last successful. So there's a lot of good information for each and every one of the domain controllers and how they are interacting with each other. So once we're able to pull that rough information, now it's time to mold that into a structure that we need. So the first thing I want to do is I want to create my outline of the object that will eventually be. To do that, I'm going to create my output hash table and just make my replication status key inside of there because that's what I defined at first how I wanted it to look. So I've created the hash table, and now I can go in and add elements to this hash table and then eventually convert that into a custom object when we get done. So once we do that, I can go ahead and then enumerate through that REPL data variable. Since each DC is an object in the REPL data, I can confirm that here, 2 objects for each DC. I can then just loop through this with our for each variable here and then define each of the servers. Let's just go ahead and do this manually real quick. So I can do for each, and then each of those objects has a server property. So it has the fully qualified domain name for the server property. If I can loop through each of these, this will create a hash table key for each of these. So now we'll go ahead and look at this. So now you can see that we have a hash table with a key of replication status. That has a value of both of those other hash tables. So let's dive in a little bit more, and then we will look at output.replication status. Dive in a little bit more. Now you can see that we have dc.mylab, memberserve1.mylab, and then a blank value for now. So that's just kind of taking it a step further and building out the structure a little bit more. Now once we have the structure built, we can then just add in the values that we want. So in this instance here, I'm just adding in, instead of just creating the hash tables for each of the domain controllers, I'm then taking that a step further and adding the last replication attempt and replication status keys to each of those domain controllers' hash tables. So when I run this now, it should have run successfully. So now let's check it out. So we got output.replication status. Now you can see we have each of the DCs and we have the values inside of those. So let's dive down further just to check out one of these. So I have replication status.dc.mylab.local. And now you see that we have the last replication attempt and replication status associated with that DC. And then one thing I wanted to point out, notice that I had to put single quotes around that dc.mylab.local property. That's because the property has dots in it, and with PowerShell, you must have quotes around any property that has dots in it, because otherwise PowerShell will think that those dots indicate further properties. All right, so we're almost there. However, notice that I want replication status to be a string of success or failure. Right now, it's just going to be 0 or some other kind of integer if it failed. This is a really quick conversion here. We can just quickly do this with an if statement right inside of the replication status value itself. Here I'm just saying if replication status equals 0, I'm going to say it's true, else it's false. However, we can also do this to success and failure if you want. So at this point, we have all the structure we need. It's just a simple matter of adding this in. So instead of true, let's just say this is success, else failure. Let's run this again. and check it out now. Now you can see that it says replication status is success. Now I can do this for member serve 1, make sure that looks okay, and I have a last replication attempt and replication status of success. This was all that was included in the replication monitoring feature. Now let's clean this up again, and let's incorporate this into our bigger AD health check tool. So to do this, I need the REPL data variable and the output variable. We still need DCs to feed to the REPL data, which will make REPL data. We don't need that one. Let's just be sure here to run this again. And again, with the IC, I can just run the entire script with F5 here. So now it's just a script. Now, since we're going to be dot sourcing it, we don't want to directly execute it when we run the AD health check tool. I'm just going to go ahead and create a function out of it, and I'm just going to call it invoke replication monitor. And then take our code that we've built and add that into the function. One thing we did miss here, notice that we are building the output hash table, but we were never actually converted that back into a custom object. So in this for each loop, we're actually building it. Then now all we have to do is finally add that step that converts the hash table to a object. So let's just test this out and see if it works. We can do that. I'm just going to go ahead and run selection here. That will get the function available in my session. Now I can just run invoke replication monitor. Looks like that worked. So let's open up the AD health check tool. Since we're using a new script here, we need to add it into our scripts. So it's replication-monitoring. That will dot source it in so we have the function available. And then we're going to add another property called replication status. Invoke replication monitor. Now, one thing that I did notice that we will need to change is the nested replication status hash table here. So in this instance, you can see here that we are building a hash table called output. So we have a hash table, and then we have another hash table embedded into that. This will work if this feature is just running on its own, but if you run it with AD health check is going to have its own replication status property. So if I would let this run, this would look like the object replication status dot replication status. So notice we would have a nested replication status. So we do not need this embedded replication status hash table because we are incorporating it into the AD health check tool. And because it's not in here, we don't need this anymore either. So we can just remove this. So now it would just be the output of each domain controller. Test this. I will bring this into my session again. Run this again, and now you can see that each of the domain controllers is its own property. So that looks much better now. So everything looks good. So let's see if we can run this without any errors. No errors so far. Because of that invoke DCDiag, this is going to take a little bit. We'll be back in just a second, and we'll see what the new replication monitoring feature looks like under the replication status property. All right, looks like it came back and with no errors, so great. So now notice that we have replication status property here, and we have each of the DCs. My DC mylab.local equals our hash table, which will include our replication status, and my member serve 1.mylab.local, which is my other domain controller. So you'll see that the replication monitoring feature is now incorporated inside of our AD health check tool. For our next demo, we're going to add a feature to find cached passwords on any read-only domain controller in your environment. Read-only domain controllers are sometimes used in physically insecure environments like branch offices or really anywhere where credentials do not need to be updated. One feature of RODCs is password caching. This prevents the RODC from talking to another domain controller, thus allowing it to authenticate credentials while being offline. By default, RODCs must refer the authentication request to another writable domain controller. This is a security issue if that RODC were stolen, or the passwords could be vulnerable to password cracking. This feature of our health check tool will check for these. All right, next up in our features for our AD health check tool, I've decided to add in a feature to finding cached passwords on my read-only domain controllers. You may wonder, where is he picking out all of these different features of the tool? Well, to be honest with you, I kind of picked these on a whim. The reason I've even mentioned this in the first place is the features that I'm adding here are not required by any means. I'm just building each of these features as an example. So maybe a useful feature that you may use with your AD health check tool. But at the same time, I want you to know that the process is exactly the same for adding each of these. It's just simply defining what kind of output that you need and then going step by step, getting the structure right, the main structure of the object or whatever you want to do, building that down, whittling it down slower and slower and tinier until eventually you come out with the output that you want. And then once you have the main script like we're doing here, then I'm just converting into a function. As you can see that converting into a function is just essentially wrapping all that code into a function and then putting it into the AD health check tool. Don't get hung up on the examples that I'm using here. Since I'm going to be finding cached passwords on read-only domain controllers, the first thing I need to do is find all of the read-only domain controllers. And to do that is very simple with get AD controller again. I'm going to filter for all of them, so I'll get all of them, and then I can filter out this even more by saying where object using my is read-only property here. If you remember in that previous module, it's always better to use the filter parameter, but in this instance, it's much easier just to simply output all the domain controllers and filter it after on the pipeline by saying where $_, which is the pipeline variable, .is read only. I will go ahead and do this here. And notice that I have none. Well, I have none because I have none in my lab environment. However, if I would have these in my lab environment, the output is going to be exactly the same as if you ran get AD domain controller. So if I run get AD domain controller again, you see that it outputs the typical properties that occur here. It would just have an is read only. You see here I have the is read only property here. In this case, they're both false, so you have all those. Another huge time saver that the Active Directory module has, it has this command called get AD domain controller password replication policy usage. Now, if you dive into the Active Directory module at all, you'll see that it has hundreds of commands and things to do all kinds of other things that we don't have near enough time to cover. So in this case, this get AD domain controller password replication policy usage, which is too long of a command, you can pass all of those domain controllers that you found directly to that, and then it has this revealed account parameter here. Now the revealed account parameter, say I want all of the accounts that have a password that has been cached on each of the domain controllers. The reason that I know this is I'm not an Active Directory expert by any means. I've got a few decades more of experience with Active Directory, but I don't use it on a day-to-day basis. So what I did was whenever I was doing the research to figure this out, I first went to help, and before we go and create your own function or command, first I would go through the Active Directory module and figure out which one it is. And this one caught my attention because right in the description it says, gets the user computer accounts that are authenticated by a read-only domain controller or that have passwords that are stored on the read-only domain controller. So it says the list of accounts that are stored on an RODC is known as the revealed list. If you look at the details of the command, you'll see have a revealed account parameter, and this grabs those. So since I'm not going to actually pull any of those out because I don't have any read-only domain controllers, I can just go ahead and run this. It's not going to do much right now because I don't have anything. However, I wanted to include this in here because it is a very useful feature of the AD health check tool because it's a primary security concern. This one is going to be shorter here because notice I just have a few accounts here, but I still want to incorporate this into the AD health check tool. I will go ahead and follow that same logic that we have been in the previous demos. And I will say this one's called invoke RODC password discovery. And I will put all this code inside of the function and then save it. So it looks like this will just output all the revealed RODC accounts for this feature. Again, just like before, since we're adding a new feature, I will go ahead and add the script in here to .source it to get that function available to us. And then I will add another property, cached on RODCs, and that function name. So now we have a new property on here. Now, when I would run this again, just notice I will now have a new property called cache passwords on RODCs. Once this is done running, then I have another property that I can dive in and really get more granular on and figure out which passwords may exist, what usernames may exist. At that point, it's just a matter of diving in to each of these properties here and then taking a look. So if that was cache passwords and RODCs, then I could just dive in, and it really gives you a starting point to do more discovery work. Next up in our demo parade is PowerShell Remoting. This demo will not be AD specific, but is a required primer for the demo following it. PowerShell Remoting is a feature you'll find yourself using over and over again. In a nutshell, this feature allows you to run local commands on remote systems just as if you were sitting at the console. If you're familiar with PsExec, it's kind of like that. It allows you to create a temporary session to a number of different machines and pretty much run whatever you'd like, with a few exceptions, of course. Let's get into a demo where I'll cover a brief introduction. Before we can get too far, in the next demo, we're going to be using a lot of PowerShell Remoting. And I thought PowerShell Remoting is such an important topic, we needed to cover a specific demonstration on just the basics and getting started with PowerShell Remoting. So let's go ahead and do that in this demo. Setting up PowerShell Remoting for the first time between a client and a server, it first needs to be enabled. As of Windows Server 2012 R2, PowerShell Remoting has already been enabled by default. However, even in R2 and later and some of the client systems, it needs to be configured properly for it to actually work. A quick way to enable PowerShell Remoting is to just run enable PS Remoting force. I'm running this on my client now, and this will need to be ran on both clients and servers as well, because PowerShell Remoting is a client and a server system. So you see there that says WinRM is already set up to receive the request on its computer, and it's already set up for remote management. That process ensures that PowerShell Remoting is enabled, so that means it ensures that a service is started and that some firewall exceptions are in there as well. So it's a quick way to get everything configured at a base level. Once you've ran this command on both the server and the client, then it's off to test this out and establish a session. I'm going to be doing this in a domain environment. So if you do not have a domain environment, if you have one computer that's in a work group or both of them in a work group, the configuration is going to be much more involved. But just know that in this demonstration and with our AD health check, I'm going to be assuming that all the machines are domain joined. So PowerShell Remoting has this concept of a session. There's a few different commands involved with PowerShell Remoting that uses this session. The first thing we need to do is we're just going to build a session here. And to do that, I just simply use the new PS session command. Now, when I do that, you see that I have a session variable here. So if I look this up, I have a session variable. The state is open and it's available. So great. So now we have an open session with that remote computer. I can look at all of my PowerShell open sessions by using the get PS session command. So notice that I have a one session here. As I create more and more sessions, I can create multiple sessions for one computer or many different computers. If I run get PS session on the client machine here, you see all those open sessions that I have. If, for example, I wanted to remove all those sessions, I can just pipe get PS session directly to remove PS session, and now you can see that the session is gone. However, because I want to reuse this, I'm going to go ahead and create that again, and now I have an open session. Now that I have an open session, I can reuse this session over and over again for a lot of different things. Everything really is held on that remote system. So let me give you an example. The command that you'll probably be using a lot is the invoke command. And this command is essentially just a command that allows you to invoke all kinds of different code on the remote system. So in this case, I'm just telling invoke command, use this session that I just created, which is on that remote computer, and run this code in this script block. So I'm going to run the hostname code inside of the script block. And if I just run hostname here on my client machine, it's just client1. This is to prove that when I run hostname, it will be running on that remote computer. So when I run invoke command here with hostname, you see that it comes back as DC. That shows you that it is running on the DC itself. Now, one other thing that you may run into is you really need to realize that everything is stored remotely in that remote session. Let me give you an example here. Let's say I want to set a variable. We're going to call it variable equals hello. So I've now set the variable on the remote session. Now if I try to enumerate this variable on my local machine here, you see that it has nothing in it. Well, that's because the variable is actually set in that remote session. So let's go ahead and run this invoke command and see what that variable is here. Now you can see that I run variable inside of that session, it then comes back. The session maintains its state even when you're not in it. So it's always running kind of in the background. It's running remotely on that machine, so you can just come in and out whenever you want. Now this is just a really simple example of using invoke command. There's a lot of other things that you can do with invoke command, and you can use that all with get help. Another connection method I wanted to explain was using temporary sessions. We just built a full session. Whenever I use new session, which comes back with a session variable like this, that's essentially called a full session. That brings up everything that's necessary for you to get a complete interactive experience. Sessions are good for reusing commands like we just did in case you need to do it multiple times over and over again. There's also a really common way that you can run commands with just a real quick temporary session that's brought up and tore down at the same time. And to do that, you can use invoke command here, and instead of using the session parameter, I'm just going to use computer name. I'll specify the computer name with the script block. And now you can see that it brought back DC. Then however, if I look at get PS session here, you see that I just have that same session. So let's just go ahead and remove this and just be sure that it's not opening another session here. So no sessions, run it. That essentially brings up the session, runs the code, and then tears it all down in one step. You'll use invoke command with a computer name parameter a lot if you just have one code block to execute on the machine. If you just need to run a quick host name or gather some kind of information from the remote machine in that nature. So you use that a lot. Now, one of the good thing about the computer name command here is you can use multiple computers as well. So for example, let's say I want to run that code on my DC computer and my MemberServ1 computer. So let's see what this does. It connected to the DC, but notice how it's pausing here. That's because there's some kind of connection problem with MemberServ1. And I thought this may happen because my MemberServ1 is going through a few maintenance things right now, but it looks like it finally did come back. So it looks like DC and MemberServ1 both did run hostname. That's a really good way that you can run it on one or multiple or 100 machines at once. Now again, this was just a very simple example of using PowerShell Remoting and invoke command. There is so much more to this, but there are entire courses focused on just PowerShell Remoting. If you like any more information or running across any problems, I highly suggest first looking at the help for invoke command. And that will provide you a list of all the different parameters and all of the different examples and a lot of other things that you can do with invoke command. But for now, this should give you a primer on how we will be using PowerShell Remoting in the next demo. For our final demo in the module, we're going to add another feature to the AD Health Check tool. This feature will be able to discover the database on each DC in the environment and pull some interesting information from it. We'll use PowerShell Remoting extensively here to do this, since we're going to have to pull some registry information. To do that, we will find each DC's database. Once we find the database, we'll then read the size of the database and determine if whitespace logging is enabled or not. Whitespace logging is a feature that allows you to see the unused space in the database. When defragmented, you'll usually find a lot of this space is freed up. All right, so it's time for the final feature of our AD Health Check tool. And this is a feature where we're going to go out to each of the domain controllers, find out where the Active Directory database is located, and then pull back a few properties from these that we would like to see in our final report. So again, just like we're starting out with the other features, we first need to define a rough layout of what we like the output to look like. And in this case, I am defining a hash table again because this is eventually going to be incorporated into the AD Health Check tool itself, with each domain controller name being a key. And inside of that, we're going to have the database file path, the size, and if whitespace logging is enabled or not. So to get started, I first need to enumerate all the domain controllers again. We've done this before, so I'll go ahead and do this. Before I actually show you how for this to run automatically, We're going to go over a few concepts that we haven't discussed yet. I'm going to cover this interactively first. To do that, I'm going to open up a PowerShell Remoting interactive session that will allow me to run these commands directly on one of the domain controllers itself. So now that I'm in the domain controller's remote session, I can then start running code. Everything that we're looking for is located in the registry. It's defined in a registry value. To get the information from a registry value, we use the getItemProperty command. And the getItemProperty command can be used for anything with a provider. So if you remember from one of the previous modules, we talked about providers. And a provider can be anything like the file system, the registry, even the certificate store, or even the Active Directory provider. So the getItemProperty command works for any of those different providers. So in this case, we want to find the value of the DSA database file registry value. It is located in this key here. So the first thing we need to do to get this database value is first we'll run getItemProperty and get the entire key. So you notice when I just run getItemProperty, I will get all of the values inside of that key. We're just focused on the DSA database file value. So I'm going to go ahead and assign that to a variable. That way we can use it later in our object. And then we'll check out and see what that is. Now notice that it is a file path. Now since it is a file path, we can use getItemProperty again to get information from that actual file. So if I run getItemProperty again, and instead of specifying a registry key, I can specify a file path. And now notice that getItemProperty understands that and then brings back the file that I requested. Now notice there is a length property there. And the length property is 293.765.12. Well, the length property is the size of the file. It's represented in bytes. However, that's not very obvious, so I want to see that in megabytes. Now, PowerShell provides a really cool shortcut to convert bytes to megabytes, bytes to gigabytes, terabytes to kilobytes, however you want to do there, by indicator here just called MB. So MB is for megabytes, GB for gigabytes, KB for kilobytes, and so on. So I can divide my byte value by 1 megabyte and will eventually come out with to be megabytes. So when I run this, now I can see that the size is now represented in megabytes. It's a little over 28 megabytes. It's much easier to see. For the final property we're going to gather if white space logging is enabled or not. And again, that white space logging is a registry value, so I will go ahead and grab all of the information from the diagnostic key this time. And then the value that we're looking for is located in the 6 garbage collection registry value. Again, I will just run this, and then white space logging enabled should represent the value that we're looking for. So it looks like it's 0 right now, so it's off. I know by experience that 0 means if it's off, 1 means if it's true. However, that's not very friendly. I need a better output. I need it to represent true or false instead of 1 or 0. To do that, we can just simply use this if condition to say if it is 1, then change the value of white space logging enabled to true. Else if it's 0, then change it to false. So I can go ahead and do that. It's just a real quick example to transform the output. And then finally, once we gathered all of those variables, we can now put it all together into an object. Again, we are using the PS Custom Object Type Accelerator here and then specifying an array. So this just is going to create a simple PowerShell object. Now notice that for the key here in this hash table, the key is left paren hostname right paren. We've used the hostname in the past. The hostname command simply enumerates whatever the hostname of the machine that is currently being executed on. And since this is going to be executed over a remote session, hostname is going to represent every single one of the domain controllers that we run this against. So whenever I run this in the remote session itself, you'll see that it has DC there. That's how I can tell that this is running on the DC domain controller. That is the whole process for a single domain controller. So now let's back out of the remote session and get back to our local session here. And let's remove out the manual steps here that we had to do. We've already created all this, so we can just remove all this comments out here. To demonstrate one DC, notice that I was just pulling out one line at a time and executing them. However, this code was enclosed in a script block. So I have a script block variable here, and it goes all the way down to here. So I have all of the code that we just went over all enclosed in a script block. So a script block is just a package of code, I guess you can say, that can be executed on command. Because all of that code is encapsulated up into a script block, we can now run invoke command and just say, invoke command, go out and, hey, run this piece of code on this DC, run this piece of code on this DC. That's what we're going to do here. So let's first make sure that we have all the domain controllers. So we have our DC's variable defined, and then inside of the DC's variable, we have the name property, and it has DC and memberserv1, which is both of my domain controllers. Once I have the target machines, so the domain controllers, I can then just specify the group of domain controllers for my computer name parameter, because my computer name parameter can accept more than one computer name. The script block, which is the script block we just defined. And then I'm also specifying hide computer name here, because by default, invoke command will output the actual computer name that it executes on. So in this instance, I don't want that output, so I'm just going to use the hide computer name parameter there. So I'll go ahead and run this, and it should run pretty quickly. So that just invoke command went out, established a remote session to each of the domain controllers, and ran that code and got everything back. So let's see what it looks like. At first, this doesn't look anything like we were thinking of. We have memberserv1, I see a reference there, but I don't see DC anywhere, and I see this run space ID. The first thing we need to do is we need to get rid of this run space ID, because I don't want to see that. That's an extra property that's included whenever you run invoke command. To do that, I can run select object with the exclude property run space ID. Now, in order to use exclude property, I have to actually also specify all the properties. So it's a little counterintuitive, because I'm essentially saying I want all the properties except the run space ID. This isn't mandatory. If you do this, this won't have any output at all. So just remember that if you're ever trying to exclude properties. And then I'm going to overwrite the original results value. And I go ahead and run this here. Now let's see what results is. Notice that you think, well, I thought we ran this on DC and memberserv1. It was two domain controllers. Well, this is one thing you might run into, because PowerShell tries to format the output in a way that you would expect with the console. Sometimes it works, sometimes it doesn't. So what you see is not what you get with PowerShell sometimes. To really see what's in results, we can pipe this to select star, which says get all of the objects. But again, look and see, that was the first inclination. I want to see everything. I think that select star will do that. Well, it doesn't in this case, because we don't see every one of them. Now, sometimes you can do this. You can specify the index. So since results is an array, instead of using select, I can see which elements are in that array with 0 or 1. And then notice that I have memberserv1 and DC. So DC is kind of hidden in there to where you don't usually see it unless you are looking. So that's one thing to keep in mind. Just looking to see, let's just make sure that one of these looks okay before putting this into the tools. So we have results 1, memberserv1. So we have each of the values that we are looking for. Now, notice that it has name and value here for the property names. We needed those in a hash table. Looks like we got everything done. So let's remove all of the demonstration code that we had here, and we will put this into our AD health check tool to round out the feature set. We need to output results at the end, so our health check tool would understand this. And let's just go ahead and run this on its own and see what happens. Everything ran fine. Let's bring this into a function, and we'll call this invoke AD database info. We will add the param block and put all this code into the function just like we have previously. Tab that over to make it look nice. All right, don't need this comment anymore. Looks like we're good. So let's go back to our AD health check tool again for the final time. Add the script that contains the function that we are going to execute, ad-database.ps1. Add our final property in here, AD database info, that's good. And then we need to grab the function name, invoke AD database info. That should work. So now, instead of invoking this directly, I'm going to invoke this from the console so I can assign it to a variable so we can look at the output more closely. So that's demos, invoke AD health check.ps1. All right, so that should execute the script. So now it is executing, and it will take a little bit because as we add more and more features to this, it will take a little bit longer. I will go ahead and wait here for just a second, and through the magic of video editing, I'll be right back where we will explore the output a little bit more. All right, looks like it finally got finished here, so let's see what output looks like. Looks like we have everything in here. So we have all of the previous ones, and we also have our new AD database info. So let's look at our AD database info a little bit. And again, we just see member serve 1, but now we could just reference it with 0 and 1 again. Then we have member serve 1 and DC. The original formatting that you see here is going to be a problem whenever you would just normally look into this, but in our next module, we're going to build an HTML report to where we'll be able to address the problems like this. Otherwise, just casually going through here, there is no cache passwords on the DC, so that's going to be blank. And it looks like everything else is still here. That rounds out our AD health check tool. So now, in our next module, stay tuned, so we will take this raw output and convert it into a nice looking report. In this module, we're going to take the tool we've been building throughout the course and put a bow on top. We'll be taking what once was an ad hoc tool and transform it into something that can send out HTML formatted messages on a regular basis via email. Throughout this module, we're going to be focusing primarily on 3 topics. The first is converting our AD health check tool's output to HTML. We'll do this to get into a format that's a little easier to read and allows us to use HTML and CSS to manipulate the output of the report much easier. We're then going to go into automating the report and running it with a scheduled task. I'll go over how to create a scheduled task with you with PowerShell to invoke that AD health check tool to ensure it's ran every so often. And then finally, we'll add email capability to the health check tool. This will ensure the results of our HTML format report is seen by the appropriate people to keep tabs on AD. When working with HTML and PowerShell, the command you're going to have to get used to is convert to HTML. This command is a shortcut for taking objects and converting them to an HTML table. You'll see that this command is pretty simple. There's really not much to it. However, it's a great shortcut for converting objects with the properties to HTML tables in a couple different formats. However, if you'll need to add any other formatting to the report, you're on your own really. Don't worry though, I'll walk you through some basic tweaks to the final report to make it pop. Let's now get into our first demo of the module where I'll show you how to convert objects to HTML. Once you've got the basics down, we'll then jump straight into converting the output of our AD health check tool to HTML. So we have our AD health check tool all done, and now we just need to spiff it up a little bit, and to do that we have to use HTML. So before we go into some details about applying HTML to our AD health check tool, let's first just go over a quick demo here and show you what it's like to work with HTML and PowerShell. The first thing we're going to do is we are going to grab just a general output here. So I've chosen to use Get service, so I'm just getting all of the Windows services on a particular machine. And I'm choosing to output the status, the name, and the display name properties for each of the objects that Get service returns. So I will go ahead and just run this, and then you can see that I have a variable here that contains one object per each Windows service. So I have quite a few there. Right now, these objects are displayed in the PowerShell console with a table format. Whenever you'd like to convert this to HTML, PowerShell provides this convert to HTML command. What this does is this essentially replicates the formatting that you see here in the PowerShell console just with an HTML table. So let me show you an example. So to use this, we just simply pipe the services variable. So we pipe all those objects over to convert to HTML. Then once I do that, then I have a big string called services HTML, and now you can see that it looks quite a bit different. It's actually created the entire HTML web page for me, even with the doc type, the head tag, the title tag, and so on. By default, for each of the objects that are passed to convert to HTML, it will create an HTML table here. So you can see that we have an HTML table with each of the objects defined as rows in the table. Now this is the default output here. This looks fine with a plain text display, but I would like to see this in something that will actually render the HTML. To do that, I will just output this content here to a file called services.htm. Now I can do that with just simply passing it to out file, which takes all that text that we just built there, which in this case is HTML, over to create the file called C services HTM. As a shortcut to bring this up in Internet Explorer, I will just use invoke expression, pass that C services HTM, and now I'm opening it up in Internet Explorer, and you can see here that Internet Explorer renders the HTML just fine. Looks great. Status name and display name, the properties of each objects are in bold there, and it just has in a nice table format each of the Windows services. So in a nutshell, that's the gist of Convert HTML. So let's take a little bit farther here. Now, Convert to HTML also has some additional parameters to it. One is the title parameter here. Whenever I bring this file up again, you'll notice that the title here is just HTML table. It just makes a general HTML table. Maybe I want to change up that title a little bit. I can do that by using the title parameter here. I would just name it Windows Services, output it to C Services HTML again, which just overwrites the file. And then whenever I look at it again, you'll see now that the title is Windows Services. So there's various little tweaks and things you can do. There's not a whole lot you can do, unfortunately, with Convert to HTML, but there are a few little tweaks here and there that you can do things. If you're curious for all the other parameters you can do, obviously you can use Get Help for just about any command, and I encourage you to do that because we're not going to go over each of the individual parameters here. Just suffice it to say, if you need to do anything else with HTML, first look at the Convert to HTML help content, and then if you don't see the functionality in there, we'll have to figure out how to do it a different way. The Convert to HTML command also has a head parameter. If you're familiar with HTML, it is a tag at the top of every HTML page. So right now I just have the head tag with a title tag inside of it. The head tag in HTML allows you to define a few things. One of them is CSS formatting. Now I'm no CSS guru by any means, and I don't expect you to be. This header here that I've captured, I just Googled it and was able to find a good example of how to format a table. This is where the design-friendly people in the audience will come in handy because they're good at designing and being creative. That's not me at all. Just suffice to say, I wanted to show you a good example of how to make this table look a little bit better. And once I have that header, I can define that head tag here, and then I can just pass the header string here to the head parameter. So I will go ahead and run this again, and then now I will check on the file. And now you can see that we have some borders and we have the top in blue. That's a good example of using CSS. CSS options are unlimited, but like I said, I'm definitely no CSS expert, and this is not a CSS course, but this gives you a good example of what is possible. Now finally, just to wrap up this demo here, I would like to use the pre and post content parameters of Convert to HTML. Now the pre and post content parameters are parameters that allow you to specify text before the table element and after the table element. So let me show you an example. Let's say that I want to name this HTML page the Windows Service Report for computer and then whatever name the computer name it's running on. So I will add this here to my session, just load this in. And then at the bottom in the footer section, I want to say found however many services it found on the computer, total services. So common header and footer situation for an HTML report. Now once I have that, I can just simply use the pre-content and post-content parameter to convert to HTML. In this instance, I'm using splatting. I don't believe we went over splatting yet, but it's a very simple concept, but it's very powerful and allows you to really organize your code. So notice that up here for convert to HTML, I'm using the title parameter and the head parameter. Everything is on one line. Now imagine that you have 10 parameters. If you would, they would get spread out all the way across here, and I would have to do this and that, scrolling back and forth all the time. PowerShell best practices dictate that you should probably never keep your line length over 150. So 125 to 150. If you're starting to get longer than that, you should probably look into doing some things that cut the line length down. And one way to do that is through splatting. Here with splatting, I can assign a variable and assign it a hash table. And then inside of that hash table, I can define each of the parameters that we need to pass to the convert to HTML function. So I have title, head, pre-content, and post-content parameters. This is doing the exact same thing as I was doing here. So in this instance here, 25, I could have defined a hash table with a title and head keys in it, and then passed it to the convert to HTML function, and it would do the exact same thing. Splitting is just a really good way to organize your code and to keep the line length down. Saying that, I'm going to pass all these convert HTML params to our convert HTML function, output it to services once again, and now we'll check it out and see what it looks like. So now notice that we have some text up here, Windows Service Report for a computer, and then it expanded that variable out for client 1. So this computer is client 1. And then at the end, you see there it says found 181 total services. So the pre and post content is a really good way to set the table header and the footer content. As I said, there's a few other parameters to convert to HTML, which we didn't get covered, but by all means, if you want to explore a little bit further to convert to HTML, just always use Get Help, convert to HTML, and you'll be able to find a lot of that good information in there. All right, so it's now time to take our AD Health Check tool and convert it to HTML. Sometimes this is easy as sending all of the output that we have directly to convert to HTML, but since our AD Health Check tool has gotten fairly advanced, we need to go through and do a few tweaks to the tool itself and do a little bit of manipulating. Let's get started here with that. So the first thing I need to explain is what we've done here is I have the Invoke AD Health Check tool script that we've built throughout the course. 90% of it is exactly the same, but there's a few things that had to be changed in it in order to get everything properly formatted to HTML. So I'll go over those few things at first. So the first thing you see here is that we don't have all of these scripts defined to be dot sourced. To demonstrate this, to show you what it did look like, let's go over here to demos here, Invoke AD Health Check. This is what it used to look like. So we used to have a scripts array here with all of the different scripts in it, and then we dot sourced everything in the array itself. However, up here, we've completely removed the array, and instead of just looping through the array, I'm actually reading all of the files in the scripts path folder here. So you can see here that in the demos/scripts folder in this demos directory here, I'm actually just reading all the files in there. So this is a way that I don't have to duplicate some effort and define each file name in an array. Now I can say, just give me all of the files in that folder and dot source them all. So that's one change that I had made here. So the rest of it, this is all pretty much the same. We are grabbing the AD users again. And then here is where we start defining what we want the report to look like. So before, the report was very simple actually, if you remember. However, we want to spruce it up a little bit. Before you even get started coding at all, it's first important to define what you would like the report to look like. So I've done that here. So I've taken all of the different attributes and things that our report already outputs, and then I roughly define these into a format that I would like to see when everything is done here. All of this, I haven't added any properties or anything like that. I've just simply changed how the formatting looks. That's the first thing that we need to do here. I've broken this out in a few different sections here. So as I was building this demo, just as you will with building your own tools, you're going to have multiple different attempts. So in this first attempt, I tried to get some kind of HTML that looked similar to what I was doing. And then I decided, well, no, I need to add something else. And then you go back through it, no, I need to add something else again. So that's how this demo is going to be structured. So the first thing I need to do is I need to break out each of the sections. So you can see up here that I have a DCDiag test results section, I have a replication status section, and a database status section, and so on. So I need to break out each of those sections. So the first section I have here, I'm calling account display, and I have a few of the different attributes on here. So this is going to be all of the attributes here in this first section. So I didn't change anything. The output is not changed at all. We are gathering all of the same information that we were previously. However, I'm just assigning these all into a hash table so I can group them together. So I'll go ahead and run this. And now I have the count display hash table with all of the appropriate values in it. You see that I have all the different values that I was looking for that were previously here. Next thing, I need to grab all the user passwords that are going to expire soon. This is word for word exactly the same as what it was in the AD Health Check tool that we covered previously. So it's just another property here called expiring password. So that's exactly the same. Let's actually go through and create the HTML. So because I have all these in a single hash table with the count display, as you've learned before, you can convert that into a PS custom object. So when I convert this into a PS custom object, you can see here that it turns to locked out accounts, password not set, etc. So each of these are properties. And once we have the object, I can then pipe that to convert to HTML. And because I need the title to be Active Directory Health Check Report, I can simply provide the title parameter here to convert to HTML. And here's an option that we didn't have before. Let's go ahead and just output this and show you what this looks like. This is going to take this count display custom object here and convert it to HTML. Actually, I'm going to output this to a file and show you what I'm going to change up here. So let's say out file CAD health check before, and then we'll do invoke expression CAD health check before. So notice that it's in a table format. So we have the properties all along the top line. So all the property names are on the one line, and then all the values are on the line below it. If you notice, that does not follow what I want the output to look like. You see here that I want a property name and then a property value on each line. So they're each individual lines. This is known in PowerShell as a list format. In order to get this kind of output, you have to use the as parameter on the convert to HTML function here. So you can see here that I have as list. This defaults to as table, but I need to use it as a list. So let's go ahead and run this. And now let's see what that looks like. I believe it's adhealthcheck.htm. Now notice that it's set to a list format, so I have it's exactly like I would like it to be. So I have each property here on one column and then the properties on the other. So first task done. And then the next thing I need to do is I need to append all of these different tables to this HTML file. So previously we just had one big file and we didn't do much with it. We were just creating a new HTML file every time we ran. Since we're running this all for one script, we need to append this information. To do that, we can use a few different things here. So this is the very first one. So I'm saying create the entire page first. So this convert to HTML command, that will actually create the file. Afterwards, I don't need to actually create the file again. I just need to append new content to the file. To do that, I'm then going to run my invoke DCDiag function that we had previously, exactly the same as before. And then once I gathered the output of DCDiag here, you see that I'm passing DCDiag to convert to HTML. Now this time you see I am using a fragment parameter here. By default, convert to HTML creates the entire page. So it has the doc type, the head, the title, and all that information. If you use just the fragment parameter here, convert to HTML will just create the table itself. And then I'm also using the post content here to create an HTML line break right after that. Let me go ahead and show you what this is. I believe that I already have the contents of DCDiag out. So I do here. Let's try this out and see here. So I had to run this. Now you can see it's appended the table to our existing HTML files. So I have the output of our counts that we had earlier. And now you can see it has test result entity, test name. It has all of the information that we have from invoke DCDiag here right below it. It didn't create a whole nother HTML file. Instead, it just created that HTML table and appended it. And we're using the exact same thing for our invoke replication monitor. So we're grabbing the results of that just like we were in the previous module, adding that to there. If we would look at this one more time, you see here that we have the same information we just had, and then it just invoked the table at the end. Just as simple as that. We're just appending on to the HTML as we go along. After we've added the replication status, then we just need the AD database info, doing the exact same process that we were before. So I can run this, and then we will check the HTML file again. And then notice that we have everything we need, but it's close. We have all the tables, but we need a little tweaking here. This doesn't look exactly like we need it to based on our previously defined structure that we had. The next phase here, we need to add table captions. Unfortunately, there's not a way to create actual caption tags in HTML by default with the convert to HTML function. However, we can sort of replicate that with the pre-content command here. You'll see here that I'm defining pre-content. I'm using the spaces, and then the BR here is a line break, so that just means a break inside of the HTML contents here. If you refer up to how we want this to look, notice here we have DCDiag test results and a bunch of dashes. Then we have replication status and dashes, database status and dashes. I'm iteratively going through this and just making sure that the output that I'm getting looks exactly like the output that I defined in the first place. To add the captions, I will just use the pre-content. I would just add this, and this is the only difference that I have. Instead of using just post-content with a line break, I'm actually using pre-content here as well. Let's go ahead and run each of these lines here. This is going to recreate the HTML. And then we run this again. Now notice we have lines, and we have lines here, and we have the names of the captions right above it. We're getting closer, step by step. This is all about building a tool like this. You can't do it all in one shot because this can get very complicated very quickly. So you just do one piece at a time. Now we have the table captions here. The next thing that we need to do is we need to tweak things a little bit. So let me show you what I mean here. Referring up to this again, notice that I have replication status, and then I have domain controller, last replication attempt, replication status here. Same thing with database status. We have the database status label, and then we have the properties here. However, looking at our current output, this looks good. We have the replication status looks good, but look at database status. We have PS computer name and PS show computer name. I don't want those in the output at all. In order to do that, we can either limit those properties inside of the DB info. If I look at DB info here, well, first of all, it doesn't even show up. The reason for this can be a number of different things. Let's see if it shows up with select.star. See, notice that it didn't even show up with select.star. Now, there's some instances where this will happen. To keep things simple, let's just say that it's much easier to convert this out to HTML, so convert it down to a text format and see what happens. In order to remove these with the convert to HTML, you can actually specify properties that you only want to see. For this property parameter, I'm using domain controller, DB file path, DB size, and white space logging enabled, which is exactly what I want to see. I don't want to see any other ones. So I will run this again and create the HTML file. And then I will look at this again, and now notice that those two properties have gone away. This looks exactly like I need it to. As a once-off, just make sure that I got everything. Oh, looks like I did forget one thing here. So I want a ran footer at the bottom here and with the name of when it was ran. So let's go ahead and just add this here on the fly. That footer is below the database status table here. In order to get this below the database status, I can use a post content here below this table, which will then add it to there. So let's go ahead and put this at the bottom here. Database info, convert to HTML. So I have pre-content, and notice that I'm not using post content. So I will just put in post content here, and I will say ran : and then I want the date. So get date. And because I am converting this over to a string, I don't need get date to be an object. So I know getDate has a toString method. I can enclose all of this with a $paren. Now we should be able to get that footer. So let's check it out and see. And this again, no errors, which is good. Test the results. And now you see we have ran and then the date and the time that it ran. Notice that it's not a very fancy report by any means. In this course, I wanted to show you the basics here. So how you get this out to HTML. Once you get it out to HTML, you can see that it's just an iterative process. I encourage you, if you need to change this up in any way or make it look prettier, you can definitely do that using some of the CSS techniques that we saw in the later demo. But for now, we have everything exactly like we need it to. So then stay tuned for the next demo where we'll go through and we'll really put the finishing touches on the AD health check tool. As with any semi-complicated software project, our AD health check tool could stand some tidying up at this point. Building scripts like this is an iterative process. When a project is completed, you'll usually stand back and think, wow, I really would have done it this way the first time. And that's no problem since it's just code. Just ensure that the time is added to the end like we're doing here. We're not going to change the AD health check tool drastically here. Rather, make it more efficient, easier to read, and thus more manageable. This is done by using the dry method, or don't repeat yourself. This is a core concept in software development that essentially means Use variables and loops whenever you can instead of repeating code. This makes the tool much more manageable. And finally, I'll use PowerShell regions to modularize the code a little bit. This is a small but important detail to point out because, as you'll see, once more code is added, being able to hide and show specific parts of the code makes maintaining it so much easier. As with building a typical PowerShell tool, our last demonstration on working with the AD Health Check tool is a demonstration on just cleaning it up. So what do I mean by cleaning it up? Well, I mean, don't change anything functionally with the tool, but take a look back at the tool and think about what things you may have changed. So how easy is it to maintain? How readable is the code? And that sort of thing. So you'll find this every time when you build a tool in PowerShell. At the end of the fairly large project, you'll end up saying, well, I wish I would have done that differently, or I need to make this tweak here so I can change this more easily in the future. So those are the sort of questions that you need to ask. And these are the sort of questions that I've asked with a tool, and here's what I came up with. So this is an example of our AD Health Check tool. And notice that I've named it Invoke AD Health Check Report. The previous ones were just called AD Health Check. And functionally, this is exactly the same as our other one. I've added a few formatting tweaks and things with the HTML, but nothing that really affected the raw output. I'll go through from top to bottom on this and explain each of the things that were changed and why I changed them to give you maybe some good ideas for your other projects. So the first thing I have here, regions. And I use regions sparingly in a few of the other demos. Regions are a really good way to hide code. So notice here that the code that I have in this script is 99 lines long. However, if I just collapse the regions, I'm making this code more modular so I can easily see what it does without getting confused by seeing all the other code. So that's the first real change that I made. The first region, in this case, I called it setup. I usually have a setup region or section in some of my more complicated scripts because for PowerShell best practices, it's good to define all of that original, all the meta things. So what do I mean by meta? Well, I mean all of the data that you will be using throughout the script. So for example, here on line 18, I have the DCs. So I'm grabbing all of the domain controllers. In previous demos, we were getting domain controllers from a few different places. We were getting it over and over and over again. We were actually repeating ourselves and making unnecessary calls to the domain controllers over and over again. As I went through, I thought oh yeah, I'm actually doing it more than once here. Let's just bring it up to the top in this setup section, and then now I can use it within the script. I could just call DCs over and over without actually having to do that. Same thing with AD users, just doing it one time. I'm grabbing all of the raw data that I need up front and putting it into this setup section. Now, once I do that, I'm then creating a function parameter declaration section. So let me show you why I did that. So if we go back to our old script here, so we'll go back to our one that we created in our last demo. That would be a good representation here. So notice that in here, I am repeating myself quite a bit. So I have convert to HTML, convert to HTML, convert to HTML, and I'm having the same general parameters on a lot of this stuff. But in reality, all this code is doing is it's generating 3 or 4 different sections for a report. So why would I have to repeat this over and over again if I have so many different similarities? This is part of the dry method, or the don't repeat yourself. Whenever you're done with your code and you want to clean it up, it's a way to really define and identify each of the areas that would make this code more readable. Here I have 110 lines, but if I want to go ahead and change one of these, I'll have to change it here. I'd have to change it here. I might have to change it up here. You need to create a situation where you only change it in one spot. So let me show you up here. I'm defining all of these in one spot. So first of all, I'm defining the header that we're using for the table. In our previous example, we used the header just for one table. Here with CSS, I can actually use this for all the tables. Since I'm changing the style here to just this table element, this is going to apply to all the tables. Next, you see the section separator. I've defined a variable with the HTML line break here at all the dashes. I did that because if you can see here, I have line break dashes, line break dashes, line break dashes. So I noticed that I'm using this quite a bit. That's a really good indicator that you need to assign this to a variable. Next is the sections array. Sometimes this can get advanced. So let me tell you the reasoning why I did this. So I have these sections array here. Notice I have 4 different hash tables. I've conceptualized the AD Health Check tool because Whenever we ran this, we had 4 different reports. It's 4 different sections. We had 1 section, 2 sections, 3 sections, 4 sections. And each of these are very similar. They're just HTML tables. And notice this is the new report that it generates. But notice that there are just HTML tables. So I conceptualized how this works and then wanted to apply these and just label these as sections. It's a really good way to kind of bring up and give you an abstract away some of this code to where you can manage it easier. So in each of the sections, I've defined a function name. So I'm associating a function name with each of these sections. Looking at the top one here, notice I just have my properties and my counts. Previously, I didn't have this as an actual function. I just had it down here in count display. However, I had all the other ones as functions. I had invoke DCDiag, invoke AD database info, invoke replication monitor. Each of these were sections. This count was a section here, but I still had it out right here in the raw script. It's a good idea to standardize that and make it into a function. So I did. So I created a get object counts function. All that looks like is I just essentially called it object counts, put it into a function called get object counts. I'll explain the parameters in a little bit, but notice that it's just a simple matter of taking that out and putting it in a function. The only reason I did that was because to replicate how the other sections were created, because then I can create this loop here. Each of the functions had a few different parameters. I'm using the users and domain controllers. I've defined parameters for each of these functions. So if you notice here, I have users and domain controller. I did that because I can now define the users and DCs up here in my setup section. I've defined them here and here one time. And then once I define them here one time, I can just pass them to all of my different functions. So here I'm passing users and domain controller and then using those inside of the function. Same thing with my replication monitor. Here I just need domain controller. So I'm using it in here. If I go to any of the other ones, AD database, I put a parameter up here called domain controller. I'm just passing it in and using it how I need to in there. And the same thing goes with all the rest of them. I parameterized the function so that I can define it once in my main script and then just use it over and over again and pass it to my other functions. Since each section has specific parameters needed for the convert to HTML command, I'm defining all the parameters needed for each of the functions. So here I have all the parameters that are needed for convert to HTML. The same thing with here. Notice they're a little bit different. I have fragment here, pre-content, post-content. They're a little bit different. So I couldn't actually use the same ones over and over again because they weren't required. So I need a different convert to HTML params. Now notice that these are a hash table. As you learned in one of the previous demos, applying these with splatting. Once you get more advanced in PowerShell, you'll use splatting a lot in the situation. And then the same thing with out file. So I have out file params. That's the params I'm going to pass to out file. And I did the same thing for each of these sections. So I have the get object counts section here, the invoke DCDiag, invoke replication monitor, and invoke AD database info. So I've associated each section in this report to an individual function and then defined out all the specific parameters that are needed to run each of the functions and commands that I needed. This part right here, this was a big help for me because now whenever I need to change this, I don't have to go looking through all the lines to figure out which lines I need to do. I can simply come up here to sections and say, in my object counts, I just want to see users that are enabled. Here I can just do where enabled, put that in here. Now I know that that would affect all of my object counts for all my AD users. I can do it once and it applies many times. Really good habit to get into. So once I have all of the sections defined here, now I can collapse this region and I can just focus on the next one. When writing good PowerShell tools, in the bottom here, you'll notice that it's pretty small. The reason is because you need to do all of your planning up top as much as possible. These two regions here were the hardest by far because you're doing all the hard work. You're defining this variable equal this variable when this function runs. Is it passing these parameters to this function correctly and this and that? When you actually get down to executing functional code, if you've done it right, it's usually very, very small. So actually executing the code is usually pretty easy. So in this instance, since I've defined each of those sections in the sections variable, I can now apply a for each loop. So I can apply the same logic or the same code to each of these sections. In order to do that, now I can just define what are my function params, my convert HTML and out file params. So I can define each of those parameter sets. And then here, notice that my function name is actually a variable. Now I can do that with using the ampersand here. So I'm using the ampersand, which is the executable symbol here, which makes this executable. So instead of invoke DCDiag dash domain controller DCs, I'm actually running this here. Essentially just takes this step further and replaces that function name that we were statically putting in there before to a variable. When it's a variable, you have more flexibility and more control. And then since I have function params defined in a hash table, I can then use splatting to simply pass that to the specific function, convert it to HTML using the same splatted parameters, and then outfile using the same splatted parameters. So in essence, all of this code that was in here, the huge majority of this code, notice all this code is really, really ugly. In essence, this all comes down to this line here. It does exactly the same thing. I'm just gathering up all that data and defining all those relationships earlier in the process. And then now it's just a simple matter of looping over the sections and then executing each of the functions with the right parameters. Our output is exactly the same. I've added a title here, which is pretty easy to do with the pre-content as you learned previously. And I'm using the CSS header for each of the tables, so I have the nice pretty output for each of those tables. So that concludes all the work that we're going to do with the AD Health Check tool. So I hope the whole process going from scratch all the way up to this point really helped you. I purposely intended to not do everything perfectly the first time going throughout the demos because I really wanted to show you not just how to build an AD Health Check tool, but to actually learn the process on building a general tool to do whatever you want. I hope that was a good demonstration for you for building the AD Health Check tool. Next up, we are going to be focused on taking the AD Health Check tool, building some scheduled tasks for it so we don't have to worry about invoking this manually anymore. So now we've got our AD Health Check tool all built and it's running great. Awesome. Oh, but wait, AD just blew up because I forgot to run it. Oops. Well, let's nip this in the bud and next time and make sure to build a scheduled task to automatically execute it on an interval. Now, technically, we could do this manually, but this is a PowerShell course. Let's do it with PowerShell. In the upcoming demo, we'll go over how to execute the script from a scheduled task. By doing so, we'll cover what it takes to get a scheduled task in PowerShell that you can apply to other tasks as well. So we've now got the AD Health Check tool all created and it's working great. However, it doesn't really matter if it's the best tool ever if it's not ever executed. Let's ensure that it's executed on a regular basis and build a scheduled task around that. Building a scheduled task, we can do this manually, but since this is a PowerShell course, I've decided to show you how to do this with PowerShell. That way you can just automate this later on if you need to. Whenever I first started building scheduled tasks with PowerShell, I thought, well, just call new scheduled task and pass a few parameters and be done. Well, that is not the case, as you can see, because if you really look under the covers of a scheduled task, it can get pretty advanced. There's a lot of different objects to worry about, so let's go over that. A scheduled task has a specific action, so it has a file that needs to be executed somehow. And in this instance, we are executing a PowerShell script. So notice that we have the new scheduled task action command, and the parameter is execute, and we have a parameter of PowerShell.exe. So that's just the PowerShell engine. And then we have an argument parameter here, and in this case it's psarg, so it's a variable that I'm setting that passes the arguments to the file. So this is important to know. Whenever you are executing a PowerShell script via a scheduled task or anywhere else other than invoking from the console directly, it's a good idea to specify a few different parameters. Technically, the only one that you really need to do is file. So if you pass -file to PowerShell.exe when calling it from cmd.exe, for example, the command prompt, all you really need to do is pass file and the name of the script. So in this instance, I have script path as a variable because the variable name's too long. You just have the name of the full path of the PowerShell script. So in actuality, the only thing that's really required is this. However, when you're doing this from a scheduled task or some kind of other automation engine, it's a good idea to include these two parameters on here, non-interactive and no profile. The reason is because whenever PowerShell.exe brings up by default, it's going to create a profile. We didn't go over what profiles are in this course, but suffice it to say, whenever you are executing a script in a scheduled task, you typically do not need a profile. It's just overhead that's not necessary. That's why you can use the no profile command here. And the same thing with non-interactive. So non-interactive sets PowerShell in a mode to say you're not actually going to bring up the console and start typing commands with it. This lets PowerShell know that all I want to do is execute this script and then die. So that's all that's going to happen. These two parameters here are a way to make this more efficient. So let's go ahead and we'll do this one at a time. As I'm explaining each of these, I'll do that. So that creates the action variable here. So we haven't actually created any scheduled tasks. We are just building up to that point. The next thing that's optional, which I usually try to do, is set a scheduled task principal. So let me bring up the schedule here and I'll show you what I'm referring to. Whenever I create a scheduled task, I typically want the option to say run whether a user is logged on or not. I don't want to have a dependency in place to have some user logged on to my machine. This option right here, when running a task, use the following user account. And it has a user account here, run whether the user is logged on or not. I always want this 99% of the time. I want this set because I don't want to depend on a user being logged on. And in order to do that, I have to set a principal here and set a logon type of S4U, and then I'll specify user ID. In this case, I'll just use administrator. This is not necessary if you are running under the credential that you create the scheduled task under. It will just create the scheduled task under whatever credential you are using. But I usually add this in here for all of my scheduled tasks to invoke PowerShell scripts. Next thing is the settings. This is the new scheduled task settings set command. Is a way that you can specify all kinds of various settings to this. This is completely optional again. If you just hit dash here, notice I have a lot of different options here. Now you can set any of these you want. This is a good way to really get granular with your scheduled task and set it up however you need. Typically, these are the only two that I always set for PowerShell scripts. So I have start when available, which essentially just makes it startable when it's created. And then hidden, because if I'm creating this in some kind of automated way, I don't want it to show up inside of the task scheduler. It necessarily may not be a problem, just being anal sometimes. For now, just so I can demonstrate this, let's just take this off, and then we will create that variable. Once I have the action, the principal, and the settings variable created, I can then actually go and create the scheduled task object itself. And then it's just a matter of combining all those two into a task. So now that I have task, the script still is not created. So if I refresh this, you see that the script still is not created in here. To actually create the script, finally, is to use the register scheduled task and then provide the input object of the task. I'll give it a task name of AD health check. So when I run this, this actually will run the check. So notice that it gave me access is denied. That was because you need to run PowerShell as administrator when doing this. I'm not running the PowerShell ISE as administrator. So I'm going to go ahead and do that here. So let's bring up the ISE and I will right click, run as administrator. And then let's go ahead and open up this file again. Now, since I went over each of the sections one at a time, I can just run the whole script once. All right, I still got access is denied. I believe that's because of this scheduled task principle here. Instead of cleaning this up, let's do this together. So the first thing I want to do is just comment this out and then run the script again. See what happens. Access is denied again. So I'll go ahead and delete the principal out. So I'm not even going to use the principal again and see what happens now. So it was the principal option here. It did not allow me to set it as administrator. So let's now look and see what it looks like. We have AD health check tool. And now notice what happened. When running a task, I am logged in as my lab administrator, but now it says run only when a user is logged on. I do not want to run only when a user is logged on because it's not good practice to leave a user logged on all the time if you can't help it. So notice that instead of administrator, it's set to my domain name /administrator. So next thing I want to do, I want to try and put that in there and give it another shot and see if that works. So I will add the principal back in, uncomment that, and then instead of administrator, I will just do my lab /administrator. Run this again. Now see that it worked. All right, to confirm, I will go over to my task scheduler, refresh, and then now you see run whether user is logged on or not. So there was some discrepancies there between a local administrator or domain administrator. In this case, I wanted it to run as a domain administrator. Not technically necessary for the AD health check tool. It just needs to read various things from AD. That's all there is to creating a scheduled task. Now, you could easily wrap this up into a function, but since we're only going to be building one scheduled task to invoke the AD health check tool, we don't necessarily need to spend a whole lot of time automating the scheduled tasks. We are only going to be doing this one time. For our final demo, we're going to incorporate email into our AD health check tool. Because even though a scheduled task might be executing, the script doesn't necessarily mean that anyone's going to be looking at it. To do this, we'll use the send mail message commandlet. You'll see that once the report is built, adding email capabilities is a fairly trivial task, and it's due to the simplicity of the send mail message commandlet. For our final demo of the module, let's add email capability to our AD health check tool. And to do this is a piece of cake. So this should be a pretty short demo because of the great functionality that the send mail message command has. Send a mail message is very simple. In our case, since the AD health check tool is already in HTML format, we can just simply use this as a body to the message. We could also do it as attachment or whatever, but for now, we are just going to be specifying in the body for the email. First, I'll define the HTML file path. In this case, it's just a root of C. I can then just read the email body with get content. So email body will now be the email contents of our tool. So notice that we have all of the HTML content in here. And then really after that, it's just as simple of running send mail message with the right parameters. It's pretty easy. We have send mail message, the to, so where do you want to send it to? This could be a group email or something like that. Subject, I name my subject AD health check report. Body is HTML. This is optional here because sometimes you may have a plain text email message that you would like to send, but since our report is already in HTML, we can actually make the body as HTML, specify the body, which is the HTML content we just created, where it's coming from, and then the SMTP server here. So really that's all there is to it to send out the email. Knowing this, let's now just quickly bring this into our AD health check tool. That will round out our tool, which will pretty much round out the course as well. So let's put it into our final one. So we have the report. Here we've generated the file. So after this for each loop here is done, our file will be generated. Now we can just copy and paste this here. We actually already have the HTML file path. If we go out here to out file params, file path was HTML file path. Make sure that's set correctly. So we've already got the variable defined up here, so we can use it down here again. So we have the email body, we're referencing it here. Once it's generated, we're referencing it. We don't need this anymore to demonstrate that. That's all there is to it. Once the HTML file here has been created without file, it will come down to the line 101 here, and then it will send off this email. I'm not going to show the email because I do not have an SMTP server in my demo environment. However, that's something that you will need to have in your environment. Most of the time, you have some kind of internal SMTP server that allows SMTP relay from an internal host. For example, this is where you would put this in here. In order to send email, you will need an SMTP server on the local machine that you're running the script from, or you can use some shared SMTP server with the SMTP allowed relay commands for your machine to relay through. Since you've made it this far, congratulations. You've completed the PowerShell and Active Directory Essentials course. Now, rather than reading off a summary of everything we covered, I thought it'd be more important to leave you with 3 important concepts for learning PowerShell in general. The first is that anything is possible. We covered a lot around PowerShell and how it interacts with AD, but we just barely scratched the surface as to what PowerShell is capable of. Due to its prevalence in the industry and flexibility, PowerShell can be used for just about anything. If you're not sure, just do some Googling around before starting on that next task. Next, just break stuff. Now, granted, don't break stuff in production. Get a nice test environment for that. I found that really just breaking stuff makes me learn the fastest. You're required to fix it, and during that process, you'll learn so much more than you would just simply viewing a course like this and following it verbatim. Go back through some of the course and deviate from my instructions. Break it, but figure out how to fix it. And finally, just be sure to apply these principles to a real-world task. I'm talking about not just using some of the examples I've provided in the course, but use your own. Take an existing process that you'd like to automate and figure out how to do it with PowerShell. Add metrics to the AD Health Check tool we built in the course. Just don't consider this all you need to know for PowerShell and AD. Get out there and explore.